Hello? Anybody hear me? That's like an echo. Going to you all or just me? A lot of echo. I don't know if I need this. Huh? Go ahead and start. I'd like to welcome everybody to Roanoke. Thanks for coming to our little hometown. I know with all the craziness, it's been, not the normal year with COVID, and traveling is not easy right now. So I appreciate everybody coming in and taking your time. I know everybody is extremely busy, and hopefully next few days you'll see some stuff you can take back and use and implement in your company. I guess it's probably the fifth or sixth symposium I've been involved with, and I finally said, well, I'll do it this year, and I'm kind of glad I did. What's wrong, Mom? It's bad? Better? What? I haven't been, they're trying to live stream it. So what we're doing with this, a little bit trial and error stuff, we are doing live streaming the event and trying to make it as virtual as we can. Granted, have a smaller group, so we're trying to open it up to many members to view it live and or to be able to go back and look at it on YouTube if you want to, as much as we can. I don't know what to do with this damn thing. It's better down low. All right, we'll figure it out at some point today. Still not good, Jenny? I just want to make sure they can hear. All right, I'll just hold my hand like this. So hopefully everybody had a good time last night. We've got some UAG staff here, and I guess click through this real quick. I'll give you a little rundown of our company, just so everybody has a little idea. We stole this from when we were at Gulkey, so was one of the best ones we had. Zach. Slide. So this is my family company. Here in the back is my mother, Winky, who started our company in 1977 along with her father and my father. We've been here in Roanoke. We started in a building about a mile down the road, and then around 88 or so we moved into this building, which, if you can't tell, was an old car dealership. So we've got a fair amount of space, more than most do, and we've tried to utilize it as best as we can. My grandfather, kind of our claim to fame, he built the pool at the White House and for Gerald Ford. He had a company in D.C. market, and a lot of you all are in family businesses, and I'm real proud to say that we're a third generation company. And of course, our biggest debate we have now is how do we go to the fourth generation and how well that's going to work. But we'll figure that out somehow. Got about 50 employees. We do retail, service, both residential and commercial service. Department when needed, does a lot of commercial service, and very, very good. He fixes everybody's problems for the most part. That's there. Got a younger brother, Austin, that's outside. He works in our new construction. He, likes to be in the field as much as he does in the office, and he kind of splits that time doing that. My wife, Jenny, She's kind of our retail manager. Does a lot of other things internally. All the furniture you see in here is kind of her stuff, along with the retail store. And then my sister-in-law, Mia, she runs our service department and that phase of work. And they both help, along with another lady, Bev, back here that does a lot of our infrastructure backbone that, I think all of us guys in here, necessarily know, or the people that are in the office or the core of the company, the financials are just as, if not more important than the actual going out in the field and doing the actual work, ordering, those kind of things. So glad we have a good team, and feel free to talk to them about, anything as we go through. Next. Go ahead, next. It's just companies that are here, so we got a good group. I think this is an old one. I didn't save the new one. Next. We have Shotcrete Association here today. Charles, that'll start us off. Pentair is going to do a presentation on the new DOE, code law that's going to be in effect as of July 2021. They're going to do that remotely, so it's going to be a little funky, but they couldn't, Mike Fowler couldn't be here today. And then we've got waterways this afternoon. We'll talk a little bit about, hydraulic jets, jet plumbing, some of that kind of stuff, hopefully at a higher level. And if it gets boring, let me know. We'll get to the good stuff. And then on Thursday, I've got GM, kind of talking, skewed a little bit more towards the renovation side. I'm trying to do this. We do a lot of our work in-house. We use subs very rarely, just because of where we're at. So, I'll try to make this symposium a little bit more, not necessarily hands-on, but do some live demos. So we'll go outside, see a little bit of dry mix shotcrete done. You may see a high PSI pressure washer that takes paint off that we have that some of you all may not have seen. Do the multi-coat demo and a plaster demo, just to kind of go through some stuff and some live stuff versus just all classroom stuff. We've got Wednesday will be the tour, or tomorrow will be the tour. We'll start kind of in here and have more of a discussion about how we build stuff, when it comes to forming, rebar, wall details. I think some stuff that we kind of sometimes leave out of our discussions or presentations, how people do stuff, I think is different. You've all got a reason, just a matter of why you do things a certain way. So go through today. In this room here, which is my CPO classroom, that's where we normally would be. I moved everybody out here just so we have more space. But in there, it's basically coffee, drinks, snacks, whatever you want. We'll have lunch that's in there. We'll do box lunches, sandwiches today. And then after we get done with class, we'll have a little happy hour if anybody wants to hang out before dinner, that kind of thing. In our break room one bathroom is there, and then if you go back through that sliding glass door, there's another men's and women's restroom there as well. Feel free to get up, do whatever you need to do during the day. I know people are busy, got phone calls, all that kind of good stuff. What? If you're a smoker, there's a bucket in the back, that kind of thing. Anything else missing? All right, real quick, let's just go around. If you'd introduce yourself, what company, kind of what you do for the company, just so we have a little idea. Try to always do this just so everybody kind of knows who we have in here and what else we do for that. Anything else? Yeah, I'm trying to help me remember, Josh. Yeah. You've been to as many of these as I have. What maybe what you like about the pool industry? What's your favorite part of it? How'd you get into it? Could be another topic. So we'll let Josh start.
All right. Hey, I'm Josh Agency from Charleston, South Carolina. Second generation, that's how I got into it. After college, I decided to give it a try. Never left. My role is in design and sales, but also, transitioning into the CEO of our company.
I'm Caitlin Center. I'm with Aqua and Pools. Joe D'Amico, also with Atkinson. Been working, I guess since the end of January. Came from residential construction and just enjoy completing a project within a good period of time and, seeing the success and kind of moving to the next one versus working on a home for a year. So it's been pretty rewarding.
Jane Merritt, Easley, South Carolina. I'm second generation, so I was born into this industry. We do a little bit of everything, from retail stores to delivery to maintenance, remodels, gun out pools. I guess the thing I like most about this is no 2 days are the exact same. So if you have a terrible day, the next one's probably not going to be that bad.
I am Mike Cherokee. I'm with Armand Pools. I'm the vice president, third generation, organic builder and a service provider outside of Philadelphia. Guess I got my hand in a little bit of everything, and that's about it.
Joel Molinari, Molinari Pools in Vero Beach, Florida. I'm second generation as well. Just recently transitioned into the CEO role. And we don't build, we do everything else. We don't have a retail store either, but so cleaning, repairs, and renovations. I'm here to learn from you guys about building stuff and see how different it is up here versus Florida, and if I want to dabble in that. But looking forward to the week.
Curtis Wright, I'm also with Molinari Pools. A lot of hats, but I would say currently it's probably focusing on project management and sales. And also as a member of senior leadership, we really focus on not just our clients, but the people that work for us too. So as far as creating those relationships and walking through stuff with people, it's a lot bigger than just pools. It's for the people that work for us as well. So I take a lot of pride in that.
Jeremy Lawson, Arkansas, luxury pool and spa. Third generation, born into the business. Graduated college and started cleaning pools for dad. But what I do day to day, I don't ever know. I don't know if I'm gonna have to fill in or I'm gonna be ordering things, but it is something that I enjoy. I do with my brother, and I guess the best part about it is it's finishing the job and seeing the people enjoy it. That's the best part.
My name is Michael Duran with J&M Pool Company. We're a full service and builder on the south side of Atlanta. And my brother and I started the company in 2009, so the first generation, kind of making it up as we go. But we come to all these, and I think Josh and Jason both have been very helpful in directing us and doing the right things. We try to build the best quality product around in our area. And I'd say the most fun part for us is actually doing, like we've got builders in our area, service providers in our area that have been doing it for 30 years, 40 years, and because we're new and kind of no one told us that this is how we were supposed to do it, we're bringing a lot of new things to the industry in our area and really exceeding a lot of people's expectations. So that's been fun.
Lauren?
Excuse me, Lauren Foster. I'm with Armand Pools. I'm with Mike Cherokee. Joined the company about 2 months ago, so kind of new to it. I'm a landscape architect. I've been in the industry for 20 years for design build companies, so been around pools my whole life, and excited to join the Armand team. I do sales, design, contracts, anything Mike asked me to do for the most part. So excited to be here and learn some stuff. So thank you for having me.
I'm Josh Moore, Burton Pools out of Fort Smith, Arkansas. I'm over the residential construction manager. Basically, I just oversee day-to-day operations of all our jobs that we got going on. Pretty much a full service store. We build, we service, do all kinds of things.
So I'm Bob Moore. This is all of our residential installations. The thing I like about the pool business, I think this is really important, is I think we provide a product that enriches family life. And we build pools for people that now, I built a pool for their parents, and they're adults now, and they're coming back going, hey, we loved our pool so much, all the memories around the pool. It's pretty important if you can do something like that, and we provide something that it really enriches family life, and I think that's a big deal for us, so that's what I like.
Mia.
Mia Vaughn,
Oh.
National Pools. I operate our residential and commercial service department. We've got about 10 crews, and we service about all of Virginia, some parts of West Virginia. So we travel a lot.
Mike Smith, I'm with National Pools. I've been here for 8 years. I primarily do all the startups, turnovers, and warranty.
Josh Hale, National Pools, been here almost 2 years in January. Do a lot of design, sales, help Jason with project management a little bit.
Joe Gaddis, Signature Pool out of Greenville, South Carolina. Been with them for almost 5 years now. I kind of oversee everything up until the start of construction, and then turn over our team for construction. So I just love the uniqueness of each project, and then it's something different every day. So being able to work with them and the clients and building something unique that not many people do. So it's an enjoyable experience. I look forward to seeing more and learning more for sure.
Paul Shaver, Signature Pools, work alongside Joe. I'm phase 1 project manager, get it through Shotcrete, so I ordered done in the beginning, and then get it through concrete, and just finished my 3rd year of Signature. And I love seeing the excitement on the customers' faces when we come out to start the project, and also when the project's finished, looking at all the pictures and being a part of something that you're proud of.
Matt Watson with Golke Pools in Denton, Texas. Yes, I got with upholstery, needed a job, my buddy got me a job. That's pretty much it. Been a hair technician for 12 years, and I just moved over to project manager, new construction in March, so got all this clear.
I'm Connor with Golke Pools in Denton, Texas. 3rd generation, so just been a part of the family, and I work in new pool sales.
April.
I'm April with UAG. I'm the event coordinator at the Go Program.
I'm Zach Johnson. I'm the IT director for UG. Been working there since January, and really like it a lot. And like being in the pool, hope you guys do your jobs better.
John Damaska with United Aqua Group. I do sales for new accounts in the Midwest and the Northeast. I also work very closely with vendors on pricing and programs. Been in the pool industry 33 years. What I like most about it are the relationships. I have relationships that started 33 years ago in this industry, and we're still here. And that to me is priceless. I really enjoy it.
Good.
Lee Vaughn, National Pools, 3rd generation pool builder. I think what I like most about my job is the history that we have, and learning accounts and customers my grandfather dealt with, and my father dealt with, and my mother dealt with, and trickle down and have some of a legacy. We have several departments across the business, as you'll see, and pretty diverse as far as our staff is concerned. I like to think that within the building, we can solve most any problem and get the job done. And we typically run after jobs that most people would run from. So look forward to talking to y'all and learning from you, and hopefully I have some stuff to share with you.
Good. All right, I'm going to bring up Charles with the American Shotcrete Association. You cue up that presentation, and we'll go through that.
Good morning. How is everybody? Are we getting some echo here? Sorry about that. We're not really a vendor. American Shotcrete Association is an association that's made to promote shotcrete. Everybody has been going through their history, so I'll give you a little bit of history of me. I started in the concrete business when I was 15, pulling nails out of formwork for a concrete construction company. After I graduated from high school, I was a concrete pro. Got some money and went to school. I got my engineering degree from the University of Florida. Anybody here from Tennessee? Georgia? That's good. And then I started with a small design build contracting company that built circular pre-stressed concrete tanks. And you all are in the pool industry. We built tanks that held from 100,000 gallons up to 20 million gallons of water. Give you an idea of the size. Up to 100 feet tall walls. These are cylindrical tanks, 100 feet tall, 350 feet in diameter, more than a football field. And we guaranteed these to be liquid tight. And the owner of the company, Ted Grom, came to me as a new engineer and said, you know what, you got your engineering degree, you got a master's degree, you don't know anything about shotcrete. We build our tanks out of shotcrete. And I'm going to send you in the field for another year, 2 years to learn about shotcrete, how to do shotcrete right. And I wish we could take all of our new engineers and put them out in the field to actually learn how to build things. I had some experience because I had worked in concrete before, but it was a great learning experience. And anybody here get involved in their shotcrete operations? So what's the first thing you do when you get on a shotcrete job? You're the new guy, the new kid on the block. What do? Shovel rebound. I shoveled rebound. I was on a gun in those days in the late 70s. We were doing dry mix in the old N-style guns. That's a dual chamber gun, not like the rotary guns now. So I was a gunman, I was a nozzleman, and I actually was a shotcrete foreman on projects. I only did up to 5 million gallon tanks, which were about 150 feet in diameter, 40 feet high. But I get a lot of people that come to me and say, well, shotcrete, that doesn't really hold water. And I can tell you that the tanks that we built, we guaranteed them to be liquid tight. And that's something that there's a lot of preconceived conceptions about the problems with shotcrete. And we're going to go through some things today. I hope that many of you who've been exposed to shotcrete pools, shotcrete shells, maybe have got some ideas about how it should perform, and we can change those ideas. You want to do the next slide? I'm used to having my remote. And I like to say shotcrete's kind of the original 3D printing. Has everybody heard of 3D printing? They're doing bridges and houses, and you know what? We've been doing it for 100 years. Next. Next. What is, and so anyway, I worked with a design build company doing these tanks for about 25 years. I worked with an international post-tensioning company, VSL, to do pre-stressed bridges, roadways, and I've consulted on my own. I worked with CTL Group. I don't know if any of you get into concrete consulting, but CTL Group. And about 5 years ago, I was very active in ASA, American Shotcrete Association, and we looked at getting an executive director who knew something about shotcrete, that could run the organization. So 5 years ago, I came on board as executive director and also technical director. But what do we do as ASA? Our vision is structures built or repaired with shotcrete process are accepted as equal or superior to cast concrete. Anybody here do form and pour concrete? So that's the industry standard, right? That's the way people built concrete buildings and walls, retaining walls for decades. Engineers are used to that. They put a spec out and they design for that. Shotcrete's a little different. We're going to go into some of the things that are different about shotcrete, but we have to raise the visibility and raise the quality of shotcrete so engineers, owners accept shotcrete as an equal. And how do we do that? Our mission as ASA to get out and give you the word, just like we're doing here today. We do it through education. We have certification for nozzlemen. We also have inspector certification now, networking and leadership. We really feel We are the International Trade Association promoting Shotcrete, both quality and breadth of application. Next. This is a video showing Shotcrete. Can you start that? We don't need the sound from the video. So this is a mock-up panel. This is a little bit heavier reinforcing than what you have in pools, but he's shooting wet mix Shotcrete. Kind of. And what we're doing, we're taking low slump concrete. This is already pre-mixed concrete, often out of a ready-mix truck. He's shooting it into a form and getting it to be zero slump. We're taking high velocity, consolidating in place. See the rocks coming down on the ground there? That's what we call rebound. When it hits that form, some of the coarse aggregate bounces out of the concrete. One of the cool things about Shotcrete is when you know what you're looking for, every square foot going in place, you can know that you have quality Shotcrete going in place. If you're the nozzleman, if you're the project manager, if you're a knowledgeable inspector, you can see that you're getting full encasement of the rebar. Why is the rebar in the concrete? Because the engineer wanted it there? Yeah, because that's the design. That's the way it carries the load. And the engineer expects that you're going to have full encasement of the concrete around that reinforcing bar. You don't see it slumping out, right? Now, if I just took concrete out of the back of the truck, it wouldn't hold up in that form. We have to depend on the high velocity to get compaction. And you might look at it and say, well, geez, that's really rough. What am I going to do with that? Well, it's a double-edged sword. Yeah, it's rough. Yeah, we have to finish it, but we can give it almost any kind of finish you want. You can leave a gun finish like that. That probably wouldn't work in your pools. But we can do a cut finish, leaves a few little, basically the flat surface, but a few little nooks and crannies. We can flash it to where we give a nice, almost sanded finish. We can do a steel trowel smooth finish. And that's one of the beauties of Shotcrete. And it also takes more labor, but we can do things with Shotcrete that cast in place really can't do. Next slide. What's the definition of Shotcrete? Concrete placed by high velocity pneumatic projection from a nozzle. Anybody have an idea when we say high velocity, how fast we're talking about? Any guesses? Miles per hour? What? 60 to 80 miles per hour. So think about it. You're driving down the freeway. It's a 60 mile per hour speed limit, so you're driving 80. And you hit a concrete column. That's the impact. That's the impact that we get with Shotcrete. That's how we can shoot it vertically. Pools, you're shooting vertically, but we can shoot overhead. We can have it stick overhead. That is the definition of Shotcrete: high velocity pneumatic projection and impact and consolidation. Next slide. And I get a lot of calls, well, what's the fire resistance of concrete? Or how much cover do I need on Shotcrete versus my concrete design? Shotcrete is concrete placement. It is concrete. It's a method of placing concrete. Next slide. And we're over 100 years old. Shotcrete started in 1907. Ready-mix trucks didn't start until 1914. Shotcrete was the way to do high-quality concrete in those old days. Now, I can come up to this job and I can see this guy in the 20s. He was shooting slope stabilization. I know it's not a pool, but I can tell you that that's bad quality Shotcrete going in place just by looking at the picture. Next slide. But we had, over the decades, evolved to get the quality, the placement qualities, the application, the materials. Here, this is the Panama Canal. Many of you have heard the term gunite, right? Anybody know what gunite is? That's what we call dry mix now, but it was sand and cement. I don't know if you can see in the back, but it says on the top of that rail car, cement gun. So the cement gun company was established to promote and certify crews that shot Shotcrete out of this dry mix gun that you have here. So that term, anything that was shot out of that gun was called gunite. It was a trade name. Next slide. Over the years, you have a dry mix gun like this. Anybody see a gun like that with the dual chambers? That's where I started shooting in the 70s. Actually very robust, higher production than what you get out of a lot of the current rotary guns like you have back here in the showroom. OSHA standards were a little different in the 20s, fall protection. But Shotcrete was used not only for structural concrete, but also corrosion protection. This Oregon City bridge, actually they had a lot of steel members that they used concrete, shotcreted in place to provide corrosion protection. Next slide. In 1951, ACI, American Concrete Institute, has anybody heard of ACI or ACI standards? I don't know if you get into those in design, but ACI has a lot of codes and standards that are written for design and construction of concrete structures. In 1951, ACI started writing documents about pneumatically placed mortar or concrete. And somebody said, wow, that's a real mouthful. Let's just call it Shotcrete. So they came up with Shotcrete. There was, in the 60s, an evolution to start using what we call now wet mix, where you have ready mix concrete, you're accelerating it and placing it. And so ACI had to come up with different terms for the wet mix versus the dry mix. So wet mix and dry mix was originally produced, not produced, but designated in 1966. Next slide. And here we are, dry mix today. This is very similar to the gun you have back there. Repair applications, we're getting a lot of pre-bagged mixtures. A lot of people in the pool industry are using volumetric mixers. You have mixers that you're going to see in the demo back here later today. Anybody here doing dry mix? Do you use volumetric or site batched? In the old days, we had a pile of sand, we had bags of cement, and we mixed it together, and that's what we shot.
Yeah, we get the sand in a truck and then cement.
And then you mix it.
It gets mixed there on site.
And people say, oh, well, that's not very sophisticated. But actually, I used to shoot a 1 part cement, 4 part sand mix when we did these tanks. We got concrete compressive brakes up to 10,000 PSI. When done properly, you can have very strong, low permeability concrete. But things that are same today, we have a nozzleman. The nozzleman is controlling the placement. We have air that's conveying it through the hose. Next slide. And here we have wet mix today. Most wet mix using small line pumps. They may have a discharge line 3 to 6 inch, typically down to 2 inch hose. Anybody here, I guess, anybody doing wet mix? Would assume. Are you doing it yourselves or you have a Shotcrete sub? So today, I think most of you aren't doing your own placement. So few are, but I'm going to give you some things to look for about quality Shotcrete that hopefully when you hire that Shotcrete sub, you know better what is going to be quality Shotcrete versus maybe not. And I will tell you, there's guys out there that have been shooting Shotcrete for 30 or 40 years. And they're not doing it right. They're not doing it as good as they could. So everything that you can do to get a better quality pool is good for not only you as a contractor or a company selling pools, but for the industry. And that's what I'm about, is quality Shotcrete in place. So here we have a line pump. And one of the neat things about Shotcrete is we're very mobile. And that's essential to you guys in the pool industry, right? And when I say guys, I mean figuratively, not... that we can get in, get the job started very quickly, get it placed, move off the job. Next slide. And this is what we compete against, form and pour versus Shotcrete. What are the differences? Form and pour, they have to build almost a structural wall to hold concrete pressure as you fill that concrete wall up with liquid concrete. What are we doing in Shotcrete? We have a form, we're basically just defining the back surface. And then we're building out the concrete section to where the final thickness will be. And the neat thing about that is not only are we doing a lot less form work, a lot less expense, but we can do these curves. And guess what? Pools aren't the rectangular cement pond in the backyard anymore, right? You got curves, you got these infinity edges. What's the tolerance on those infinity edges? Very, very tight. If you had an inch lower on one side versus the other, what's going to happen? Water's going to go over the low end, right? That's not going to, the owners, they're laughing like it might have actually happened on a job.
It's gonna look like crap.
Right. Next slide. And I talked about tanks. This is the pre-stressed tanks. I just threw this in here, so it's not in your book. I think the book does have most of the slides. But once again, we shot Shotcrete. We guaranteed it to be liquid tight. I have gotten calls saying, oh, well, dry mix is porous. It doesn't hold water. I have to have plaster to make it watertight. Is that true? No. Quality Shotcrete in place is essentially watertight. Next slide. And I'll just show you some of the pools. Here we're doing some steps. The neat thing about Shotcrete, you see this on the upper left, there's no straight lines. It's all curved. Next slide. Here you can see the pool, as well as rock features that were built out of Shotcrete. Next slide. And that previous slide, that pool was based on taking, these are out of North Carolina, a stream, and they wanted to model having a stream in their backyard. I think I heard a lot of you say, what was the best thing about building pools? Was that the owners at the end when they had something they really enjoyed. Next slide. And here you can see they basically carved the Shotcrete to look like rock. And this is probably more durable than what a lot of natural rock would be. I came out of Florida, we had limestone. Limestone was not very durable. Concrete, if you do it right, 50 to 100 years, maybe even longer. Next slide. Here you can see shooting. They're shooting dry mix here, and also the finishers working off scaffold, or not scaffold, but the ropes. Next slide. Here you can see going in place. Next slide. And a drone view. Could we do that with Shotcrete? Could we do that with cast in place? Probably not. Not very efficiently, not very effectively, not very durable. Next slide. And we can do straight lines, but we once again can do things with tight tolerances. If it's a remote area, getting in and not having to build all that formwork is a big plus. There's been pools where they added in the backyard. Backyard tapers off like a mountain. They had to bring the hoses in through the building, in through the house to get access to the backyard for the placement. With Shotcrete, as long as wherever we can get that hose is where we can place concrete. We don't have to have a crane lifting in a bucket or a big boom pump. We do it all with the hose. Next slide. Here you can see we do get fairly sophisticated formwork, but it's not heavy. It's not having to take that hydraulic pressure of liquid concrete. We're basically defining that back surface. Next slide. And one of the things we'll talk about later is the bond that we get with Shotcrete. You can see here, here's a floor wall joint. And when we have Shotcrete placement that's properly prepared substrate, we get excellent bond. We get essentially liquid tight joints, monolithic joints, when executed properly. And there have been cases where we did have to have against a cast in place wall. As long as we properly prepare that substrate, we can get a good bond. Next slide. Here you can see some of those infinity edges. Next slide. Just, we do, as American Shotcrete Association, have an annual Outstanding Project Awards. One of the categories is pool and recreational. So we have gotten a lot of submittals. Jason, I don't know if you guys have ever submitted, but you should. It closed yesterday, so it's too late for this year. But next slide. And here you can see this rock was all shotcreted in place as well as the rest of the pool. Next slide. Just to give you an idea of some of the other creative things we do with Shotcrete. Here you can see a skate park. Anybody here a skater? I guess Southeast doesn't have near the skaters I get when I go to California. Next slide. But why would Shotcrete be here? Because we got the curves. And we can actually finish it to very tight tolerances. If you were skaters, you would say, hey, you know, I don't want the humps and bumps. I don't want a speed bump like you guys got in your parking lot when I'm skating through a radius. Next slide. Here you can see this is actually a bowl that they're shooting. Once again, very tough to do that with cast in place. You'd have to build a form that's double curved with ties. Many times we can use a stay form where we actually shoot from both sides. We're using a form, an expanded mesh inside the wall itself to hold the shotcrete. Next slide. Here you can see they've finished it. Next slide. And the final skate park. Next slide. So I already gave you kind of a hint about the two processes, right? Dry mix and wet mix. What's the other term, the old term for dry mix? Gunite. And we still see gunite a lot. There's a lot of pool companies that have gunite in the name. There's, I see $1 million mansions. The big feature is they have a gunite pool, and they're like, okay, if that sells the house, that's cool. But nowadays we call it dry mix shotcrete. And what we are doing, do you have a laser pointer? Laser pointer? I got a manual pointer. So you can see up at the top of the slide, we have a shotcrete gun that's being fed by, in this case, a pre-dampener because there's pre-bagged materials. You'll see out there they have a mixer where they're actually mixing the materials, dropping it into the gun. The gun then takes air, so we need a volume of air to push the material through the material hose out to the nozzle. And then at the nozzle, we add water. Next slide. And this is a gun that I shot on back in the 70s. Very robust, high production, but very difficult to operate. And nobody here has been on one of these, right? Because if you did, you would see the gunman is actually doing a dance of opening valves, closing valves, releasing air. It's really a much more difficult gun to operate. Next slide. But this is what we typically see now for, not the one on the left, but on the right is a bowl gun, similar to what you have back here and similar to what they have outside. These are easier to operate. They basically put dry material into the hopper, then they use air volume of flow to push it through the material hose. Next slide. And if there's any questions as we go along, feel free to ask. This is an open forum. I'm going to have some things towards the end to maybe challenge some of your preconceived notions about shotcrete. But if you have questions as we go along, feel free to ask. Yeah?
Why are we not calling it gunite anymore?
Because gunite is a trade name. And actually, if you go and do a Google search on gunite, it's a brake company has a trade name gunite for part of their brake pads. So it's, okay. So a lot of people still call it gunite, but when we go and write documents, standards, whether it's a code or a standard, we can't use trade names. And so that's why ACI in 1951 came up with the term shotcrete. And then in the 66, they had dry mix and shotcrete to differentiate between the two. All right? So this is another type. Oh, okay. Can you guys see that in the back? Can you see it on the video? So this is another type. This is a rotary barrel gun. A little bit higher production. A little bit harder, not harder to operate, but a little bit more maintenance associated with it because it has two wear plates. But because the discharge is right out the bottom, 90-degree angles, it tends to have better discharge rates than what you get in a bowl gun. Next slide. And this is where we make concrete. This is the nozzle. This is kind of like the nozzle. You're going to see the ham nozzle out there. We have a material hose. That's the hose that runs to the gun, right? Are you using a 2-inch out there? Probably 2-inch. internal diameter. So it's a rubber hose, and the material flows through, and then it hits this piece right here. It's what we call the water ring. That's the place where we inject water at high pressure into relatively dry concrete materials, all right? So we add the water, and then we get a lot of turbulence. We have it narrow and then wide and then narrow, so the Venturi effect. There's some ridges on the inside of some of the nozzles, and we actually get some mixing when it hits the wall or hits the receiving substrate because of that impact, right? So we're driving water into that concrete mix. And we've shown over the decades that we get excellent mixing of the water. We don't have, with the proper application techniques and the proper equipment, we don't have a lot of dry spots or areas where the concrete's not mixed, the concrete materials aren't mixed with water. Next slide. I keep wanting to advance the slides. And we do like to see pre-dampeners, especially with pre-bag materials. Pre-bag materials, it's bone dry. Maybe not quite like that bag of concrete mix you get at Home Depot that you do your mailbox and half of it's already hard. But most of it that you buy is bone dry. If it was wet, it would be hardened in the bag. So what happens with that very, very dry material is you get a lot of dust. And so we recommend having pre-dampeners, give it a little bit of moisture, and really it's equivalent to what we had. You have your sand supply, pile of sand. Most sand supply is not bone dry, right? You're getting it from your ready-mix supplier or whatever. It's got some moisture content. And so we're just really modeling that with the pre-dampening system. It also helps to keep static down. I don't know, have you been a dry mix nozzleman that you get some static? And that electrical discharge when the hose is between your legs is a kind of a hazing event that we have for all nozzlemen. Next slide. And we also have some other variations where we actually put the water ring further back, about 10 feet back. This allows that mixture to see water a little bit earlier, get a little bit more mixing, and also help control dust. I don't think you have that. Your nozzle is right at the end. Next slide. And what is most critical is the water pressure. What's the water pressure out of most houses when you're in residential? Anybody know? Huh? About the pressure, 45 to 60 psi. And that's a good pressure. Some places I've been have a little bit less pressure. What's the air pressure out of an air compressor? Anybody know?
80 to 120.
Usually 100 to 120. So I'm blowing the material through the hose. 100, 120 psi. Can I take 45 psi water and inject it into that material stream? Probably not. Or you can't get a reliable flow. When I walk up on a job and I see dry mix and the nozzleman's continually wetting and drying because he can't tweak in the actual setting for the water, almost always it's a result of not having adequate pressure. So dry mix, typically you need to have a water booster pump so you can get that pressure of water about 15 psi higher than the pressure that you have at the nozzle. Now I said what, 100, 120 psi out of the compressor? By the time it goes through the gun, material flow through the hose, gets to the nozzle, we're probably talking about 80 psi. So if you can get something like 95, 100 psi water pressure, you're usually good. Now, it's not to say you don't get water at 45 psi. You just don't get consistent to inject consistent water into that material stream. So that's something I always stress when we talk to new contractors looking at Shotcrete or inspectors. You know, be aware of your water pressure. Next slide. So just to refresh, 40 to 60 psi. Would be out of a hose bib. Maybe at a water plant would be a little bit higher, but generally not. So we'll use water booster pumps. Here you can see an air motor using it to boost the water pressure up, probably 90, 100 psi. Next slide. And this is what happens. So have you been on a seeing them shoot dry mix? And one of the neat things about Shotcrete, if it screws up, you can see that too. If you see a dry spot, what can you do? You can stop, cut it out, and reshoot it. But when you see sand lenses like this, it's usually an indication that either the nozzleman is not experienced or there's some issues with water pressure. Next slide. Wet mix is the other process. Once again, this was started in the 50s and 60s. Before that time, we didn't have really reliable pumps to push concrete, low slump concrete through the hoses. So once we got pumps, and how many here do wet mix? So you probably have hydraulic, you have subs that come in and do it. Most of the wet mix Shotcrete contractors are using a small line pump that's dual hydraulic cylinders that basically push the water, the concrete through the hose. So that hose, this hose here is full of concrete. And then we add air from the air compressor at the nozzle. Next slide. And here, what are we doing? We're getting that high velocity. What's the velocity again? If you take anything away today, it's going to be high velocity, 60 to 80 miles per hour. I had a call, I did answer technical inquiries. I had a call from an owner in Arizona on a pool. And we got to not walk in front of the speaker. She said, well, you know, the concrete got so hard they couldn't pump it, so they put it in a wheelbarrow and then they threw it with a shovel into the wall. Is that still Shotcrete? And the answer would be no. That's not high velocity. We depend on that high velocity for consolidation. Next slide. So here you can see this is actually an Australian wet mix pump. This is one of the first more reliable dual cylinder with a swing tube between that was introduced in Australia and then brought over to the US back in the 70s. Here you can, this is actually one in 82. Next slide. So what are we talking about? We have dual cylinders. So this hopper is full of concrete. One cylinder, you can see there's what we call an S tube or a swing tube. It's connected to this cylinder in the back. So it's pushing concrete through there while the other cylinder is pulling back. So they're always moving in opposite directions, all right? And this one's sucking concrete out of the hopper into the cylinder. When the stroke is done, the swing tube moves, and this one on the left will push concrete into the delivery line. Next slide. Yeah.
I've seen videos that surge a lot. I mean, what causes that?
Yeah. Go back a slide. Can you go back with your bagel? Don't drop it on the computer. So not that far. So this is a swing tube, all right? What happens when that tube is physically swinging? There's no concrete going through. And so you will see in wet mix, the nozzleman, he'll be placing Shotcrete, and then there'll be a little lull. And the nozzleman will actually learn, this is the stroke rate, and this is when I'm going to get a little break. And so they'll be able to adjust their stance for the placement. But that's what the surge is, the swing tube moving from one cylinder to the other.
So like the video you showed, it was little surge in comparison to some that I've seen.
The other surge that happens, it should not be surging like that. One other issue is if the pump operator or concrete truck delivery guy lets the hopper go down and you suck air into the line, then what happens, that air gets compressed with concrete back behind it because they had it, and then that comes through as a really almost explosive surge, can be an explosive surge at the nozzle. So that's something the pump operator really needs to pay attention to. But the stroke should be relatively smooth. Go next slide. And we have pumps now that are designed for Shotcrete operations. They're smaller line pumps, but they're high pressures. When you talk about pressure, air compressor was 100, 125 PSI. With wet mix pumps, we're getting up to 2,000 PSI. And okay, PSI, what's a PS? Think of 2,000 PSI. What is that? What's a car weigh? Let's say 3,000 pounds. So I take 2/3 of a car and put it on a square inch. I draw this little square inch on the table, 2,000 pounds, 2/3 of a car weight. That's the kind of pressure we have with wet mix. So when we go through our nozzleman certification, which National Pools has several certified nozzlemen, we talk about the safety issues, the fact that we're dealing with high pressures. It allows us to have higher productivity, higher production, but it does require some more attention to the safety. But these pumps are made for placing, basically pumping low slump concrete. I can't shoot a 6-inch slump. What would happen if I shot a 6-inch slump in a vertical wall? It's not going to stay there. We typically do what, 2 to 3 inch, heavily congested reinforcing, maybe where you got a spa coming into a pool wall, you got a lot of reinforcing steel. Maybe you're going to go to a 4-inch slump. But we're taking that low slump once again and making it 0 slump when we get it in place. Next slide. Variety of nozzles. The nozzle you'll see out there in the demo is a ham nozzle, kind of like that sketch we had. But actually, most wet mix, and I'm confusing, the nozzle you'll see is the dry mix. So most wet mix nozzles are the tapered like this, where typically a 2-inch diameter hose comes through and then next down to about 1.25 inches. So what are we getting? We're not only accelerating it with air, we're accelerating it because it goes from that 2-inch diameter to 1.25 inches. These are used underground on robotic equipment. You're not going to see that for pools. Almost all of them will be like this. Next slide. So go back a slide though. One thing, you guys are hiring a Shotcrete sub, right? So there are nozzlemen who will say, hey, I can cut the end off this. Remember I said it went from 2 inches to 1.25 inches? And they'll say, oh, well, I get better production. What dictates the production rate? How much concrete goes through that hose? Anybody have a guess? It's the pumping rate, right? Those hydraulic cylinders. It's not what's happening at the nozzle. All they're doing is reducing the back thrust that they have to tolerate and reducing velocity. What are we getting with velocity in Shotcrete? That's how we get consolidation. That's how we get quality. So always watch and don't let your nozzleman be cutting off those tips because you're reducing velocity, you're reducing quality in place. Next slide. Air compressors, standard air compressors. One thing, dry mix takes more air, typically 500 CFM or greater. How big are you guys using?
Rolling it now, I guess,
950? So typically 500 CFM or greater. When I shot, we used 2.5-inch hose with an 1100 CFM compressor. That thing sucked up diesel like it was going out of style, but we also drove the air motor that was on the gun. We drove the scaffold. We had scaffolds that could go around the tanks that were driven by air motors. So typically you need 500 CFM, that's cubic feet per minute out of the compressor. If you have a dry mix guy, he shows up to the job with a 185, he's not going to get the velocity. He's not going to be able to have enough airflow to convey the, maybe he'll go through, but he's not going to get the velocity. The velocity is what's key to getting consolidation and quality Shotcrete. Wet mix, typically the minimum would be 185. And we like to say that at least 200 CFM. The more air, the better, because what's airflow giving us on a Shotcrete job? It's giving you velocity, which gives you compaction, which gives you quality, which means lower permeability, longer durability. All these things work together. Next slide. So once again, it says 375. Typically, we like to see 500 CFM or greater. 375 would really be the bare minimum. But we do have in dry mix, I don't know, you're probably using a 2-inch hose, but there are some applications where they're using an 1.5-inch hose. So the smaller hose, you can get by with a smaller compressor. But most of the guys out there today are using a 2-inch hose or greater. Next slide. And then wet mix, 200 to 375. Now, In some structural applications, we may use a blowpipe to control some of the rebound, and that's going to take some air. So it's not unusual to see a contractor, good shotcrete contractor with wet mix going up to almost a 500 CFM. Next slide. And we have to have clean, dry air. If the air has oil in it, where's the oil going to go? It's going to go in the concrete. Do you think oil and concrete should go together? No, it's not good for the concrete. And it needs to be relatively dry. Next slide. So I get this all the time. Which is better, wet or dry? Any ideas? Anybody have an opinion? I have had calls. Oh, well, dry, it's really porous. It's always wet mix is always the best. And then I have wet mix. Well, they're always having to worry about the concrete supply. It really depends on the contractor. National Pools, they're experienced in dry mix. Their nozzleman know dry mix. The nozzleman knows he's controlling the water at the nozzle to do it right. Those of you using shotcrete subs that are wet mix, those guys are experienced. If they're certified, ACI certified nozzlemen, they're certified in the process and the orientation. And I mentioned before the dry mix, when I shot just a standard 1 to 4 cement to or sand mix, we could get 10,000 PSI. So you can get equivalent strengths, equivalent low permeabilities that give you the long-term durability in your pool structures or concrete structures. So it depends on the contractor. Both will give you good quality shotcrete in place. Next slide. But comparing the two, probably the big lower volume. It's about 1/4 the placement rate with dry mix versus wet mix. And why is that? Well, they both have 2 inch hose, right? But most of the hoses in dry mix is full of air because we're blowing the through the hose. In wet mix, that hose is full of concrete. Because the wet mix is already mixed concrete, a lot of times with ready mix truck, they may use volumetric trucks to mix wet mix on site, but because it's had more time to be exposed to the water, it generally is less dust, a little bit less rebound. And if you get a commercial job, I know most of you, does anybody here do commercial pools? So you get specs where the engineer says, hey, I want a water cement ratio or something. Wet mix, you can get it on the delivery ticket. You can look and it says, yeah, I got a 0.42 water cement ratio. Dry mix, we can't do that. Where are we controlling the water in dry mix? At the nozzle. That nozzleman, he's got that water valve. He can make it too wet, he can make it too dry. Now, I get it, and I had to sell this to ACI 318. This is the building code requirements for structural concrete. And they're like, well, we need to have a water cement ratio. And I said, well, I can't give that to you because the dry mix that's controlled at the nozzle. One thing we can tell you though, is that dry mix tends to have less water because we're just adding water right as it's mixed, right as it goes out of the nozzle. So that allows us to have a lower water cement ratio than wet mix. Wet mix, we have to add a little bit more water because we have to pump it. Have you ever been on the wet mix job with your sub and they have a plug? It's a hard thing. So they have to have some more water to be able to give it the pumpability. So this is a key here. It's not so much maybe in the pool business, especially new pools, but in, say you're doing a repair job in a pool, an old pool, and you've got some areas that are deteriorated, you can start and stop very easily with dry mix. With wet mix, if I ordered 5 yards of concrete sitting in the truck, can it sit there for 3 hours? Probably not. So that's some of the benefits of dry mix. You can start and stop. You can get pretty high production rates. How many, do you have any idea, cubic yards?
I mean, our production rate is relatively low. I mean, compared to what most people in this room see doing a day, we probably shoot maybe 15, 20 yards max in a day.
In a day? There are some pool contractors with dry mix with a volumetric rig. Dry mix gun on the back, shoot 3 pools a day. Now, I have to work on them because I have some qualms about the quality, but they have the potential of doing quality shotcrete work, even though they run from 7 a.m. to 10 at night in the summertime. Next slide. Surface prep. We like to dampen the surfaces. Now, this is not this is a soil nail wall. So, have you ever seen concrete? And this might be a floor of a pool or even just a patio deck. Hot, sunny, dry day, and you get those cracks right in the top surface. Those are what we call early age plastic shrinkage cracks. It's evaporation of water in the concrete right at the surface. If I'm shooting against a bone dry substrate, what's it going to do? It's going to try to suck some of that water out of the concrete mix, right? It's going to be that same type of effect on the backside of your concrete that you don't see, all right? But if you create cracks in the back, if you get some cracking in the wall down the road, where's it going to crack? It'll probably crack where there's an existing little bit of crack in the back. So we like to have, against a soil substrate, dampening. If we're shooting against concrete in a repair application, we definitely want to have the substrate dampened so that it enhances the bond we get with shotcrete. Next. Form work, once again, we can do very intricate forms. We just needed the single side. So these are plywood, but we can bend. I've seen pegboard. I've seen masonite. I've seen the stay forms, just an expanded mesh. You put it in, you can shoot from both sides. You can finish both sides of it. So we have a lot of flexibility of things we can do with shotcrete. What's the pressure, though? I said, what, 60 to 80 miles per hour, right? The actual load against the form is about 90 to 100 pounds. And if I'm shooting right here, that part of the wall doesn't see it, right? It's just very localized. If I have a cast-in-place wall and I'm casting concrete, it flows against that whole wall, right? We got that pressure the entire wall, and that's why that formwork is so much more stout. Actually, a lot of times, maybe you don't run into it in pools because you have relatively low heights, but wind load. Many people doing commercial work will design it for wind load because that's something, they don't want the form to blow over before they can shotcrete against it. We do want the formwork to be relatively rigid so it's not vibrating a lot, but we can do that pretty easily. Next slide. So here you can see, once again, we can come in, very easy to do the curved work. We do want to have our reinforcing be relatively rigid so it's not vibrating as we're shooting against it. Next slide. So this is not true just of shotcrete. Shotcrete's concrete, right? You don't want to have the rebar covered with mud, covered with oil. You want it to be relatively clean. Now, is it okay to have rust on a rebar? Yeah, except when that rust is actually pitting the steel. Because if it starts to pit the steel, what have you done? You've taken some of that cross-sectional area away. With shotcrete, we do like to have the laps not be contact lap splices. Can I use the board?
Yes.
And what do we mean? So here's the rebar, and you got a lap. Usually you tie the two together, right? But if I'm shotcreting from this direction, and these are number 4 bars, that's 1 inch that I have to encase, right? But if I take these 2 bars and I separate them by a couple inches, then all I have to do is encase the individual single rebar. Much easier to get my wrap of shotcrete around that bar with a single bar rather than a double bar. Now this can be done. Takes more experienced nozzlemen, takes more control of the mixture sometimes, but it does allow you to make it more foolproof. When I design tanks, I try to always make them as foolproof as possible. I could take my engineering design, I could say, oh, well, I need 4 different spacings of resteel as I go through this deck. But then I would say, well, you know, are they really going to do that in the field? They're going to keep the number 5 spacing and 4 spacing all separate. I often would go to the bigger bar, consistent spacing, so I could just have one spacing, one size bar throughout a section. Yeah, a little bit more reinforcing steel. Wasn't tweaked down to the bare amount of steel, but it made it easier to get it done in the field correctly. Next slide. And why do we want the steel to be rigid? So as we're shooting, if I'm shooting here, I don't vibrate the bars where I shot previously, because it can actually kind of wallow around, create a void around the rebar. Next slide. Here you can see, what do we have? Here's the rebar. I guess I can use this. And a void. So basically they were shooting, it was not rigid, and it kind of vibrated and sloughed the concrete out below. This can also happen in taller walls where they're shooting the lifts a little bit too quickly. The load from the subsequent lifts push down on the plastic shotcrete and can create a void like that. Next slide. So when I go for that non-contact lap splice, we like to see a minimum of 2 inches or 3 times the bar diameter. I guess most pools you're probably talking number 4 bars, maybe sometimes number 5. Commercial might be a little bit more. 3 times the maximum aggregate size. In Shotcrete, we typically limit our aggregate to about 3/8 inch. I was an nozzleman. I could tell you, I don't want 1.5 inch rock hitting and bouncing back and hitting me in the face. The other thing is, I got a 2-inch hose. If I'm trying to push 1.5 inch rock through a 2-inch hose, that's got a lot more potential to plug. So we have a rule of thumb that we'd like to keep our maximum aggregate size 1/3 the diameter of the hose. So that's why we say 3/8 of an inch is typical. That means you nominally get a 1/2 inch. You guys aren't placing wet mix, but you get a ready mix truck, the last load, had 1.5 inch rock, and they didn't quite clean it out quite as well as they needed to. And you'll get that big aggregate actually come through the hose. So we do like to keep the aggregate size down to 3/8 of an inch. Next slide. Oh, go back. One thing, if you do have an engineer, and this may be a commercial job, not your residential, but if the other option you can do is, instead of having them top to bottom, the engineer says, yeah, I want that contact lap splice. Sorry, I'm standing in front. Do it front to back. So we still then have, if it's a number 4 bar, we're only shooting around a 1/2 inch instead of that 1 inch. Next slide. Now this is not so much, well, this will be applicable to new construction as well as repair. You mentioned that you guys do repair of concrete pools. We want that substrate to be rough. We want it to be clean. And then we want the surface to be brought to saturated surface dry. That terminology, SSD, is pretty common. What are we doing? We're filling the pores of concrete. Now, people say, oh, concrete, it's really dense. What are you talking about, pores? There are pores. You have a concrete driveway, and it rains, and there's a puddle. That puddle goes away, right? It kind of soaks into the concrete. It doesn't flow through. We don't get flow through good quality concrete, but there are some small pores that get filled. We like those to be filled with water. The surface doesn't have running water. It's just wet, damp to the touch, but no water on your hand. And that is what gives us such good bond with Shotcrete. Next slide. And never use a bonding agent. You may not actually see these in pools, but a lot of engineers think, oh, well, where I have hard concrete and new concrete, I have to use a bonding agent. Of course, the chemical guys are selling that bonding agent. You need to have that. But actually, for us, it interferes with the bond. It can be a bond breaker. The best bond we get in Shotcrete is when we can have that saturated surface dry, roughened surface. And what are we doing? You think about it. We're driving concrete at that surface 60 to 80 miles per hour. We're driving the paste into the interface. Next slide. And what are we trying to do? We're trying to get intimate contact. Old concrete here, with new concrete. And I said, this is repair, but also it might be new construction. What if you've cast your floor and you're going to do a wall? And that wall comes down to the concrete that you cast. You want good bond there, right? You want that joint to be liquid tight.
And we pour off all of our floors. Not all, but probably 95% of the floors we pour, and we're mainly shooting walls.
Yeah, and I actually recommend that. If I'm shooting down horizontal, I can't control my rebound as well as if I have a vertical wall. Because what happens, a vertical wall, remember that video? The rocks were bouncing off? They were going down to the ground. You could actually scoop them up. You can get them out of there. With wet mix, typically you have a pump. You can go ahead and pump your floors and vibrate and actually do it probably as quick or quicker than you would with shotcreting it in place.
The only issue with that, on the wet mix side, you won't be able to shoot the whole shell on that. Because it's trying to that balance of
Won't be able to what?
shoot the whole shell in one day, which is what most of these wet mix guys are wanting to do, is to get in and get out and get through it.
Right, because you want the floor to set up.
In on a typical pool,
Right.
get on out. Whereas for us, we got one day where we pour the floor, then we do a little bit more prep work. Sometimes on the vertical walls, and we come back and actually shoot the walls after.
Well, I think one of the keys you mentioned there is prep work. You have to pay attention to the details. If you don't do it right, it's going to leak. Now, you may not do a tightness test in tanks, and we always had tightness tests. We had to basically prove that it was going to be watertight over 3 days. But you have to make sure, once again, that joint, if we're coming in at a floor wall joint, it's roughened. So when you cast it, you roughen that area right at the base of the wall. You clean it, maybe a pressure washer that next day or 2 days, however long you come back to clean that, and shoot it. Then you get a saturated surface dry. Those are the 3 things. They're simple things, but you skip any one of them, you're going to have a poor performing joint. Next slide.
The hardest thing I've ever had to do is to convince an engineer that it's not a cold joint.
I'm going to talk about cold joints, and I didn't even prompt him for that. I talked to DOTs, Department of Transportation's, those guys. Whatever worked 50 years ago is going to work today. And they will always say, oh, well, you always get cold joints, right? What's a cold joint? Cold joints where I was casting concrete and the next truck got delayed or the plant broke down, and when I got my concrete, I couldn't vibrate it into that previous lift, all right? So that's a cold joint. We can't get intermingling of the new concrete with the previously cast concrete. Next slide. Next, should actually highlight. Next slide. So to preclude intermingling and bonding of the material, that's a cold joint. Next slide. But what are we doing with shotcrete? We have high energy, the high velocity, right? 60, 80 miles per hour. You probably haven't stood in front of a material stream coming out at 60, 80 miles per hour, but it's like you're sandblasting that surface, right? So you're exposing really fresh, hardened concrete to the new concrete paste. Next slide. And remember the video? How those rocks were bouncing off at the beginning when they hit against the form? Well, what stays behind in concrete if some of the rocks bounce out? What's concrete? Cement, water, that's paste, right? And then you got sand, and you got rock. If I let some of the rock come out, I'm leaving a very paste-rich environment right at that interface, whether it's a floor wall joint or it's a repair or we're coming in bonding a patch to an existing concrete substrate. So we get a very well compacted high paste content. Next slide. And that's what gives us the bond. Concrete gets hard by hydration. That means that cement particles actually grow almost like magic crystals. They interlock, and we encourage that interlock then at the surface between the existing concrete or the existing layer that was placed and the second layer. That's one of the cool things we can do in shotcrete. We don't have to shoot if I have now you don't do 3-foot thick walls, but I had a a subway system in New York, 3-foot thick, number 11 bars. What's 11? That's an inch and 3/8 diameter bar, spaced 6 inches apart in 3 layers. That's not a pool. But we shot that with Shotcrete. But we didn't shoot it all at one time. We put up the first layer of steel. We shot into where the second layer would go up, placed the second layer of steel, shot out to the third, and then placed the third layer, shot out to the final surface. That way we're only shooting through 1 layer of steel. We could pay attention. We could get that velocity, that wrap of the material around the bar. Because it was Shotcrete, it acts monolithically. There aren't any cold joints. But I can walk up on a job. Have you ever, dry mix, walked up on a job and seen something like this? Where there's buildup on the face of the bar, it looks dry, there's voids behind, versus a job like this, a nice sheen, we can see the deformations on the face of the bar. This, I can walk up and tell you that that's going to be good quality Shotcrete. This is not. And it's immediately obvious. In dry mix, when you have dry spots, you immediately know it's dry, right? Next slide. And I swear I see these YouTube videos. Have anybody watched YouTube videos of shotcreting pools? The guy stands in the middle and just kind of waves it around. And he's maybe 6, 8 feet away. Yeah, he's getting concrete out there, but do you think he's getting high velocity? No. Typically with both dry mix and wet mix, we need to be about 3 feet away from the receiving surface to get that velocity. And also, you need to be at a 90-degree angle. You're not going to wave it around. Remember I talked about the 1920s soil, they were doing soil stabilization. That guy was standing there and shooting out at about a 30-degree angle. There's no way he was getting velocity consolidation of the concrete. The other thing here, he's shooting up here. Where's the rebound going? It goes down, right? Gravity pulls it down. It's down here. Is that the good quality concrete we're looking for? No. Do you think they're going to clean that out? Probably not. Next slide. When you do get construction joints, one of the things about Shotcrete, if you're shooting in November or December and then all of a sudden it gets cold, you say, oh man, I'm going to have to come back in March because of the weather. We can prepare a construction joint to allow us to come in and build that monolithically when we come back. It may be after the weekend. It may be after 3 months. As long as we properly prepare, you can see it's roughened. We're going to clean it when we get ready to shoot, bring the surface to saturated surface dry. Next slide. Yeah. All right. As long as everybody comes back. All right. As long as you give me an hour and a half that you promised.
Stop the clock, stop the clock.
Yeah, it's like a football game. There's like 6 minutes of action.
I probably should give them a break after the introductions.
All right.
We've been hour and a half, I guess. No, I mean, we're
Wanna go ahead?
Go ahead.
All right. So a lot of times the pools, it's free form. You don't need close control of the curves. Remember the skate parks? They pretty well did those with templates. However, you get a competition pool where you need really straight walls, whatever. We do have alignment control. If you get a commercial pool where there's an engineer who's inspecting, and the inspector will say, hey, I need 1.5 inches of cover. You can actually have this wire, you can measure the cover. Then when you're shooting this, you actually finish, you shoot just past the wire, the finisher is cut to the wire, and then you cut the wire out. Next slide.
Anybody else use pencil rod? Know what pencil rod is?
Pencil rod is, it's not in this picture, but it actually is used for curved shapes. You can bend it to follow the shape that you need. I mentioned the skate parks, they'll actually cut a lot of times a template that will give them.
We use pencil rod for any curved pool we do. You know, basically instead of a shooting wire, like most everybody here is accustomed to on a straight pool.
Right.
Pencil rod, we basically, off of our kickers, put a piece of 3/8 steel, you know, out, and then essentially shoot that in elevation wise, and then tie a piece of pencil rod to it, and that's what you shoot to, and that's what you cut to make your finish, you know, corner on the top edge of the pool.
Pencil rod is just maybe 1/8 of an inch diameter steel, and it's easy to bend. Do you reuse them then?
Sometimes. As soon as they get a kink in them, they're hard to.
Yeah, right. So Shotcrete is concrete. We follow ACI recommendations. ACI 306 is cold weather concreting. We have a rule of thumb though, if the temperature is 40 degrees and falling, we stop shooting. That allows the concrete to build up enough strength to tolerate a freeze-thaw cycle. Anybody here have cast concrete that's frozen? If you do, you have to tear it out. It'll never build up strength. You don't want to have frozen concrete. So 40 degrees and falling unless you take special precautions. We do have people up in the northeast part of the US who shoot into December. They'll put blankets on it. They'll put heaters on it, knowing that they have to protect that shotcrete. Next.
Question. So I've heard some different stuff about that. And typically what I believe is the first night is not as critical as the second night on your temperature as a result of concrete having some heat.
Yeah, concrete has heat of hydration. However, the concrete is weaker the first night versus the second. As long as, and shotcrete, we generally have a lot of paste to begin with. So we generally have pretty good strength that first night, and it's pretty easy to get the 500 PSI. That 500 PSI is good for one freeze-thaw cycle. So if you went down to 32, you put your hand on the concrete, it's going to feel warm already, still warm. So you're probably okay. But if it's going to drop to 10 degrees, then you're probably going to want to have thinking about some additional protection for that first night.
And the wind, that has an effect as well, is that correct?
Well, wind creates evaporation. Evaporation reduces temperature, so you'd want to cover it if you could. Once again, the heat of hydration, I can't give you a fixed number for 6 inches of concrete versus 12 inches. Thicker the section, the more heat it generates, but typically your walls, what are you, 8 inches thick?
I mean, anybody here probably doing anywhere between 8 inches and 12 inches.
Right. So there is some residual heat. If it just went down to 32, you're probably fine. If you're going down in the teens that first night, you may want to have some protection. In the summertime, we talk about not applying it when it's 100 degrees or higher unless you take special precautions. And it's not so much damaging the concrete, it's the fact that when you have really high temperatures, you get more evaporation. It's going to tend to dry out that surface, and what happens when you dry that surface of fresh concrete? Cracks. Is that what you said? Yeah. That early age plastic shrinkage cracks, which can be mitigated by a fogging nozzle, kind of putting some water, moisture on that surface. But just you have to take some special precautions. And your concrete mixtures, if you're working in Arizona or Florida. Was anybody here from Florida? Yeah, you know, It's hard to not have 95 degrees in the summertime. Maybe not 100, but most of your ready mix suppliers will use ice in their concrete mix to keep that mix temperature down so it has some room to not exceed 90 to 95 degrees at the delivery temperature. Next slide. Wind is another thing. What's the biggest problem with wind? High rates of evaporation. Evaporations can cause more cracking. Once again, that can be mitigated by getting fogging, misting nozzles, maybe a pressure washer with a fogging nozzle on it to get moisture on that surface to prevent the cracking. It can, really high winds separate the shotcrete stream, not so much in in wet mix as it is in dry mix. Dry mix, we're just adding water right at the nozzle, so it might tend to separate the material stream a little bit, but you have to have a pretty good stream of water or of wind perpendicular to your material stream to really create much separation. And at that point, you're probably worried more about overspray or rebound getting in areas where you're going to be shooting. Next slide. What's that? Yeah. I found when I was out in the field shooting shotcrete sticks really well to Cadillacs, BMWs, the boss's new pickup truck. And I have clean, anybody here clean concrete off vehicles? Yeah, fun. We don't want to shoot in the rain. Why? That's going to basically dilute the concrete. We're going to raise that water cement ratio. It's going to be weaker. It's not what we need to be doing for quality shotcrete or concrete. We're not going to shoot in ponded or running water. Now, maybe you have some water in the bottom of the pool and you're shooting the floor. Maybe you actually make that a little thicker. You put a first course of shotcrete to kind of stabilize, what we used to call mud slab, to stabilize that and then build your structural section on top of that. Next slide. I don't know, the pool industry, are you worried at all about sustainability? Does an architect want LEED? Okay, so they'll talk about using recycled materials like fly ash, recycled aggregates, but we have a lot of things with shotcrete that give us sustainability. We're cutting the formwork in half, less than half, because it's lighter form to begin with. More efficient sections. I mentioned those tanks. We could do a 4-inch thick wall at the top, 16 at the bottom if that's what needed. Continuous taper, very easy to do with shotcrete. Reduced equipment needs, once again, very small line pumps or dry mix gun. So we don't have to have a big 52-meter pump to do our walls. Flexible access and schedule. You can get in, remember that pool that was on the back side of somebody's house on the back of a mountain. You can get in very easily wherever you can get that nozzle. And usually, though we cast, or we place concrete a little bit slower than cast in place, because we can start quickly, we can get done quicker, a lot of times there are time savings on a job. We get better bond if we're in a repair situation. Next slide. And shotcrete's one of the most sophisticated concretes out there now. If I'm shooting in New York City, maybe not a residential pool, but I can't get concrete in 2 hours. Theoretically, you're supposed to use concrete within 90 minutes of adding water. So we have hydration control, puts the concrete to sleep. We have super plasticizers to allow us to reduce the water but still get flowability, pumpability. We use microsilica, that's to make it stickier and reduce permeability. Oh, bless you. We use fibers. Anybody use fibers in your shotcrete mix? A lot of times microfibers are really good in like a wet mix because they'll help control some of the early age plastic shrinkage cracks. And you don't use this in pools, but we do have rapid set accelerators where we can get almost instant set of concrete in place, used a lot underground or for repair applications where it's very time critical. Next slide.
What does silica fume do?
Silica fume is a very tiny particle. It's a recycled material. And remember I said concrete has pores that we fill the water? Well, the silica fume, such a small particle, when it hydrates, it kind of fills the pores in between the concrete or the cement that's been hydrating. So it reduces permeability, increases strength. It adds to adhesion and cohesion. So if I'm shooting a repair overhead or a general wall, I can have it stick easier and do thicker sections. Disadvantage of silica fume is that it is very thirsty material. It'll soak up water, so you have to get curing water on it very quickly. Typical, I'm not going to go into the details of concrete mix, but if you have an engineer or specification, we typically are 0.30 to 0.45 water cement ratio. That's the weight of water divided by the weight of cementitious materials. And that's what a lot of engineers, if they have a specification, they may specify either a strength or a water cement ratio. But these are very good numbers for doing liquid tight concrete. Next slide. We use standard Portland cement. Typically it's 1-2. In fact, most cement plants now have a blended, a type 1-2 that will meet the specifications of type 2, 90% of the cement used. 3 is high early strength. We don't use that because we get high early strength to begin with. And 5 is a sulfate resistant, typically not in a pool. But it is something we use in wastewater treatment or soils. Do you get any sulfates in your soils? Anybody here from Texas? Texas, I think you have some sulfates in the soil. I know in the West Coast, Arizona, California, there's sulfates. They attack the concrete, and that's why you might have a different type of cement. Next slide. So we already talked a little bit about silica fume. We also use fly ash. That's out of the coal-fired power plants. They collect the fly ash. It's a recycled material. We also have ground granulated blast furnace slag, now abbreviated as slag. It gives us lower permeability, which means that there's better durability, more resistance to sulfate. Anybody here do saltwater pools? Are they increasing or decreasing? Increasing?
It's flat where we're at. It's
Yeah.
pretty popular. We don't do a lot of soft stone.
Okay. Well, that has more chloride, so the idea is that if you can reduce that permeability, you're going to have better resistance to those chlorides getting back to your steel that can cause corrosion. Next slide. And this is fly ash. Why would I like fly ash? If I'm pumping wet mix through a small hose, these things act like little ball bearings. So you may have a shotcrete contractor who says, hey, I really want to use fly ash. The other thing about fly ash, it does slow the set. So in the summertime, it gives you more time to work on that final surface. Next slide. So we get lower heat, which means it has lower time to set, lower permeability. Once again, it's filling those pores between the cement grains. It does gain strength a little bit more slowly, but interestingly, at a year, it's stronger than normal cements. And it is a recycled material. Next slide.
How much more time is that giving you, putting that in?
It depends. If it's the summer, it might give you like 30 minutes. If it's winter, I might not want to use fly ash because it won't set up like I really want it to. So slag is another one. It used to be called ground granulated blast furnace slag. It does make it a little stickier. It's a different color. You can see slag cement versus Portland. That's not so much an issue with pools because generally you put some kind of coating like a plaster or pebble tech, something on your final surface. Next slide. So these are the two most common. They're actually now blended cements. You may get it if you're doing dry mix. Some of these cements are already blended with fly ash, so you'll get it delivered to you as a Portland cement with fly ash or Portland cement with slag. Just something to watch out for. You can have up to 25% of replacement of cement with fly ash. Slag, theoretically, you can go to 50%. You can take out 50% of the cement, replace it with slag. Next slide. So this is, I already talked about silica fume. Small particle here versus a cement just basically fills the pores. Next slide. It does improve the adhesion and cohesive, which means thicker layers. Here you can see they've built up this like beehive. There's no reinforcing in there. They just built up that thickness overhead against gravity. And because it's stickier, it does reduce rebound. Somebody had a question about rebound. Hey, what do I need to do for estimating shotcrete quantities? the concrete used. We typically get 5, maybe 10% rebound in wet mix. So your actual concrete in place is 95% of what you estimated. Dry mix might be 10, 15%. Depends on the nozzleman, depends if you're using pre-dampening. There's some factors there. We're getting some more advanced nozzles where we're actually controlling or adding water. I showed you hydromix, but other ways. So we're reducing that rebound, trying to get closer to where we are with wet mix. Next slide. So once again, silica fume, higher compressive flexural strengths, reduced permeability. That means you have more time for chlorides. If you have a saltwater pool, chlorides getting through that concrete to attack the steel. Next slide. So it is very thirsty. That can lead to more plastic shrinkage cracks. So if you do have a mix that they're using silica fume, the shotcrete contractor probably needs a fogging nozzle on a pressure washer to give some more moisture right at the surface. Next slide. So what are we looking for in a quality pool? Strength. I keep talking about compressive strength, right? Functionally watertight. Now, I mentioned that concrete has pores, right? A little bit of water gets in there, but it doesn't flow through. I could do a cast-in-place wall, not pre-stressed, 35, 40 feet high. I can go put my hand on the wall. It doesn't feel wet. There's not water coming through, even though it's full of water on the other side. And maybe you as a contractor aren't so interested about durability, but that owner sure is, right? They don't want to have a pool that 5 years they have to have Jason come in and repair. They want to have it durable. They want to have to not have any maintenance associated with the concrete shell. Next slide. So how do we get strength? Water cementitious ratio. We talked about a 0.3, 0.45 is the max. Interestingly, shotcrete's self-controlling. If you have too much water in it, at too high a slump, it won't stick vertically. It'll slump out of the wall section, or it won't stick overhead. And the paste is whatever fills in between the aggregate. Next slide. So just talking about water cement ratio, here you can see these are the same amount of cementitious materials, but all we're doing is changing the amount of water. So here's a 0.35. 7 days, we're getting a little over 4,000 psi. If I went to a 0.45, I'm only getting about 3,600. So I've increased that strength by reducing the water. If I went to a floor slab, 0.55, less than 3,000 psi, and corresponding strengths at 28 days. Next slide. So for our shotcrete materials, typically a 0.45 is about the most that we'll have in wet mix. I used to work with the pool contractor, say, hey, let's design a 0.42. If you need to add a little bit more water, you know you have some reserve water that you can use on this job site. Next slide. 4,000 psi. This is what ASA says should be the minimum compressive strength of shotcrete. Anybody here deal with pools where it's less than that?
I've been trying to be sold by gunning contractors 3,000 PSI.
One of the things, compressive strength is how strong is the concrete against compression, all right? And 4,000 PSI, that's a pretty good strength. But ultimately, strength is pretty easy to get. What we want to get is good flow of paste around the bars. Remember I showed you that when it was too dry, build up on the face of the bar, it wouldn't wrap around the bar. Well, you have to have enough paste content to do that. I've had people say, oh, well, you only need 2,500 PSI. Well, maybe structurally that's true. But to get good wrap of concrete, to prevent voids back behind the bars, you can't use a mix that has that much sand in it and get enough paste to get quality shotcrete. I think if you use the 4,000 PSI, it almost always will assure that you're getting enough paste to get good consolidation around your reinforcing bars. Next slide. So these are the things that I think you need for functional water tightness, the 4,000 PSI minimum. And honestly, most of our mixes are getting 4,000 at 7 days rather than 28 days. This water cement ratio, 0.35 to 0.45. And that gives us adequate paste to encase the reinforcing steel. Next slide. So I don't know if you've seen this, but 1 gallon of water in a cubic yard will increase your slump. Anybody not know what slump is? That's how the concrete will, you put it in a cone and you rod it and you take the cone off and how far it slumps down from the total height. So if we add a gallon, we increase the slump by 1 inch, but we reduce the compressive strength by 200 PSI. It increases permeability, reduces durability. What are we looking at getting in our Shotcrete pool shells? We want reduced permeability, not increased. We want increased durability, not reduced. Next slide. Mentioned before, we do like to, this is just a gradation of the sand and rock that is in our Shotcrete. We have 2 gradations, one just with sand, the other with some coarse aggregate, typically with that 3/8 inch nominal size. Next slide. And for pumping, we like to have a well-graded distribution. That if we have uniform or gap graded, you'll see that the Shotcrete contractors will have problems pumping that mix. With a well-graded distribution, one of the other things is we have big particles, medium size, small, so we have smaller voids. What fills the voids between our sand and rock in a concrete mix? The cement paste. What's the most expensive part of your concrete mix? The cement paste. So the well-graded mixes will actually improve pumpability and give you better economy. Next slide. Air and training. Now, I would say in Virginia, you probably get a lot of freeze-thaw cycles where they want to have entrained air. This is something they learned. If we can introduce these small little air bubbles in concrete, it's much more resistant to freeze-thaw damage. Anybody ever see freeze-thaw damage on concrete? Have you seen like a flat section where it just kind of has gotten real punky on the top? It kind of works its way down from the top. It's because water's in the concrete, freezes. What happens when water freezes? Expands, and it breaks that concrete apart. Now, if you put these little bubbles in air and training, it allows that concrete to be more resistant to the stresses of that expansion. Negative effects of air is that it reduces compressive strength a little bit. But typically, Shotcrete, we're so paste rich, we have a lot of strength to begin with. The other benefit of air is that it improves pumpability. So if you have a really harsh mix with your wet mix, you can add air to it. And we may actually add 10% air. And you say, wow, that's way, you know, engineers say 4 to 6% air is needed for freeze-thaw durability. But what happens with Shotcrete is we're impacting 60, 80 miles per hour. What do you think happens to the air? We knock out half the air. Typically, it's the entrapped air, like a bubble like this that comes in ready-mix concrete to begin with. But, and we leave the small bubbles, and the small bubbles are what are the freeze-thaw durability. And that's not true just the pool, but your pool decks. If you get involved in doing pool decks, that's probably even more so because you got a horizontal surface that can get saturated, and so freeze-thaw durability is probably a good thing for you in areas with a lot of freeze-thaw cycles. Next slide. So we do significantly reduce the entrapped air. That's the bigger bubbles, but we keep the small ones. And I mentioned before, we may use higher dosages to increase pumpability. You can think those small little bubbles, that actually kind of helps reduce the friction of the concrete inside the Shotcrete hose. Next slide. And why air and training? Here you can see air and trained, 300 cycles in the test lab. Here it is non-air and trained. It just works its way down from the surface, and here it's exposed the fiber and the aggregates. And typically 3 to 4%, if you go into Canada, 3 to 4% air. A lot of US engineers will say 4 to 6%. What we want to do is keep the small bubbles. So if we're at that 3% air with the small bubbles, we're good. So you might see a shotcrete contractor, if the commercial job says, hey, I want 4% air, they may go to 8% to know that they're going to lose that in place. Next slide. We use fibers, probably not so many in pools, but these microsynthetic fibers really help to control that plastic shrinkage cracks right on the surface. And then we do have structural fibers used more in structural work, the macrosynthetic and steel fibers. Having shot steel fibers as a nozzleman, I can tell you they're not fun. They stick in you like a porcupine. Mentioned you don't want rocks to bounce at you. The fibers, steel fibers, are even worse. Next slide. So here you can see microfiber. It's a thin diameter, short fiber, a maximum of about an inch, a little over an inch long. It just gets well distributed. You can think if the concrete tries to crack at the surface, you got all these little fibers in there, it's kind of holding it together, right? And so it will tend to reduce that crack width that might be at the surface. And it's not overly expensive to add those to the concrete mix. Next slide. Commercial pool, you're not going to get this in residential, but if you have a complicated reinforcing section, the engineer may ask you to do a mock-up. This is not a pool, obviously. You can see the size of the bars in this. These were all shotcreted. People think, oh, well, shotcrete, you can't do anything but wire mesh or number 3, number 4 bars. We've, once again, done number 11 bars, fairly tight spacing with the proper materials, equipment, and placement techniques. Next slide. So on the mock-up panels, if it is a commercial job, they may have you shoot with the mix, the reinforcing that's going to be used on the project, and the nozzleman and equipment that will be used. And we have an ACI document to allow the engineer to basically evaluate the quality of the shotcrete placement. Next slide. Next slide. So what do we do for QA, QC? Plastic shotcrete, the age of the concrete, the air temperature, the temperature as delivered. One of the things we can do visually, though, we can see sags or reinforcing encapsulation. That can be judged when you know what you're looking for. You can see that going in place. Line, grade, and cover, that could be the pencil rods or shooting wires. There may be templates if you're using a template to, say, get a consistent radius on a cove. And then the finish and tolerance. Next slide. And then hardened shotcrete compressive strength is what most engineers look for. We don't typically in residential or most commercial use flexural or toughness. Some engineers do like to test permeability, but these are more the commercial, the DOTs, or structural engineer. Next slide. Here you can see this is a mock-up panel, not a whole lot of steel, but they had this big embed that they had to shoot around, and this is actually 2 nozzlemen. They're going to be tested. They can actually sit this up where there's a panel between to grade the 2 nozzlemen. Next slide. Shotcrete, we do test. Do you guys do test panels for your pools?
Some on commercial jobs, but
All right.
in all reality, they're so damn big that most people don't take them to do much with them because you can't move them.
Right.
I mean, and you're not just doing core.
Yeah.
I mean, I've got one that's sitting outside from a job last year that we left there, and the testing, people didn't take it because they didn't want it.
Yeah. Test panels are typically, if it's ACI, 16 by 16 by 5.5. If it's ASTM, it's 24 by 24 by 3.5. So they are heavy, several hundred pounds. But why do we shoot panels? We shoot panels. Have you been on a wet mix job where the casting, where they poured concrete into a cylinder? That's the way the ready mix plants usually make sure that you're getting this compressive strength out of the concrete. What happens if I have a 6 by 12 cylinder and I try to shoot into it? It's going to trap air. It's not going to be representative. So we do a panel so that air can come out. We just leave the deposited material behind. So I was involved in a litigation, and it was a pool contractor, and they had issues with strength. But they had called the ready mix plant and said, well, just send me a Shotcrete mix. They didn't give them any specs. They didn't say, hey, I want 4,000 PSI, or I want certain water cement ratio. And the concrete supplier sent them whatever they felt like they could give them. It pumped, but they didn't meet the strength. So it is something, if you are ordering concrete, your Shotcrete subs may be doing that. If it's a commercial job, you might have a spec on it. Get involved with your concrete supplier to make sure you get that 4,000 PSI that gives you low water cement ratio and the slump you want. Because some of these suppliers may tend to short you. If you don't ask for it, they won't give you the strength, the cement. Next slide.
Anybody here having their stuff tested? Anybody had their shot, I mean, a lot of subs were using, like, I know when we, first time we used a sub, I had them shoot a panel so I could pour it and actually prove that they're giving me what they said.
Yeah, I mean, you're paying.
On rigs, I mean,
You're paying for that concrete, right? So you should be getting that. Once again, that 4,000 PSI is the minimum 28-day strength you should be shooting for. And how do you get it? You don't get it by just looking at it. It all looks like gray concrete when it's in place, right? So you do it by the panel test. And good Shotcrete contractors should be well aware that they can shoot panels and have those cored for compressive strength. Good shooting practices, we always want to shoot corners first because that's where rebound could accumulate. The repair job, then we'll shoot in the middle. Next slide. And this is why we need to have 4,000 PSI. We have to have enough paste. This is good quality encasement on the left. This is bad. I have enough velocity. It's keeping the face of the bar clean. This is against a form. Here's a rebar. So the material's coming from the left to the right. And you see a little bit of accumulation back behind the bar. Can you see that in the back? If we have it too dry, it won't wrap around. We have to have that flowability of the paste. And why does it flow around the back? Because we have air pressure out here. It's kind of pushing it around the back. A little bit lower pressure here. Material building up there on each side. Then as we're shooting, there's more paste. We actually get a little bit of a ridge back behind, and those two will meet, and we'll get full encasement of the bar. And here you can see we've shotcreted. This is a number, these are certification panels, so that's probably a number 8 bar. That's an inch diameter. And you'll be able to see the face of the reinforcing until that bar is encased. If I walk up on a job and I don't see the deformations, it means I don't have enough velocity. I don't have enough pace to move that material around the back. So it's a combination of velocity and flowability of the paste. Next slide. We always want to be shooting at a 90-degree angle. I mentioned before the YouTube video, guy standing in the middle just waving it all around. Yeah, here I'm at 90 degrees, but here I'm 45 degrees. Why would we want to do 90 degrees? If I threw a baseball at 45 degrees, it's going to hit there and it's going to bounce. I don't have very good arms, so it won't go too far. Zach, you don't have to worry. But if I throw it at 90 degrees, it's going to hit, fall down. It transfers all that impact energy right into that wall. That's what we want, right? Impact energy. That's what's giving us consolidation. And also we want to stay 3 to 2 meters. That's 3 to 6 feet. Typically 3-4 feet is what we are looking at in most shotcrete placements. Once again, that's what gives us velocity. Next slide. Now, if you're doing a thicker wall, you remember here's the video where we're actually benching it from the bottom to the top. A lot of pools are done that way. We're actually shooting at a 45-degree angle to horizontal, but it's 90 degrees to the receiving substrate. Once again, maximum impact. Next slide. And here I can walk up. I can see the deformation on that bar when I walk up. I can see there's no voids behind. There's a slight sheen to the material. Next slide. And finishes. We can do anywhere from this natural gun finish to a cut finish to broom. We can carve it. We can have the carved rock. Next slide. This is probably what you're looking for in a lot of pools, right? Cut finish, where we got roughly the right thickness, but it gives you some areas, hopefully not too deep for plaster or your other finish to go on. This is becoming probably one of the most common. Next slide. But for exposed work, we do a float finish where we'll take that cut finish and then do a flash coat to actually be able to give almost like this kind of plaster wall finish that you get in your house. Or we can do a smooth trowel finish. I just did an inspection of a bridge. They smooth trowel finished it. That's what was required. How do we get the gloss in a smooth trowel finish? Water. So you work it, right? The guy's there with a trowel. He works it. He brings water to the surface. Higher water cement ratio, more permeability, less durability. It's actually decreasing the performance of that surface. It will also show cracks. It'll have more water, more evaporation potential, more potential for early age plastic shrinkage cracks. So we don't like to see steel trowel finish unless absolutely required. Next slide. And concrete needs to be cured. We recommend a 7 days wet cure in hot, dry, windy conditions, fogging or misting. Now this is something that in pools I see a lot of variation. What's the recommendation for you guys in curing? Jason, no. How do you cure?
We don't do as good a job as we should.
All right, well, I got a call from Arizona again. Oh yeah, the pool contractor told me to water the pool twice a day. So wet the surface twice a day. In Phoenix, Arizona, 115 degrees. How long do you think that surface stays wet? Seconds. Curing usually means continuously exposed to water. Water hydrates cement. It increases strength, reduces permeability. Curing is essential to getting what you're paying for in your concrete materials. Curing is not a four-letter word, though most contractors think it is. I was just in a bridge project in South Dakota, and they said, oh, well, we cured 3 days, and then we got cracks. So we went to 7 days, and we got less cracks. And then we went to 14 days, and we got less cracks. Well, that's the way the system goes. Curing helps give concrete additional strength, and as it gets stronger, it's more resistant to cracking. And most owners don't like cracks.
So we set a sprinkler out.
Right.
Sometimes that night, or what kind of duration should we, in theory, be?
Continuous.
Well, I get that. I mean, 5 days, 7 days.
7 days.
Possible.
ACI would recommend 7 days. It's not always possible. The more you can give it, the better. If you could put Visqueen up over it, wet it, put Visqueen so you keep some of that moisture at the surface, maybe that would help some of that curing.
Some of my buddies put burlap bags.
There's curing blankets, polypropylene with burlap on the underside. You wet the burlap and then it holds that water against the surface.
This may be a more technical question, but we use a colloidal silicate
Uh-huh.
as part of the waterproofing process, and we interrupt that in the 7 days. Is that a problem?
You interrupt what?
Like, so we usually within day two, we'll completely we'll put the silicate on the surface, and we interrupt it, and then we start back with the sprinkler.
Yeah, colloidal silica.
Or should we wait until after day 7?
Colloidal silicas are, just like I talked about silica fume, it's filling the pores, and some people are selling that as a curing compound.
Sure.
And what are you doing then? You're sealing the water that's already in the concrete. And you probably haven't used, but maybe a spray-on curing membrane. You've ever seen those on concrete? That just seals in the existing water. We already talked about we have low water cement ratios. So we have water. It's always better to give it more. If you're putting colloidal silica, you're basically sealing it off. So you could put more water, but it's not going to help.
Okay.
It's like you've put a seal on the surface.
So should we wait?
I would recommend waiting because you're going to get better strength, you're going to get lower permeability, which means better durability overall of that pool.
We've noticed that when we do the silicate, that we get what we call weepers, as everybody else does, but it identifies those areas like very quickly, and almost like like that turns that silicate just runs out of some of those areas, which is good, but it made me wonder if I was doing it way too soon.
Yeah, well, cement likes water. And when I say cement, whether it's silica fume, it's cement or silica fume or fly ash, all those use water to hydrate.
I mean, most of those manufacturers try to tell you to do it early.
Yeah, well, it's because a lot of people don't cure.
Yeah.
I think. I mean, I'm not a pool contractor, and I know there are people that will come in and shoot the pool and and they're off the job. They're there one day.
I mean, I think these, products that would be Shotcrete, Acron, have gotten a lot of traction in the pool industry. Although, I mean, of course, you talk to Drake Lee, he says shouldn't use it.
You don't need it. I mean, basically, if you water cure, you're going to provide the best strength gain of that concrete surface.
I think, but to your point is that it's not really about making it watertight as much as it is the after effects of like fluorescence and those types of problems.
Correct. I mean, it's a real catch where, bashing edges, raised walls, those type of things are what we in the pool industry have struggled with now.
Mm-hmm.
Is it material, is it technique, lots of, weather, curing, all the above that, we're always searching for. How do we remedy that? And once it's placed, there's not a whole hell of a lot you can do. That's, granted, ideally you want a perfect placement.
Oh,
Material, but
I tell the Shotcrete nozzleman, hey, I'm telling you all the things that would be perfect. I started out in the field. Construction is never perfect. There's always something that's going to happen. But if you know what you can do for the best quality, you know that goal of what you can achieve, then you can make decisions in the job. If I got concrete that's too old and I can't get it pumped, don't try to throw it in with a shovel. I have to be able to pump it. I have to be able to shotcrete it. If I can't cure, I know, okay, I'm going to get less strength. I'm going to get more cracking. So maybe I can get 3 days of cure. Maybe, I can get 4 or 5. 7 would be what we would consider the optimum.
Do you have a recommendation as far as for the water curing, as far as what would be a way that's better than another way?
In tanks, or those circular tanks, we used to put up a dripper hose right around the top of the wall and then have it basically drip down. I think somebody mentioned a sprinkler. A sprinkler, you put a rainbird inside, let it water. Generally, the floor can still tolerate water, accumulation of water. Burlap, we talked about burlap, so putting a coating that can hold moisture against the surface. Because once again, cement likes water to hydrate, gives it strength, lower permeability. Next slide. So here you can see, actually, this is what we call burline. It's plastic with burlap underneath. Here's the dripper hoses. Now, this is pretty ideal because it's at an angle. It can drip water behind, but we could actually put up the dripper hoses. We didn't cover it. We could see where water was getting. If it was not getting water in an area, this is just a plastic tube. PVC tube you can buy at Home Depot, and you just drill another hole to get water down there. And here you can see a fogging nozzle to give moisture at the surface to help prevent that early age plastic shrinkage cracks. Next. So we can do curing compounds. I don't think you're going to do it in pools because you usually put something else on the concrete, which means these would have to be stripped off by sandblasting, high pressure pressure wash. If you do use curing compound for some reason, we recommend twice the rate because what we're trying to do is seal in the water that's there, which you're trying to get with your colloidal silicas. Next. So what's substandard work? Delaminations, voids, rebound pockets. You should be able to see that. When you're knowledgeable about what to look for, you can say, I'm not paying, stop, cut it out, reshoot it. That is one of the big advantages of Shotcrete. You don't have to wait until you strip that form in 3 days and see a big rock pocket at the bottom. Next So if you have areas that are suspect, the easiest thing is hammer sounding. I was a forensic engineer. We had really sophisticated tools. I always started with hammer sounding because you can identify delaminations very easily. You just tap the surface. And if you have a lot of cracking in one area, that's the first thing I do. I come in, hammer sound, and see if there's a delam not too far down within that surface. Next slide. And these, if you get a big pool and you got some issues with voids, these are non-destructive things that can be done. GPR, some of you may be using. If people are doing coring, they're using GPR to find the rebar. Next slide. And we have ACI nozzleman certification. National has how many? 4 or 5 certified nozzlemen? Right. Next slide. Oh, it's always the 500 hours. That's the minimum hours of nozzle time required for a nozzleman to be ACI certified. Now, we do have a nozzleman in training category that's only 25 hours. And why do we have 25 hours? Because we want the guy to actually have picked up the nozzle, can hold the nozzle, not be blown over by the nozzle. So it's more a safety issue. But they can go through the full process with only 25 hours, get nozzleman in training, and then as they work on jobs, they collect their hours. When they get the 500, they submit it to us, and then they get upgraded to full certification. They have a full day of education. Like I'm giving you here an hour and a half plus. I can talk about Shotcrete for a full day very easily. I could probably do 2 days. That gives the nozzleman who may have learned on the job something that was wrong. They may have learned from the guy that did it for 30 years that's been doing it wrong for 30 years. We give them the right information to have quality, what makes quality concrete? What makes the right equipment? What's the right size air compressor? What do I need to do for placement in unusual situations? They have a written exam from ACI, an oral exam, and then they actually have a panel they shoot. Next slide. And they shoot a panel. This is probably more complicated than some pools. It has a number 4 bar vertical, a number 6, a number 8, and then 2 number 4s. And we grade them during shooting. Our examiners are all with decades of experience in Shotcrete. And then the following day, we come in and core and grade them on their ability to encase the reinforcing bar. Next slide. And it does make a difference. This is an experienced nozzleman, inexperienced. Picked up the nozzle, yeah, I can shoot Shotcrete. Some of you guys may be getting that from a Shotcrete contractor that's been shooting for 30 years but doing it wrong. We talk about high velocity, compaction, adequate paste content, strength. All these things have to work together to get quality Shotcrete. Next slide. And then we were going to do the International Pool Spa Patio, a full day seminar on quality Shotcrete, what to look for. It's our Shotcrete Inspector program. There's 40 visual clues that we go through. We're actually going to do that online. If anybody's interested, I can give you some information, but it's going to be in 3 2-hour segments online to allow you to get more information about Shotcrete, what to look for Shotcrete quality. Because if I was, you guys are hiring a Shotcrete sub, you should know what you're looking at. You're paying a lot of money to those guys to come do that work, right? So if you, as the GC on the pool, know what to look for, you can make them accountable. And if something's not right, fix it before it's set in concrete. It says it's near rollout. Actually, ACI now does have an exam. There's a written exam, but I think the main thing for you guys would be to look at the education, that full day education seminar. Next slide. So that's a lot of text. Basically, it goes through, we do some things regarding testing standards and all the DOTs and government agencies. We talk about reference materials, but the key is 40 visual clues that you can walk up on a Shotcrete job and know whether you're getting quality Shotcrete or not. Next slide. So this is the seminar, I think. I don't know, is this in the handout too? So how to recognize it when you see it. It's going to be the 4th, 5th, and 6th, 2 hours a day, because nobody wants to do a 6-hour webinar. I went through a 3.5 hour, and I'm like, wow, that's too long. We actually do 2 hours. We take a break at the 1 hour mark so that, you know, we give people a little bit more time. And so you can go to shotcrete.org if you want to sign up for that webinar. Next slide. We also have a contractor qualification. This is actually taking we have 2 categories, basic and advanced. Basic is more structural shotcrete. Basic is lightly reinforced, just vertical, no overhead. And we basically grade the contractors on 15 projects over at least 3 years on basic, 5 years on the advanced, on their ability to do quality shotcrete. And these are projects where we get the references. We call them, and it's by experienced members of ASA who know shotcrete. They can call and know the questions to ask. Most engineers don't know shotcrete. When I went to engineering school, they didn't teach shotcrete. So this is something that helps to provide qualification. If you wanted to hire a shotcrete sub, if they have ASA contractor qualification, you know that somebody has vetted their experience, their equipment, their crews, their ability to place quality shotcrete. And it also has a full-day education program. Next slide. Shotcrete.org. I told you the most important thing is high velocity to take back home with you. If you want a reference on shotcrete, go to shotcrete.org. We have position papers, and look at the pool and rec. We've seen that there's a void in the pool market for codes and standards. What are the standards in the industry to get quality watertight concrete shells? We talk about compressive strength. Why would we have the 4,000 PSI? Watertight shotcrete. That pool shell should be watertight. It's not the fact that you're adding plaster to make it watertight. Concrete will be functionally watertight. Forming and substrates, curing. And then our underground committee also has a couple position papers. These are available for free download as PDFs on our website. Next slide. So just remember shotcrete.org. The phone number, I think, in the handout is a little bit different, so that's the main office, but there's my direct line, and you can always send me an email, and I respond to technical inquiries all the time. Next slide. So, any questions? So I want to ask you guys some questions. Say you have a pool wall. Okay, it's designed, right? You got a pool drawings, and they're probably sealed by an engineer. And it says it's an 8-inch thick wall. But then you get there, and they over-excavated. You shoot 12 inches. Can you use the same steel? No. The amount of steel that you use should increase with the thickness of the wall. Pool industry, remember I talked about doing cast-in-place tanks? I did pre-stressed tanks, but also cast-in-place. If I had an 8-inch wall by ACI 350, which is a code for liquid-containing structures, I need number 5 bars horizontally at 8-inch spacing. Anybody do that in their pools? Why would we do that? Why would we add more steel? Because it provides crack control, enough control of the width of the cracks so that it doesn't leak. It only takes a 5 mil thickness of a crack to leak. 5 mils, that's a hair thickness. You have to walk up to the wall. You have to walk up about this close to the wall to even see a crack like that. Now in pools, most pools are in ground. Get a little bit of leakage out the backside, nobody knows. But that's something to look out for. We have a new document in ACI. We're working on a document for shotcrete pools, and hopefully we can raise some of the standards. Now, what kind of steel to use in an 8-inch thick wall? 4 is a 12. So that's 0.2 versus so you're basically half the steel that we would require by 350. How much more does it cost to put that much steel in, that per 350? Maybe we doubled the steel. is the cost of the steel really driving the total price of that tank or that pool? Maybe a little bit, but placing number 5 bars instead of number 4 bars, that incremental cost is pretty low, but you get a much more durable product.
What about double mats?
You can do double mats. So if you did double number 4's 0.2 square inches per bar, so you'd have 0.4, that would work.
What is the formula you're running?
0.5% of the cross-sectional area. So 0.005 times your width times 12 inches gives you how many square inches of steel you need per vertical foot. That's horizontal because we're typically horizontally, you don't have a lot of stress. All we have is shrinkage stresses. And that's what the 350 design is for, shrinkage. Because when we build tanks, most owners don't like an above ground tank to have that water coming out through cracks. So, and another question we already talked about was the compressive strength. If I have 2,500 PSI, it means I have less cement and I have more sand. In your case, are you using coarse aggregate in your dry mix?
Yes.
Yeah. So you have more aggregate, less cement, which means that you have less paste. Less paste means less ability of that paste to flow around the back, the flowability that we're looking for. So compressive strength is pretty easy to get, but the flowability of that paste is really what we're looking at with the 4,000 PSI. So anybody questions? I probably ran way over. So Shotcrete is a really creative way of placing concrete. We can do things that you can't do with cast in place. Quality-wise, we can do as well, if not better, than cast in place. I was a forensic engineer. I got called into jobs where they strip the forms. You guys haven't done cast in place, but they strip the form and they have a rock pocket. So how do they fix it? Oh, they got a guy out there with a bucket, a 5-gallon bucket, cement and water, grout, they slap it in there, it looks good. But when they fill that up with water, gee, why is all that water coming through the wall? And once again, with Shotcrete, you can see it going in place. Shotcrete is functionally watertight. And if you are getting cracks and leaks, one thing that we didn't cover was, and somebody asked me a question, when we're finishing the wall and you have the cuttings, is it okay for those to be used to make up the floor? No, because when you have cuttings, is it at high velocity? Is it being vibrated? No, it's just falling down there. It's just like you took concrete out of the back of the truck and put it on the ground. That's not good quality concrete. Should we use rebound? No. As a forensic engineer, I had a few pool projects where, I got all these cracks in the bench or the steps. I don't know what's going on. Well, it turned out, what did they do? They cut the walls, they threw that material up into the bench. That's crappy material. And you know what? They made it look good. They glossed over the top with some paste, but you could take the hammer and sound it. It was hollow. Same in coves. I've seen a lot of cracking in coves where people have just thrown it up into the cove. They're using that rebound and cuttings as concrete, and it's not the concrete that you want for fully impermeable, functionally impermeable shotcrete shell. Everybody's so quiet. At least nobody's snoring yet. That's good. So I got a call from once again an owner. They were complaining about cracks. And I said, well, did you watch them shooting the pool? Oh yeah, we watched. Did anything ever get shoveled out of the pool? No, nothing ever came out of the pool. So where did it go? Went in the floor, went in the coves, went in the bench. That's not the quality of shotcrete that we need. So curing, watering twice a day, that's not enough. Even if I'm up in Michigan, I'm out of Detroit, watering twice a day is not enough to give you good curing that reduces permeability, increases strength. And with that, I guess I'll be here for lunch if I have questions.
All right, thanks, Charles.
All right.
Hello, test, 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 test. Okay. Okay. Test 1, 2, 3, 4. Test 1, 2, 3, 4. All right, cool. Let me just stay on mute. Let me test that. You may hang up the phone. See if I hear you. Okay. Yes. Yeah, I got you. Well, they're just eating, right? Yeah. Oh, yeah. No, I can't hear anything. I did just a little bit in the background, but no, I'm fine. I'll just I guess if anybody had, we'll have a question time at the end. But if somebody that asked me something during the middle, try and yeah, Keith is there. Okay. 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 Yeah, that's fine. And we're going to answer the best we can. You know, this wasn't me doing this presentation, so we've been we'll do the best we can to get through. I think we'll be fine. We'll just we'll go from there. So I'm going to go ahead and since we're already hooked up, I won't disconnect anything. I'll just Can everybody hear me?
Can you hear me, Mike?
Yes, I can hear you.
You're good to go then.
All right. All right. Well, hello, everybody. Are we ready to start?
That would be a yes.
Okay, thanks. I can't hear too much in the background. So, anyway, welcome everybody. I want to thank Jason Vaughn and all the team at National Pools. I also want to thank Zach Johnson from UAG for his help. Sorry we can't be there in person today. My name is Mike Fowler. I'm one of our commercial sales managers and also a UAG main contact that I deal a lot with the internal group there at UAG, and I've been part of your working with your group for more than 20 years now. And it's great to be able to be here with you today. I hope you guys are enjoying your conference so far. I talked to Jason a little while ago. He said it was going pretty well. Also there in person, who I'm sure you've already met, we have Keith Phillip. Keith is our territory sales manager covering Southern Virginia and all North Carolina and the Myrtle Beach area for us. And I'm glad Keith was able to be there in person. Appreciate that, Keith. And hopefully he'll be able to get some time with everyone there. Again, I want to thank you guys for letting us take this time. Obviously, it's an awkward situation we're all in right now in this world. And just glad that you guys were able to get there and do this. So what we're going to talk about today, and Keith, just interrupt me if something comes up on any questions. There'll be a question period at the end. Hopefully some of you have heard about this. Obviously have heard about this this new regulation going into effect. I did want to ask or point out Jeff Farlow's name. The original plan was to have Jeff do this presentation for us. Unfortunately, he is involved in a webinar himself this afternoon with the DOE. So I'll explain more about that in a little bit. And so he was unavailable to do it. So we're going to do the best we can to get through this and present this to you. And then we'll have some resources that we will be emailing out to you as well as we go forward with this. And I'll give you some other information, other details that you guys can use to fully understand or pass on to customers even when you're having to explain to them why things have to change as of July 19th of next year. So with that, we'll go ahead and get started and kind of just go through this. So let's see if I can do this right. Okay, so basically what we're talking about today is many of you have heard, as we mentioned, this Department of Energy looking at pool pumps and looking at different regulation changes in regards to their performance and how we as a manufacturer and you as a dealer can sell these products going forward. This is perhaps one of the biggest regulation changes that we've seen in our industry, maybe since the VGBA thing back around 2007, 2008 time period. It's going to have a huge impact on the way we do business and also the way that pumps are sold into this marketplace and into the whole aquatics industry. It affects a lot of mostly residential, and I'll go in a little bit more detail later. It does affect commercial as well when you reference and talk about certain horsepowers, but we'll get to that point here a little bit later. So what we're really in this organization, this group, and I'll share with you a slide here shortly, that worked with the Department of Energy for the last couple of years on this new regulation, is really looking at what is now termed to be dedicated purpose pool pumps, which in a nutshell, they grouped in and they brought in-ground pool pumps, above-ground pumps, and pressure cleaner booster pumps. That's what the PCBP stands for. What we mean by that is that this, at the same time that this was going on in the aquatics and the pool industry, the industrial pump industry, and for those who have been involved, you think of large industrial sites, hazardous waste sites, HVAC system type pumps, that kind of thing. They have their own regulations that were going to happen and be adhered to in reference to this DOE changes going forward. The pool group and the aquatics industry was able to tackle and bring in and focus our pumps that are in this industry to what our best needs were and try and get those pushed through the DOE. And again, we'll explain a bit more what that means. So what does that mean? So basically what it comes down to is pool pumps that are manufactured manufactured for use and imported in the United States after July 19th, 2021 must meet minimum efficiency standards. The old thoughts of, service factors and horsepowers and different things are kind of going out the window. And we'll get into more detail on that too as well later. But it's more of a performance-based standard now, not technology specific. So again, you'll see later when we talk about service factors, et cetera, that are going to be going away, and the way it affects labeling, affects manufacturing, and the way things are tested. Existing pumps are allowed to remain. So anything that is in place right now does not have to be replaced with a variable speed pump. If it goes down after July 19th, 2021, then it would be. And I'll repeat this again later. If National Pools or some of you guys have single speed pumps in your inventory, and those are in your inventory as of July 19th, 2021, you can still sell those as long as they're in your inventory. That's not going to be affected by this. That was one of the things that got pushed through with this team, was that anything in distributor inventory or your own personal inventories that, in a sense, don't meet the new regulation can still be sold as long as you had them in your possession at the time. So that's something that was cleared up that is going to help all of you, I'm sure. As I mentioned, it does apply to both residential and commercial pumps. Usually up to 5 horsepower is what we're talking about. In this sum, there's a lot of small hotel, motel, apartment, condo pools that might be 5 horsepower and less. There's a key target that I kind of spelled out for Jason and Lee the other day that was confirmed by Jeff, that we're basically looking at anything that's 200 gallons a minute and at 50 feet ahead. Anything of that and above is going to be a pump that's not going to have to worry about this regulation. Also, this really affects single phase only. All 3-phase pumps are exempt from these new regulations. So that's where the commercial end isn't as impacted as the residential part is. So kind of to explain that further, if you have a single phase installation on a smaller hotel or community pool, whatever it is, say you have a 2 or 3 horsepower single speed, after July 19th of next year, if that pump fails, you will have to replace it with a variable speed pump. Service factors. Everyone knows and understands service factors on pumps. Usually you see anything from 1.5 to 1.85 or whatever it may be. That impacts the service factor, the actual performance of the motors. With this new regulation, that is all eliminated. So all the service factors, all the labeling that you is going to be set at 1.0. So it's all going to be based basically on true horsepower is what we're talking about in the performance of the motor. So what does that do for you guys that have kind of dealt with uprated and full rated pumps? That's all going away now. It's just basically going to be, this is what the motor can do. This is the true horsepower of the motor. So for our instance and other manufacturers as well, you won't see uprated pumps being manufactured any longer after July 19th. One of the things that does impact on the manufacturing side, again, is that we are not allowed, as Pentair and Hayward and Jandy and everybody else is going to be the same way. After July 19th of 2021, we no longer can manufacture any of the pumps that are not meeting this regulation, as long as they're within that window. Pumps have to be labeled, and we've already started doing this labeling change. Hopefully you've seen that in our literature, as well as some of the labeling on the pumps. They have to be labeled with what's called a WEF, which is a weighted energy factor, and also a total horsepower. Now, the total horsepower, again, kind of relates to the elimination of the service factor in that point going forward. 75% of the pump part numbers are going to go away. Those are just going to vanish because a lot of them aren't going to be able to deal with the regulation going forward. So that's kind of what you're going to see now. So why not sell variable speed now? Because single speed pumps are soon going to be illegal and not be able to be manufactured or sold by any of you. So again, this really significantly impacts our industry going forward. So where are we now in reference to this regulation and how we've come from the standpoint of hold on, I'm trying to move that. Hopefully nobody can see that. Where are we now in the transforming of this? Back in 2005 is where we first started seeing variable speed technology come into place, about 15 years ago. And it slowly developed, and a little bit more people got involved with it, about 30% in 2013. And in 2018, things started going a little bit more. So we're at a standpoint now where there's about 40% of the market penetration as it based in 2018 was at this Energy Star level or at these energy efficient levels. So for the first 15 years, it took that long to get 40% of the market penetration. And now we've got a year to basically work on the rest of it. So again, that July 19, 2021 date it's not going to change. It's set in stone, and that's what we all have to work towards as we go forward with this. We'll talk a little bit about incentives that are out there, rebates that are out there that have been a long time with power companies. Your local power company might have certain rebates for using variable speed technology, and some of those might go away after July of 2021 from the simple standpoint that these are going to be mandatory. You don't have to. It's not like I'm going to upgrade this because it's a good thing to do so I can get an energy rebate. They know you have to do this, so they may start taking some of those rebates away. But obviously, there's still a lot of advantage to going to the variable speed route. Oh, why isn't my screen working? Bear with me, sorry. There you go. So we talked about weighted energy factor, or WEF. Think of this as a way of just how much work over how much energy is pointed out. That's how this started. That's how this regulation started looking at it, and then the simple to do it. So think of it from your car, right? You can look at how many miles you drive as opposed to how many gallons you consumed in your car. That's kind of a thing, work over energy. So when you're looking at pool pumps, they kind of looked at it the same way. So how many gallons of water can you produce in a pump based upon how much kilowatt power you're using in energy? So in a sense, that's kind of where the guidelines are, kind of similar to kind of understand a little bit more what you're talking about in that reference. So in this, looking at the typical weighted energy factors that were out there, so single speed pumps, and this was a category they were looking at, and we'll talk a little bit more what qualifies as Energy Star in a sense. But typical single speed pumps in the production of this, you look at how many gallons per kilowatt usage on energy these things can run. So typically single speed pumps are anywhere from 1,000 to 3,000 gallons per kilowatt as far as energy goes, okay? Two-speed pumps, a little bit more, 5,000 to 7,000. And the variable speed pumps can produce anywhere from 5,000 to 12,000 gallons per kilowatt hour. And that's really where you see the additional, much more flow, 5 times more gallons for the same type of energy as single speed. Again, I mentioned earlier that there was a team of people that were involved in this. What they actually call themselves the Dedicated Purpose Pool Pump Negotiated Rulemaking Working Group. That sounds pretty impressive. Almost like the United Aqua Group sounds so impressive for your group. This is that's even a little bit more of a technical name here. But you can see in this list that there's a lot of people involved here across the aquatics industry. So you see, and Jeff Farlow, I want to point out, Jeff Farlow has been our leader in the energy initiative for more than 15 years now. He's been our main spokesman dealing with the Department of Energy, has been a leader in us getting our Energy Star certifications. So we really owe a lot to Jeff for not just his work within Pentair, but for the work that he's done with this team to help make sure that the aquatics industry is taken care of, that if we had to do this, that we're going to cover all the pumps that were there. So you can see across these 13 people, the big players, big manufacturers are all represented there between Pentair and Hayward and Waterway and Zodiac. We're all there, and we're part of this group. There's also a couple of the motor manufacturers that are involved there, and some other power players, Energy Commission people you see. So these people were tasked with developing what they felt was the best standards that they could present to the Department of Energy, and getting them to buy in on what they need to do to not just provide better performing pumps, but to protect the aquatics industry in general as well, and make sure that we got it, making sure it was the aquatics personnel that was going to negotiate this and form these codes rather than having someone outside the aquatics industry. So again, some new terms that you may have heard or may not heard in this, but this is kind of where you're looking at basically. So the first one is hydraulic horsepower, or you might refer to this in the presentation as HHP. So it's really directionally proportional to pump flow. What you got to think of this as the wetted end, the water end, of a pump, what that can produce horsepower wise. Not so much in dealing the motor itself, but the actual hydraulic horsepower of that water going through the pump is really what you're looking at. So this is a tested value as part of this regulation, where they're testing that to size pumps instead of rated horsepowers. Okay, so that's really what they wanted to look at and get at to. Total motor horsepower, again, going back to what I mentioned earlier about the service factors. Service factors are now out of the question. Everything will have a service factor of 1.0. So if it's a 3 horsepower motor, the total motor horsepower is going to be 3.0. Okay. You won't have that extra factor built into this as well. And again, this must be on the label. I'll show you a sample of a couple labels later that kind of increases that. Weighted energy factor, or WEF. And I mentioned you'll see this. I know a lot of our literature already has it. I'm sure the other guys' literature is starting to add it. It's a requirement that it has to be added into literature as well as labels. This is a lot of things that are based on gallons pumped by the power consumption of the pool, or the pool pump, excuse me. It's also used to compare different energy efficiencies of pumps, and the higher the better. So basically, there's certain things that are converting now. There's older things that are with literature being updated, and constant things you'll see being updated and converting over to these WEF factors. What was basically done in that thing, and looking at the energy factor here to a weighted energy factor, is in looking this curve, and you follow the green line is what you're looking at. When the version 1 of the Energy Star happened a few years back, they set a energy factor level of 3.8. That's what the black dotted line is across going horizontally. So you can see when we tested, this is one of the pumps that was tested. The peak efficiency point in that lied between 800 and 1,000 RPM is where it was. So basically anything setting above that dotted line was considered compliable through the Energy Star, and would also meet most of the real world conditions going forward here. To set this even further, what was done, this is just another example of a different curve that was produced in the same aspect of that. And this is more of a energy factor versus weighted energy factor in reference to that one. So in order to going back to the first curve I showed you, in order to kind of figure this out and come up with a weighted score for this weighted energy factor, you look at two different situations. You look at the first one where it says 24.7 GPM. So basically what they looked at was they set 25 GPM as kind of a minimum requirement that they would need for skimmers to work properly, as well as chlorinators and anything else you might have in the system. And then looking what the full capacity flow would be based on that curve at a given speed that would still keep it right about where that black dotted line would be. So in this case, you can see that 20% of the score was at high speed. 80% of the full flow of the pump was towards the end of the curve, but 20% of the score was based on that high speed. And 80% of the score that you give it is based on the lower flow, which again is about 25 GPM. So you can see how the range of that was in going this. Department of Energy, just to give you an example, the WEF score on the Department of Energy and Energy Star version 2, which came out a few years ago, is now 9.6. So that has ballooned up a little bit since the original 3.8 of a couple of years back. Equipment classes per se, per the DOE, you can't necessarily base classes in what you're talking about, classes we're talking about of motors and pumps, not just on applications any longer. These are basically, you can't say in-ground versus above ground or et cetera. There's really no difference in the requirements now between residential and commercial. It's all based on the regulation. It's got to be based on design or the physical features, performance characteristics that really take place in this thing. So if you look at the chart below, and obviously that's just the fun thing about above ground pump. So you wouldn't necessarily see a big CSP pump on a above ground pool. But what they basically looked at and did is trying to determine what are the dedicated purpose pool pumps within these regulations. You have what typically is your pool filter pump. So if you look at the green colors there underneath, you got your priming pool pumps, non-self-priming pool pumps, water feature pumps, and then, of course, the pressure cleaner booster pumps. There's a big umbrella of a variety of pumps, and they try to squeeze as many as possible in that category that we're going to be impacted by the regulations. Now, the other categories there represented in yellow, these little integral sand filter pool pumps or cartridge filter pool pumps that you see with a lot of these above ground kits, as well as storable electric spa pumps for fiberglass spas or portable spas that are sold now. Those don't have to worry about these regulations so much because they fall out of the typical dedicated purpose pool pump that the group filed in and brought in as part of this. So looking at the dedicated pool pumps with like minimum performance requirements and looking at the ways that we try to categorize this, and then the group tried to categorize this, is looking at self-priming pumps, which all of us would refer to as, let's say, in-ground pumps for pools. There's a small size, which would be less than the 0.711 hydraulic horsepower or something equal to maybe like 3/4 all the way up to maybe 1.2 horsepower, just a little over 1 horsepower. And that's total horsepower, remember now, taking out that service factor thing. We'll explain a little bit about EL2. That's just the different curves that you'll see here that was required by the regulations and as well as Energy Star that you had to hit. Larger size pumps would be greater than that 0.711 horsepower. So you're looking at things that are a little less than from a 1.2 horse all the way up to 5, in a sense, total horsepower pumps with a minimum allowable of the EL6 level, which is the top line, and that's variable speed. And that's all based upon what today's technology is. Technology changes rapidly. So we may be having a different conversation, 5 years from now. But right now, this is where things kind of lie and breaking down those performance requirements. And of course, remember, this is single phase only. 3-phase are exempt from this, no matter what the horsepower is. 3-phase is exempt from these regulations. And then you have your non-self-priming pumps that are basically your above-ground pumps, let's say, or as we said it here the regulation was kind of set. Priming is defined as a minimum of 5 feet in 10 minutes. So if that's the case and they don't meet that, then the above ground pumps, in a sense, are part of the energy performing regulations, but not as detailed as what they would refer to as self-priming or in-ground. And then, of course, your pressure cleaner booster pumps, minimum allowable, have to meet at least the EL1, and they can still be single speed with a medium efficient motor, as well as the smaller above ground pumps can too. Waterfall pumps. These are things that still are considered and brought in as the dedicated purpose pool pump category, but don't have quite the same performance requirements. And I mentioned that earlier. So water feature pumps, any waterfall type pumps, because you don't have to, you can set those for everything. They're not based on an installation or a specific need. They can just do whatever you want, feature wise. So there's no real true performance requirements that have to be met with those pumps, so they don't necessarily have to fit into that same category. Those small little integral sand and cartridge filter pool pumps that you'll see on a lot of above ground kits, a lot of stuff that's sold out of the stores and things, you'll see those don't necessarily have to fit into this category as well. And then lastly, as I mentioned, the portable electric spa pump, those don't have to fall into this as well as either. Everybody doing okay out there? Mr. Phillip, everybody's good?
Everyone's well.
I'm not putting, huh? I'm not putting too many people to sleep, am I?
Only two.
It was after lunch. Okay, so anyway, looking at this, just to kind of give you guys an idea, this is an efficiency metric that goes across the line, and self-explanatory, single speed in blue, 2-speed in red, and the variable speed in green. So you can see where the different plotting points based on the weighted energy factor going up on the vertical side and the hydraulic horsepower, or again, the actual horsepower of that motor within the wet end area, measure that and see where these things fall. And this is we'll look at this as the self-priming category that we talked about a little bit ago. So when you graph it even forward and you look at that 0.711 point that we wanted to get to for this, and then you plot those EL lines that we mentioned a few minutes ago, you can see where all the different types of pumps, and each of these dots may represent similar pumps, not just one pump. And this is across different manufacturers. So you can see where these all fall into play on these different levels. So in here, in a lot of cases, the obviously the variable speed really stands out above that line and reaching those above that EL6 line going forward. The max category on this is that EL7 line. So you can see there's even a handful of those that reach above that. Again, another look into this, and this is looking at the same thing from a self-priming standpoint. You can see how the split lies when you're talking about half horse and 3/4 rated horsepowers below, and then how it ranges from the 1 all the way up to the 5 horsepower. And again, you can see where variable speed technology, variable speed pumps still remain up above that EL6 level, which is very not just meets the regulations, but continues to meet that elevated level that Energy Star looks for as well. So again, when you look at this from a compliant, non-compliant standpoint, so basically anything below that level is going to be non-compliant. Anything above the level is going to be compliant with these new regulations that, again, go into effect. Technically, I looked at it, 9 months from yesterday. So it's coming. Looking at the final, just a quick look at this, just kind of give you an idea where you're looking at here. So hydraulic horsepower of the beginning of that line is around 1 horsepower, and out at the end of the curve down there is about 2.5. So your minimum scores, and remember, we're trying to keep it elevated more than that 3.8 level that was first on the Energy Star level. So now most of these things are going to be ranging from on the high side at 6.8 on your lower hydro horsepower, all the way up to the 2.5 when you start getting out towards the end on these scores. I mentioned labeling earlier. So some of this has already taken place. A lot of the labeling regulations started actually back around January of 2017 is when some of this started to go into place, and they gave themselves 54 months to get fully compliant, and 54 months would be that July 19th, 2021 date. So a lot of manufacturers had that long to get things nailed down, get things changed, get things worked out as we move towards that date 9 months from now. So you can see the old labels on the left. You can see where you see a service factor circled. You see total plus things that are labeled there as well. We must list the total horsepower now with the service factor of 1. So as you see on the label on the right, the new label, that's what you're going to be seeing on these pumps. I believe this one here is just for example, this is a label off one of our Whisper Flow XF pumps. So you'll see there it's a 5 horsepower, service factor of 1. So the total horsepower is 5 that is on there. And then there is a label, not part of this label, but there is another part on the labeling that has the WEF score on there as well. So this will also eliminate, as I mentioned, the uprate full rate labeling scheme. Some of you are well aware of that, where one pump's a 1 horse, simple label change, design change, it's a 1.5 horses. That has to go out the window now. Everything will be based on the hydraulic horsepower and the total horsepower going forward. So you'll see this not just on the pumps, but also, as I mentioned, on the literature, and the information will also be in manuals as well. So this is just kind of the same situation we talked about, just in a bucket format. We have old rated horsepower versus new hydraulic horsepower with this, just a bucket way to look at it a little different way. So you had the full rated pumps were at 1, we call it up rate 1.5 horses, and that's something that's no longer going to be able to be done any longer. Service factor of 1, so 1 horse is a 1 horse, 2 horses is a 2 horse, etc. Determining hydraulic horsepower, very similar curve. Everyone knows about curves and how to read them, so I won't spend a lot of time on this. But basically, you're looking at what the curve C is, which has a lot to do with this hydraulic horsepower, what the pump curve does based on feet ahead, and stretching out to that far. So again, one of the things just to kind of remind you is the 50 on the what doesn't have to comply is that 200 GPM at 50 feet ahead compatibility when we're talking about, bigger pumps and commercial pumps, which that basically starts at 5 horsepower. Those don't have to worry about any of these regulations, but this is kind of how these are determined going forward as things creep along. Per the DOE regulations, rated horsepower is no longer allowed on the label. Has to be total horsepower is what's required. The total horsepower states the motor horsepower, not the pump horsepower or pump performance. Gotta remember that. That's one key thing to remind yourselves. Again, I can't, Jeff told me to make sure we hammered this a lot. All service factors are 1 now. Hydraulic horsepower defines the pump's wet end performance. It is exactly proportional to flow, and that's precision, and that's how their measurements are standardized with the hydraulic conditions. And these curve Cs you saw in some of these curves, and you'll continue to see that in other things that are out there in the industry. When we talk about curve C, it's usually talking on systems that were plumbed or tested with 2-inch plumbing, just so you know that. There's no difference, again, between commercial and residential. It's not application specific. Again, 2-horse single speed are prohibited from being manufactured. And again, July 19th, we can no longer make a single speed pump that doesn't meet the regulations, and we won't be able to offer it for either commercial or residential. I'll say this again, that if you already have them in your inventory and you have 10 or 12 on your shelf on July 18th, you can still sell those if it takes you 2 years to sell those. So don't worry about that. You will be allowed to sell those. We just cannot manufacture anything after July 19th that isn't variable speed and doesn't meet these regulations. We mentioned residential size. We all know commercially there's a lot of pumps out there that are less than 5 horsepower on a commercial installation. But again, only single phase is what you have to worry about. There's that 200 GPM at 50 feet ahead that we talked about. And that's kind of the red line in reference to, have to worry about regulations and not with a larger pump. So that's kind of where we're at here. Most larger exempt pumps are not required to label with WEF. I think, and I don't have confirmation on this, but I think we are going to be doing some of that anyway, going forward on some of our larger commercial pumps, but it's not necessarily a requirement. Replacement motor regulations. Now, the question came up, if we're doing this with pumps, with complete pumps, what about replacement motors? Shouldn't they have to fall into the same DOE regulation? Well, ironically, that's why Mr. Farlow is not with us today. He is on the meeting call. They're trying to put the final versions of how replacement motors are going to be handled and trying to put that to bed so they could implement that the same July 19th date going forward. So what we're trying to get to that point that, replacement motors, where it's variable speed or efficiency, whatever, will be part of this regulation. That's still yet to come. We don't know exactly what they're going to change or not change. But as I mentioned, Jeff is actually probably talking right now in reference to that, and hopefully they'll have it all nailed down. And we'll obviously update you as soon as we get more information as to how they're going to handle replacement motors going forward. Regulation of force, I haven't said this enough, July 19th. Again, base date of final pump assembly. So I don't have a guarantee whether we're going to start earlier than that. But let's just say for now, July 19th, we will make no single phase pumps. You can't return any product that's in inventory or at distribution. We're not going to allow that. They are allowed to purge the pre-regulation products. So again, if you have, I know most of you guys are buying direct from us, but if you have a distributor you're picking stuff up from, or they need a pump that's, and as long as if it's a customer that doesn't, you can't convince to go variable speed, and you want them, they want to just replace what they have. If a distributor has it and it was manufactured prior to July 19th, you can buy that pump and install it. So that's definitely what it is. We as a manufacturer, we're held accountable for this compliance. We are not able and legally able to bring pumps in or sell pumps or make pumps after that date. As I mentioned, approximately 80% of the current pumps will be obsoleted. Don't have the exact numbers or SKUs or what's going to be going away. But again, it will be quite a bit, especially on our side with all the different companies we bought over the years. You're going to see a lot of change in that. One thing, going back to the commercial side of it that has happened, this is affecting commercial pumps as well. Our sister division, Aurora, as well as other competitors like Marlowe and Payco and stuff, they had to comply with a lot of these energy type pumps and DOE regulations from performance and that kind of thing. So we've seen a lot of pumps gone away on the commercial side. We used to sell the Aurora 340 series pumps for years, and those went away, and those have been replaced by the 3800 series, which meets the new compliance. Berkeley pumps, since Berkeley's part of our company, we've seen a lot of Berkeley pumps go obsolete because of this, and we still have a handful of those that we can get that meet the regulations. So it's a lot of change and a lot of not just adjustments to us as manufacturers, but obviously to you guys as the dealers going forward. So the Energy Star and utility rebates, I kind of mentioned this earlier. Version 1 came out in February of 2013, and that really had an effect for just 2-speed and variable speed pumps. Version 2, which happened January of last year, 2019, which after this year seems so far away, but those were variable speed only. And again, version 3.0 of the Energy Star regulations will take effect the same date as this DOE regulation on July 19th, where it'll just be premium variable speed pumps will capture that. I mentioned earlier on the rebate side of it that there are several different power companies that allow rebates for going to variable speed technology. I would really take advantage of that all that you can now in helping you sell to your customers and encourage them that their rebates are out there. Because again, after this regulation, those might go away. They might be severely impacted because it's going to be a mandatory thing rather than, in a sense, a choice to do it going forward. So it's kind of like a use it or lose it mentality as to how we go forward with this. So take advantage of those rebates now. So selling the benefits of variable speed, and Jason, if you stop me if you're going to go into things we don't need to cover, but this is kind of a review on why we should go into energy savings and variable speed. So obviously, when you look at this, you look at a lot of instances. You look at selling the benefits of it from a home energy use. When you look at the whole total energy usage of a house, 51% of it is in the heating and cooling of a house, a typical average house. The next biggest factor in that single factor is a pool pump. If you have a pool pump, approximately 13% of that energy in that household is based on the pool pump. So you got to really start looking at it. They have a right to save money. They have a right to, you guys have a right to sell a higher dollar pump. They have a right to save money and energy. So that's a great way for you guys to provide those options going forward with this. So slower is better. We started talking about this a long time ago as to how this was worked out. So think of this again. If you're in a car and you're going full speed with no brakes and you can't slow things down, you're just going full on speed. And think of that pump that's doing the same thing. That's running 24/7, full speed out there. You're putting extra performance needs on the pump. You're putting extra stress on the pump, et cetera, et cetera. So by slowing things down with variable speed technology, you're enhancing the equipment performance. You're able to dial things exactly what you need to do. You can run it longer, but for shorter speeds and better performance going forward there. It kind of protects itself from damage, has longer filter cycle, and helps the chemical circulation a little bit longer. And then you can also, an advantage on water features or negative edges or other things you have on a pool, you can customize or change water features however you want to do it. You know, typical daily thing, you have your negative edge and your waterfall going at a certain speed. And then, of course, when you have the 100 people over for the party, social distancing, of course, right now, you can speed that up and set up different times. So there are some all kinds of benefits that you can do going to this variable speed. Avoid roadblocks, of course. You know, there's different things that we've all had to try and overcome. We did as a manufacturer trying to sell that initial cost. It is quite a bit higher than a standard pump. But then you start getting into the fact of cost of operations and life cycle costs and the annual savings and rebates that are out there. Really start looking at your return on investment. I know all you guys have done a tremendous job in selling this technology, and we couldn't be happier, and we thank you for that. Because obviously this has been a big push and a big impact on our business over the years, and couldn't do it, of course, without your involvement and your help. So looking really quickly, and this is something that can help from a sales standpoint of it. So you look at it, a single speed pump that they have, a homeowner has, they pay approximately $700 for it. This is based on the assumptions you see there in the right-hand corner. Running 8 hours a day, 12 months a year, 20 cents a kilowatt hour. That's a little higher than some of the areas on the East Coast, but that's kind of gives you an idea. So $700 to buy a pump over a 5-year running at those assumptions. You're looking at about $1,200 a year. So in 5 years, just under about $6,000 to operate that pump over the course of a typical life cycle in looking at this. So when you go into variable speed on the same type of scenario, the cost to buy is a little bit more out of pocket, but it's also reducing your operation costs are now down to $400 a year. So over that course of the 5-year analysis, you're just under $2,000 to operate that. When I was at almost $6,000 before over a 5-year period, and so your energy savings and the savings in cost is over $3,200. So the payback to the consumer is just in 2 seasons for this scenario that you're talking about here. Also allows you to run the pump, of course, a little slower, a little bit more high speed for a few hours a day, low speed for the other times, and stretch that out. So this is a good way to explain this and obviously go after these variable speed jobs that are out there. This is similar, a little bit similar, just a little bit different. This is a look at a horse and a half, I think, on this one. This is a one season payback if you upgrade from single speed to variable speed. And I think this is very similar to that. But again, variable speed cost of ownership is basically cut in half when you talk about energy savings and potential cost going out. So some of the key takeaways that we want to really remember, again, enforcement of this starts July 19, 2021. Customers are there. They have the right to save energy, just like all of us have the right to sell good pumps. Work on it now. Anything, keep pushing. I know you guys have been pushing for years, and keep pushing it, because it is going to be something that they're going to have to do soon. So why not do it now? You don't have to change based on the application anymore. It's the same pump now because of that total horsepower. Again, it does apply to residential and commercial, single phase only on the commercial side. That's a key thing to remember going forward. Mostly in-ground pumps, variable speed pumps will become the most common type. They're going to have to be, once all those other single speeds that fail, or once they purge all the inventory, it's going to have to be all variable speed. Again, the 1.0 service factor. So again, the upgrade full rate's gone. Above ground pumps, the single speed pumps will still remain a most common type because they don't fit that self-priming category. So you have to worry about it. Again, everyone does the selling of variable speed in different ways, but the main thing is just return on investment, really quick return on investment in most cases. Quiet operation. Everyone knows here that's used them, very quiet to run those pumps. And what's going to be helpful too, in a sense, for, selfishly from a manufacturing standpoint, it's going to reduce a lot of the SKUs that we have to offer. So hopefully what that means is that we can push pumps out the door even quicker than we have. I know, I apologize. I know that doesn't fit this moment, but we're getting there. And also will help you guys with stocking. If you're going to have inventory in your own place. You can stock 2 or 3 different SKUs and cover probably everything that you do. I know we're seeing a lot of people do that with one of the 5-horse variable speed. They're realizing that I can use that same pump for different applications in the same project. So that's helping cut down and make things easier on you guys as well. I'm going to go through a couple questions here in a minute, so I'll save that for now. So one of the things that Jason wanted to cover, and I don't have a lot of detail. I apologize, I don't have a lot of detail in this, but there's some changes within the electrical codes that are out there. Ken Gregory is our director of compliance, and he does a lot of, he's involved in all kinds of codes and things in regards to this. So the NFPA, for those who don't know what NFPA stands for, that's the National Fire Code Protection Code Association, and it really helps to publish the National Electrical Code. So they're currently working in the National Electrical Code. There are different requirements and different things that are going to be changing, that are being pushed for change, I should say, in reference to these regulations and how they are affecting and what you have to worry about going forward. So some of the things that are out there now is this Aqua potential bonding, water to deck bonding of things. The reason it was doing this because it was preventing the tingling while sitting on the deck with the feet in the water. So that was one of the things that was important to push through. Water bonding, of course, water to bonding grids that were requirements and needed to be done. And then the latest thing that I've dealt with personally on a couple of different situations, especially here in North Carolina, is the corrosive environment aspect, and especially on commercial as well. So corrosive environment, meaning they want inspectors, and a lot of it has to do with their understanding of the regulation, that corrosive environments really only apply to the wiring and not the actual equipment. If your equipment is approved for outdoor use, then you should consider that to comply with that corrosive environment. That's the key thing that they wanted to make sure of. So their confusion comes into when we've had it run into inspectors say, hey, this pump's can't be used in a corrosive environment. Well, it's not the equipment. It's the actual wiring to the equipment. The actual equipment, if it is certified for outdoor use, then it's fine in reference to this corrosive environment situation. Again, NFPA 7, or the International Residential Code, is applicable with section 102.7.1 of the electrical requirements. There is an exception for the internal wiring for portable residential spas and portable residential exercise spas. So those don't necessarily have to worry so much with this type of this regulation here. One other thing I want to mention, I got from Ken this morning. It's not in the presentation, I apologize, but I just asked him if there was anything else that I could add or mention. And I will we'll say this in a minute again, but any questions in regards to specific electrical, you could fire to me, and then I can get those to Ken, and he's always available to talk. So he said the 2020 National Electrical Code now requires a GFCI based on that now, and they are proposing to change that. So I just want to read this to you as to what this document says. It says ground fault protection for equipment operating at voltages greater than 150 volts to ground, circuits serving all pool motors and dehumidification units connected to the circulating water system, operating at voltages above 150 volts to ground, whether single or three-phase, shall be provided with a ground fault protection for equipment not to exceed 30 milliamp trip current. They're going to try and develop this and add this in for the 2023 code. And it addresses the new changes are going to address, and I can send this to you guys. The new section is going to address the use of higher voltage motors, et cetera, and how that affects this regulation and how things are done. So there's some things going on, behind the scenes constantly. Ken Gregory's been really our main guy, involved all kinds of different codes and different things. So he will continue to be, and we'll do our best to keep everybody updated on things going forward. Some of the things I wanted to just reiterate, and then if you have any questions, or Keith, I know I want to give you some time to talk about anything that you want to talk about. One of the things, as I mentioned 3 or 4 times, Inventory is still good. If you have inventory on single speed pumps, you don't have to worry about it. You can use those even after the July 19th, 2021 date. Question came up, how does these regulations affect NSF Standard 50? It doesn't. It doesn't at all. So anything that's listed, and one of the things that we have done, some of the other manufacturers may have done as well, don't panic if you don't see our pumps or certain things listed on NSF anymore. UL has started to test per NSF Standard 50 regulations. So there are certain parts of equipment that we are starting to transfer to UL as far as our listing agency. But either one of those is fine. You're not going to see any of the regulations affect those listings whatsoever. Replacement parts, just to kind of give you an idea, that question had come up at one point where how are we going to handle replacement parts on the single speed pumps, et cetera. Those will be good and available for quite some time. The one thing on the replacement motor side, as I mentioned, Jeff's on that today, so we'll have more detail as to how that's going to be effective after July 19th of next year. But right now, single speed motors would still be available up until that point, at least as of right now, is how that's going to be addressed. Let's see. I think that was some of the key things. We have several things that are available to you guys for extra reference, extra points. You can see them there on the screen. You can go to the DOE's website, get that link there, and I can send this to you, or Jason has this presentation as well. They have all the information as well. We have developed at Pentair a great site as part of through our website. If you just go to pentair.com/pump regulations, there are several things there. There's a webinar that Jeff Farlow did, which a lot of this information that I talked about today is there. There's a webinar they did with Aqua Magazine a few months back. Some of you might have attended that, but that is on that site. You can listen to that. There's also some documentation there as to how to fully understand more about the regulations and things. Maybe that could be a good selling point to you all if you need to convince somebody to go this route and why you're having to do it. There's also a little webinar in there that has a handful of guys from the industry, some of your colleagues that talk about how they're handling it and best to handle these changes that might be helpful to you as well. And of course, we're here to help in any way we can to further get this information out to you because again, 9 months from yesterday, it's going to hit. So with that, if there's any questions, fire them away. I'll do my best to answer them. If not, I'll get the answer for you. And if not, I wanted to thank everybody for the time today. I want to give Keith a few minutes. Keith, if you wanted to say anything about anything else going on.
I will, but I'll just see if there's any questions.
Okay.
Hey, Mike, it's Lee. Can you hear me?
Yes, sir.
Hey, I have a question regarding how this affects the VGB, Virginia Green Baker Act, and main drains. So for many years, we've installed a lot of IntelliFlow pumps, Westflow pumps, and going forwards, we've already had the strainer housings plumbed in, and instead of cutting out and replacing whole pumps, even if it doesn't necessarily need an IntelliFlow, we want to use SuperFlow. We've been swapping out wet ends of Whisper Flows to IntelliFlows. And, depending on, different applications, certain amount of these projects, have the potential to pull more flow through the main drains than they should. And as far, are you aware of how they're going to handle? I mean, simply maxing out or lowering the RPMs on these VFDs, is that acceptable for max flow rates on the main drains?
From what I understand, it will be, and I'll get confirmation on that from the guys. I don't want to give you a wrong answer right now. Just jotted that question down. I'll get an answer back to you guys on that just to verify that, just to make sure.
You need him to repeat it? Yeah, could you repeat that? We had to enter.
Oh, that's fine. No, that's fine. Actually, I don't have the final answer on that. I'll get that answer to you. I know that some of the things that have been taken into account was the VGBA regulations as well and flow. I jotted that question down. I will get that answer to you before you guys break up from your meeting. If not today, by tomorrow. And Lee, I'll send you an email on that so you can spread it to the guys. Anybody else?
Mike, I think.
Okay.
Sorry,
Can you
one more time if you got a second to Lee again.
Sure.
On the Superflow VS and the IntelliFlow, I just want to make sure I'm correct. Either one we can wire three-phase.
I can't speak on the Superflow, but the IntelliFlow, yes. And there is a way to specifically do that. I have that document. I thought I'd email it to me, but I didn't. But I have a document that shows how you do that. I can email it too. But yes, the IntelliFlow you can. Superflow, yes. Keith, you might know that answer. I'm not sure on the Superflow, but I know the IntelliFlow you can.
All right, I think you're good, sir.
All right. Well, before I'm gonna I guess I'll listen into what Keith has to say, but I just want to thank everybody again. I'm sorry I could not be there. Jason, thank you, and the whole team at National Polls. Thank you guys for this. And as I mentioned, I know Keith's got the attendee list. We're gonna follow up with some stuff to you guys. And thank you for the time, and good luck with the rest of the conference.
for the northern part of Waterway. And what I'm going to do is spend some time talking about proper in-ground spot jet design in a variable speed world. Because as you guys just went through and spent an hour and a half talking about our upcoming DOE mandate. So unfortunately, that's going to create some fun for us next year once it's not advanced. There we go. All right, so real quick, I'm sure most of you know a little bit about Waterway, but I just want to cover some brief history just for those of you that don't. Waterway, most people know us as the spa guys because, you know, we've made jets for years and years and years. But Bill Spears is our owner. He moved out to, he was a little boy from Oklahoma. He and his brother moved out to California back in the late 60s. And they both worked in the plastics industry. Kind of reminds you of that part in The Graduate, Dustin Hoffman, the old man, plastics, plastics, plastics. Well, you know, there was good money in it back then. So Bill and his brother took their money, started their own company, Spears PVC, and unfortunately what sometimes happens with family businesses, Bill decided to have Wayne buy him out. So in late 72, Bill took his money, started his own business, bought 2 machines down in Orange County, and started producing custom parts for the pool and spa industry. So to not be in competition with his brother, he knew a number of people in the pool industry, Len Gordon, South Pacific, that's where the Hydro guys came from, Vico Pump, California Cooperage, Ortega, and started making custom parts. And all he did was pop plastic, and he was happy doing it. He just sat there and popped plastic, and the pool and spa industry went on, not knowing that he made a lot of the stuff. And then by 89, Hydro and G&G got big enough to start doing their own manufacturing. So that's when Waterway was actually created. So the difference was, instead of just making jets, because of our background, we also were making the pumps, the filters, skim filters, lights, ozonators, specialty fittings, everything that the spa OEMs needed to make a tub, except for the shell, the cabinet, until about 7, 8 years ago, the control box. We were making bundles for the spa industry before the pool industry knew what a bundle was, okay? So fast forward, in late 96, who here remembers a company by the name of PacFab? Few hands. How about American Products? Yeah, well, PacFab bought American. We lost 2 customers in one quick swoop. So PacFab wanted the 10 machines over at Moore Park, and hence we're sitting there with all the tooling that we owned and nobody to make white goods for. So the pool division was created in 97, and yours truly was hired in the spring of 98 to sit there and run around 14 states in the Midwest selling gunite white goods on a vinyl liner market. Yeehaw! Now, the good news is that we also came out with a lot of equipment in 98, above ground equipment, in-ground equipment, pumps, filters, lights, closers. Everything you see in that catalog now on the pool side has only been around in the last 22 years, 23 years, okay? So that's real fast, real quick, where Waterway came from, how we got to the point where we are today, and obviously we know these things inside and out. The spa industry is still 70% of what we do, okay? Therefore, when it comes to this stuff, we can give you the ins and outs on spa hydraulics. Now, not going to sit here and talk about OEM portable tubs. What we're going to talk about is in-ground stuff, whether it be concrete, whether it be vinyl, whether it be fiberglass, but in-ground only applications. So, this is normally a 2-hour course for PHTA, 2-hour CE credits. I'm going to sit there and cram that into an hour. So we're going to get going pretty fast, but because it is a CE credited course, there is a quiz. The good news is, I'm going to give you the answer to the quiz, so there shouldn't be any reason why anybody doesn't pass. So obviously up on the screen, we've got some gorgeous tubs, some beautiful projects that were built. So I'm going to give you the answer, or give you the question. When you guys get done building a project, turning that backyard over to a homeowner, they've got that spa, they get home at the end of the day, it's been a long, exhausting day, they get the kids put away, go outside with their spouse or significant other, they've got their adult beverages, getting ready to get out in that tub, and they want to press that button. What is the most important thing that that homeowner is wanting out of that spa? Anybody? What? Jets and heat. Good answer.
Bubbles.
See, cheaters. The bottom line is, guys, they want bubbles, okay? When they press that button for spa jets, there better be bubbles. If there aren't, guess what? There's a phone call to you. My tub doesn't work. And guess what you guys do? Then you call John or me and going, hey, this freaking tub doesn't work. Your dang jets, this $24 jet doesn't work. What the hell? So the bottom line is, as far as a consumer's concerned, a homeowner, they don't care about what all the work has to be put in this thing, what has to be designed in it, what has to be organized and put together to make it work. All they care about is when they press that button, they better get bubbles. Okay? So there's the question, or the answer, and there's the question. So moving forward. Obviously, you guys have spent an hour and a half on this. Most of you have probably heard what all this pertains to, but real briefly, where we're concerned with what I call DOE 2021, or as everybody else calls it, Dedicated Purpose Pool Pumps, DPPP, this mandate next July, as far as we're concerned, what we're talking about here today is going to be regarding self-priming pumps. That's pretty much in-ground pumps. And we ain't worried about the small ones, okay? Because for most jet applications, most spa applications, we're going to have something that is, as this mandate calls it, a large self-priming pump. So what does that mean? That means anything that is 0.711 HHP or larger, up to 2.5 HHP, hydraulic horsepower, has got to be a variable speed pump, right? So that's our problem. And our problem is this. Do variable speed pumps work with jet systems? And the answer is yes, they can if they're done right. So when variable speeds first came on the scene out in California under Title 20 years ago, an average tub out in California had 6 of these little suckers on it. They always worked. Title 20 goes into effect. Now you got to stick a variable speed pump on it. And next thing you know, guys are sitting there putting pumps on them, and the jets don't work. And now this $24 jet is broke. What changed? Not the jets, not the hydraulics, but the type of pump they're using and the way they thought they could use it. Okay? First off, why is that true? Spa jet systems are a fixed system, meaning this little $24 jet, this nozzle requires a fixed flow rate at a fixed pressure, period. We have a fixed system. It is not variable, which means we have to put X amount of flow through there at X amount of pressure, or guess what? We don't get bubbles. What is the most important thing that homeowners want when they press the button? Bubbles. So they want bubbles. Now, what are the most common mistakes that we see? These jets will always work. They never fail, as long as they're installed properly and as long as we make sure we have our hydraulics right, which means proper pump sizing and adequately sized plumbing. Okay? If we make sure we've got those two things right, this thing is always going to do what? Give us bubbles. All right? So, all of you should have a copy of this worksheet Jason was kind enough to sit there and print it off, so you guys should all have that in your book. So what we're going to do is take time, and I'm not going to spend a lot of time getting into the weeds on the numbers. I just want you to be able to make sure you've got the reference points as far as the charts and where these numbers are being derived from. The main point is I want to take you through this so that when you get back to your businesses and you're working on a project, you've got the ability to follow through with it, design that system, and make sure with confidence that when you're done, it's going to work right, okay? So the most important thing about this is as easy as A, B, C, and D. First, we're going to analyze our jet flow demand. We're going to blueprint our pipe size. We're going to calculate our system total head loss. And then D, we're going to determine our pump size. This is really no different than what we do in regular pool equipment sizing for a pool, right? We need to know what our turnover rate's going to be so we can determine what size pump's going to be needed to sit there and turn that pool over, right? Same sort of thing here. So analyzing our jet demand. In there, I have a generic tub schematic in the very back. So it's showing you've got a circulation system, and this is not a shared system. And we'll get into shared systems later, but I just want to give you a general outline of it. So what you've got is your circulation system. Your suctions are in blue. You've got your heat going back with a hot water return. And then you've got your air blower with the Hartford loops and injector system. And then we also have our spa jet pump here, dedicated jet pump, where the aqua is the suctions and the orange is our jet system. Okay? Now, we're going to come back to this from time to time, so if you want to find it and just thumb over that page, that way you've got a reference point. All right, A, we're going to analyze what our jet flow demand is. Why do I want to do this? Well, we just talked about it a minute ago. It's like determining turnover rate on a pool. We need to know how much flow we need for that jet system. Okay, so in that example we just talked about, there are 4 power flow jets and there are 10 poly jets. So if we go to our jet chart here, you'll see your diameter of the orifice, and you'll see pressure down, you got 3 columns, 10, 15, 20 psi. You want to sit there and try and run everything at the 15 psi. We want to be down the center of that chart because that's the sweet spot. It gives us a little plus or minus on our tolerances, but we want to try and aim for that. So what that says is for our polys, we've got 10 jets, and they're a 5/16 orifice. That's 10 GPM times 10 is 100 gallons a minute. Okay? And then we have 4 of our powers at 15 GPM, which is 60 gallons a minute. So that's 160 gallons a minute. Is that true? Everybody good with that? Okay. Now, it's also at 15 psi. So I want to make a point here. What is 15 psi in pressure? Times 2.31. It's almost 35 feet ahead, right, guys? So what does that mean? That means this stupid little $24 part is putting 35 feet of head on your water flow as you're running that water through there to get enough pressure on that nozzle to create a negative atmospheric pressure point in the front of that nozzle so that it will pull in air like the gravity pushed the air in. We're trying to create a negative atmosphere in the front of that nozzle. But we have to push that water through at 35 feet ahead. All right, let's think about this. Let's put this in perspective. What is 35 feet ahead? What's your average head pressure on a normal pool application with a pump filter and a sanitizing system, maybe a heater, with a clean filter? 10, 15 psi, give or take? Is that realistic? Okay, so let's say 15 to keep the math easy. So what does that mean? That means a clean pool filtration system to operate a whole pool has got roughly around 35 feet of head on it, right? Is that fair enough to say? So does this stupid little nozzle. It puts 35 feet of head on your system with nothing else calculated in. No 90s, no T's, no valves, no suctions, no pipe, nothing. This stupid little $24 piece of plastic is shoving 35 feet of head on it, on your system by itself, okay? Now, moving forward. Is everybody good with that? Okay. Not moving forward. There we go. All right. B, we need to blueprint our pipe. I don't want to get too deep into this because I think most of you guys know the basics on hydraulics and that, but we'll go through real quickly just where we're at in this example. So if you're going to do a linear with multiple jets, usually you're going to have some sort of a main feed line, then manifold over, T over to your manifolds to make sure you got even pressures on that system. But we need to go through and figure out what our size plumbing is going to be based on our flow rate for those lines. Now, this system's a 160 gallon per minute system, right? We already determined that. 2, I've always tried to be conservative when I sit there and do my numbers. So I've always figured everything up at 5 feet per second for suction and 7 feet per second for returns. And that was before VGB. Now we got VGB to deal with, and under the new codes, everything's at 6 and 8 minimum. Okay? So obviously, the way I've been doing it for years, I've got it at 5 and 7. Obviously, for an industry standard, everything's at 6 or 8 minimum. So you can go through and do the same thing. But what you'll see here is I highlighted at 160 gallons a minute, we're between 6.5 to 7.5. So at 160, we're right there. 80 gallons a minute, we're for 2.5 inch plumbing, we're at 5.3. And then 40. So for our return side, what we're seeing is we're going to need 2.5 inch plumbing to be above 70 gallons or 7 feet per second for 80 gallons a minute, 40 as we split off, and on and so forth. So if we go back and look at this, we're going to have our main trunk. It's coming in at 3 inch pipe. Our T splits off at 2.5 and feeds our main manifold for all the jet systems. That'll be 1.5 inches. Okay. So that's just it in the same way of saying it, at 7 feet per second. All right. So that does the jet side, the return side. Now we need to do the suction side. And in this instance, keep in mind we got VGB to deal with. So that means whatever suction fitting we use, you have 2 numbers you got to take into account. One is whatever the flow rate for the grates are. Okay? But that doesn't necessarily mean that that's the determining factor in calculating how many suctions it's going to take. The second part of this is we got to be 6 feet per second on our plumbing. So in this example, I'm using our 2-inch insider with the 6-inch grate. That's good for 136 gallons a minute, but it's a 2-inch insider, so it's going to be 2-inch pipe. So we'll have to take that into account. But if we go through, if you take 136 gallons a minute, divide that by 160, that's roughly 85%. So if we throw that in the flow charts, what we're finding out is obviously at 2 drains, we've got to be 100%, right, for VGB? But we're not. We're at 85. So that means we're less than 100% with 2 drains. So our problem is we're going to have a multiple drain scenario, but at how many is the count? So our next step is 3 drains, gets us to 66.7%. 85 is obviously greater than 66.7, right? So therefore, we're going to have to do at least a minimum of 3 of those suction fittings. But let's double check and make sure we're good on the pipe. So here, we're going to go back to our friction flow chart, okay? And we're at 2-inch plumbing for the fitting. And in this instance, we want to be better than 5 feet per second. So if we come across, that puts us at 50 gallons a minute, right? So at 50 gallons a minute, divided by 160, what's that put us at? It's over three fittings, right? 3.2? Well, we can't do a 0.2 fitting, so we're going to be at 4 fittings minimum, all right? So even though the suction grate has the flow rate that we could get away with 3, the plumbing fitting is not, so we've got to go by that. So when you're doing suction fittings under VGB, you got to keep both of those numbers in account. All right, for our feed lines, you got 2 lines coming in, or you can do a single line. But if we do 2 lines, it's going to be 3-inch plumbing. If we do a single trunk in, then we got to do 4-inch. Okay? Is everybody good with that? Any questions? All right. Now the fun stuff. This is where everybody's eyes usually glaze over, if this hasn't been boring enough. We're going to have to calculate the system total head loss. I'm going to try and move through this fairly quickly, but I also don't want to lose you guys along the way, all right? So what we're going to do is we're going to take on that example and calculate up all our fittings, all our length of pipe, all our T's, everything, right? What I'm going to do to make this simple is we're going to just focus on the 3-inch stuff. Now, we got to go back through and do that for all the other pipe sizes. But to get through this quickly and not bore you guys to death, because I only have an hour and I'm blowing through it pretty fast, we're going to focus just on the 3-inch. So what we've got, you're going to find in your worksheets a friction loss fitting chart. So in here gives you all, whatever the size of the pipe is, 1.5, 2, 2.5, 3, on up, but it will give you the length of pipe for each one of those fittings, whether it be regular 90s, long radius 90s like our sweeps, 45s, U-bends, T's, on down the line. So let's just do this for argument's sake. Let's go over and look at the 3-inch. A normal 3-inch 90 utilizes or uses up 11 feet of pipe when you're figuring up your head losses. A long sweep 90 is almost 3 times less. And a 45 is equal to what a long sweep 90 is. So how many here normally, when you guys are doing high flow situations, instead of using a standard 90, would use 245s? Anybody? No? 1? Excellent. Well, and back in the old days, that was, you know, the easiest way to sit there and cut your head losses on a system. But of course, it's always so much fun trying to get everything lined up. You got 245s, extra chunk of pipe, trying to make it look nice, and plus a lot of extra glue joints. So the one thing you're going to see we're going to talk about, we're going to spend more time talking about our long sweep 90s, just because with one of those, I'm at no more head loss than 145, and I don't have to do all the extra work of trying to make it nice. But this is where those charts are from, or these are where those numbers are coming from. All right, obviously we also have our friction flow chart. So we'll reference back to this. Bottom line is, if we got 3-inch sweep 90s, we have 3 of them, our fitting loss is at 4 foot, that's going to equal 12 feet of pipe. We have 115 feet of 3-inch pipe, which is how much pipe? 115 feet. And then if we go ahead and jump ahead and add in the T's and the 12 feet for the 90s,
we're at 70 feet for the fittings, plus in the pipe, it gives us a total of 185 feet of pipe on just the 3-inch run, okay? And then we go to our friction flow chart. We pull up the head loss, which is 1.39, take that by the length of pipe, divide it by 100, and that gives us 2.57 feet of head. All right? So that gets us for the jet suctions. Now, we also got to do the component, right? We got to do the drain itself. So the good news is on that 6-inch suction, where is our head loss? Okay? Now, notice I didn't do it at 50 gallons per minute. Why? We got how many suctions in this example? 4. And 4 in the 160 goes how many times? 40 gallons, right? So the reality of it is, even though they're very, very close, we're only having to worry about the 40 gallons a minute going through that fitting. We're still at 0, so that helps too. All right? So we got, and we're only going to do one side. So we got one fitting at 40 gallons a minute, is at 0 feet of head. We add everything together because obviously we have more pipe. We have 4-inch and 2-inch in that example. Remember, we were only going to focus on the 3 to get through this fast enough. But that, I went ahead and did the math for you guys. So that's at 296. Plus the suctions, 0 gives us still 296, right? So that gives us the whole head loss for that suction side. Everybody good with that? I know I'm going fast, but okay. All right. Next part, we're going to have to do the return side, going back to the jet. So from the back end of the jet pump, the discharge, back to the jets themselves. We're basically going to do the same thing, right? The difference is we got to go through and figure up what the 3-inch part of that is going to be, because I want to go fast through this for you guys. So I'm going to cheat. We're going to jump ahead of the rest of the stuff. Here's our friction flow charts again. But we've got, for this example, 590s in 3-inch. They're at 4 foot. That's 20 foot of length. We've got 97.7 feet in 3-inch. So we're at 97.7. That's pretty easy. I'm going to go ahead and add the 20 feet for the 90s and the T's, add it together. We got 37 plus 97.7 gives us 134.7 total length of pipe for the return side in the 3-inch portion of this. We'd have to also go through and do that for all the other pipe sizes in that return side. Okay? And then we just take our friction flow chart and we pull that up, and we're at 5.9 for 3-inch, 134.7 into 100 times 5.9 gives us 7.95 feet of head for the return side of this scenario. Okay? Now, we've got our suction side, and we've got the return side. Oh, I'm sorry, jumping ahead here, my fault. So, no, there we are. So we got your suction side, and then you got return side. We need to add those together because we want to get the total head loss on the whole system, correct? So 2.96 plus 11.77 gives us 14.73 of total feet of head on that system. But then we still have this, okay? And we know what the head loss is on this because we already looked that up a long time ago, right? And what was that? 34.65 feet of head, almost 35. So what are we going to do? We're going to add that to our total feet of head for all the pipe and fittings. And in this example, we're coming up with 49.38 feet of head for the whole head loss system. It's almost 50 feet of head, right, guys? How much head loss did we say was on a normal pool application with a clean filter. About 35? Yeah. That's a lot of head loss. All right? All right, so what are we going to do with this? This is basically just restating what we just did. Well, if you were doing a pool application, what would you do? You'd take your flow rate for the turnover rate, right? After you went through and calculated out what the head loss was for that system, we take the head loss, and what do? We go get a pump curve, right? Okay, so we're going to determine our pump size. And why are we doing this? What's the most important thing to a homeowner? Bubbles. All right, so we're going to take our pump curve. This is just a simple pump curve for our PD 300s or our 130. And if we come across at 50 feet ahead and at 160 gallons a minute, that tells us we need a 3 horsepower pump. It's that hard. Okay? Now, we've been talking also, we have DOE coming up, right? Where now everything, we aren't going to be able to use this come next July. I can't make it anymore for you guys. I can make a variable speed version. That's it. So, what does that mean? When using a variable speed pump, we have to sit there and figure that up based on maximum RPMs. Why? Are jets variable? They're not. They're fixed, right? What did we say at the very beginning? Fixed flow, fixed pressure. We need both. If we have flow and no pressure, we got expensive wall returns. If we got pressure and no flow, what do we got? Expensive wall returns. And what is it that homeowners want when they press that button? They want bubbles. They don't want expensive wall returns. Okay? So the bottom line is, when we're sitting there planning out with a variable speed pump, is we have to go to that pump's maximum curve. And you're going to sit there and treat it as if it was a single speed at 3450 RPM, because we need flow and pressure. Okay? So, this is just saying the same thing all over again. We have a fixed system. We have to run that pump at a fixed flow rate and pressure, or we're not going to get bubbles for that homeowner. Period. Okay? There is no such thing as adjusting these. Let's use this as an example. So back in the day, I was telling you about Title 20 and when that went into effect back in about 05, 06 in California. A tub out in California has 6 of these stupid things, always has. A single speed pump that gave you 60 gallons a minute, 50 feet ahead, always worked. Jets always gave bubbles. Following year, everything went variable speed. So at that point, one of our friends out there said, oh, just take this pump and you dial it down. Now let's think about that rationale a minute. Back in the old days when we were a lot younger and I had more hair, we have a little tub with 6 jets on it, a little portable tub. And if we had a 2-speed pump on that tub, when we were running that pump at low speed, what were we doing? We were filtration, heat, sanitization, right? But when we wanted bubbles, what did you have to do with that pump? When you pressed the button, what were you doing? We had to have it on high speed, right? Why? We needed flow and pressure. So let's think about this analogy a little bit differently. Let's say you had a 2-speed pump, but it's 120 gallons per minute on high speed. Okay? But we got 60 gallons a minute on jets. What happens to a 2-speed pump when you put it from high to low? Flow cuts by half, but what happens to pressure? Doesn't drop by half, drops by 4 times. It's exponential. This is what all of us manufacturers learned the hard way with VGB. Remember the recall? The recall was because all of us that were testing, you got all these different drains, but who wants to go out and buy a special pump for each one of those drains' flow rates? So what do? Hey, there's these nice big fancy pumps with these variable controls on them. So you stick up a big variable speed pump on your test system, and you just keep dialing down the flow rate. No one sat there and paid attention. You're also reducing pressure by 4 times as you do that. So what happens when you're trying to test for entrapment? That's the whole purpose of VGB. And you're sitting there lowering the pressure as you do this? Guess what? You have a recall. Some of us had 4 products that we had to take back. Others had their whole product line. Okay? Bottom line is, with a variable speed pump, as we lower flow, pressure drops exponentially. If that was a 2-speed pump, like we just said in our example, if I was going to take a 120 gallon per minute pump, and if that was a 2-speed, kick it down the low for 60 gallons a minute to run my 6 jets in California, based on that rationale, my pressure is going to drop from 15 down to around 3 or 4 at best, right? Is that going to give us bubbles? We need the water going through at what PSI? 15, right? So we cannot sit there and go backwards. The same, what is a variable speed pump? A variable speed pump is nothing more than a 2-speed pump with more lower speeds. So think of it this way. If you have a single speed pump, a 2-speed pump, and a variable speed pump, how many high speeds do each one of those pumps have? 1. 134.50, period. That's it, guys. It doesn't get any harder than that. But we got to remember it, okay? Because in order to get that jet, what is it that homeowners want when they turn on that jet pump? They want bubbles. In order to get this jet to give them bubbles, we have to sit there and size whatever variable speed pump we're using based on its maximum flow rate at 3450. Okay? Now, I've done enough of these systems that if you're doing a dedicated jet pump, you're going to find out that that number I came up with, at 49 and change, you're going to probably hover around that 50 feet ahead, plus or minus about 1 feet of head. I don't care. If you've done all your hydraulics right, you've sized your plumbing right, it will always come out roughly around 50 feet ahead, period. So the nice thing is, we have a rule of thumb. Years ago, when I first started working for Waterway, back in the old days, we'd say for every jet we use 1/4 horsepower, right? Then we created these things. And the technology here threw the doggone rule of thumbs right out the window. But now we can go back through and we at least create a simple rule of thumb. So if you're using our PD 165, we can do 8 poly jets or 80 gallons a minute. If we're doing our 300 in our champion body, I can do 120 gallons per minute or 12 poly jets or 8 powers. And if I'm using my PD 300, I can do 160 gallons per minute or 16 poly jets or combinations of poly and powers to get up to that 160. All right? Is everybody good with that? All right. So, the first spec I showed you guys way at the beginning was a dedicated jet pump system. It was not shared, right? How many here use shared systems on their tubs? Anybody? Okay. I'm going to tell you I don't like them. Straight out. Here's why. In my opinion, if you want to make sure that every time that homeowner presses that button, and you want to make sure it works each and every time with no problems, it's always better to have a dedicated circ system and a dedicated jet pump. Why? Because there's nothing that can get in the middle of those jets and siphon off more head loss. Okay? What happens in a shared system? In a shared system, we got a filter, right? We got a heater and we got some sort of a sanitizing device. And we already said right at the beginning that just for a simple pool application with a pump, filter, heater, sanitizer, we're going to be with a clean filter somewhere around 35 feet ahead. With a dirty filter, we're going to easily be 45 to 50, right? So if we did a shared system for operating our jet systems, in the old days, getting away with 6 jets, maybe 8, we could do it. But if you're going to get into sitting there creating some of the things that are being done nowadays out in the field, like you see in a retail store with a portable plastic tub, and I've got guys that have easily done dozens to 30, 54 jets. I got a builder down in Cincinnati years ago, did a 11 by 11 octagon tub with an ADA ramp, all tile lined, and ended up with 54 jets on that puppy. Pretty nice job, $500,000 project. You're not going to do that with a shared system, okay? Guaranteed. But if you are doing a smaller system with a smaller number of jets, 8 and under is your safe point. Once you go over 8, that's where you start getting into problems. You're pushing the border there. Then, if you're going to do a shared system, you got to make sure you throw in a bypass. Think of it this way. Back in the old days, see, I'm showing my age again. Old Polynesian lounger with a little Hayward 2-speed pump on it. Also had a little Rainbow 25 square foot cartridge filter on it. Homeowners get that tub, they're enjoying it. 2 to 3 weeks of usage every week, you know, that's normal usage, right? Back in those days. And what happens after a period of time? A couple months or so. What do? They give you a call. Hey, got no bubbles. What was the first question out of our mouth? Clean the filter. Did you take the cartridge out and clean it? Why'd we ask them that? Because the stupid filter had put more back pressure on it because it's now dirty. And so the head loss is higher, and we can't get enough flow at the recommended pressure to make bubbles. Okay? That's in the old days when I had a lot more hair. This is no different. This is just an in-ground application of that exact same scenario. What did we do as Waterway? We got tired of you guys getting the phone calls, because guess what? Who'd you call? Us? Hey, no bubbles. So you know what we did? We cheated. We took that 25 square foot filter, punched a hole in the bottom, called it a bypass, stuck a spring-loaded check valve inside of that puppy. So what happened? On low speed, check valve stayed closed, all the water went through the cartridge filter and kept the water clean, right? Happy customer. Kick the pump on high because we need bubbles. What happened? If the filter was especially dirty, check valve opens up. Now, are they getting any filtration? Probably not. Would you want to be in that spa? Probably not. But guess what? They had bubbles. Did you guys get phone calls? No. So, same scenario. If you're doing a shared system, then keep in mind, especially as you start getting up in your jet flow demand, you're going to have to consider putting a bypass on it. Otherwise, as your filters get dirty, as you increase all this head loss on that system, you're not going to get bubbles. You're going to get phone calls. And in a year like this, do you guys need phone calls? In a year like this, do you guys want phone calls? No, I don't think so. That makes sense, everybody? All right, good deal. All right. How much time do I have? A few more minutes? Can I steal a few more? All right. I'm going to go through real quick, guys, and just go through air blower sizing. Who here is using air blowers along with their jets or in injectors? Okay, good. So the good news is it's the same basics with hydraulics. It's a little bit different because we're dealing with air, okay? But what we're going to do is we're going to sit there and determine what our total water depth is. So from the top of our water line down to wherever that jet or injector point is, however deep that happens to be. We're going to go through and calculate the depth of water per fitting. So think of this as in length of pipe for fitting for water, but in air, we're going to do it by calculation of water depth. Then we're going to calculate out what the air holes are, and that will help us, using a blower curve, determine what size blower would need to be used for that job. So in this case, you're seeing a couple things here. You're seeing injectors in the floor. You're also seeing a spa jet venturi being injected also. Now, let me say one thing. We just spent the last hour or so talking about how to make sure this thing works just by turning the jet pump on. The bottom line is, if you guys do not want to put a blower on a jet system, you don't have to, because I don't care whether it's this jet or any other jet. If you've done your hydraulics right, if it was installed properly, pipe size is correct, plumbing or pump size is correct, any jet should always pull a venturi, period, without pushing air through it. Now, problem is, back in the day when I was building, no one told me that. Hell, I didn't even know who my hydro rep was. And one of the first tubs I put in, I had 10 of Hydra's 10-inch Venturi T's. They were actually made by Waterway, but I didn't know it back then. I was still young. And go turn on the pump, no bubbles. That's pretty embarrassing. So I called my local distributor. Hey, Greg, no bubbles. Well, what he didn't tell me also is that, with Venturi T's, they can only be so far back, so the nozzle spacing is proper and all that other BS, which is the advantage that these don't have, or these override rather. But for a Band-Aid, he says, well, did you put a blower on it? So I stuck a blower on it, poof, I had bubbles. Happy camper, homeowner was happy, I got paid. Bottom line is, you don't have to put a blower on the system if you don't want to, if you've done everything right. However, if you choose to turbocharge it or turbo boost it or whatever fancy marketing name you want to call it, we can do that, but we need to do some basic things to make sure it works right. Okay? And two, a blower as a Band-Aid for a poor installation will not solve your problem. If we haven't done the things right that we just spent the hour talking about, a blower will not solve that problem 9 times out of 10, because blowers are not made to push water. All right? And that's what we're going to talk about, a couple key things here. So bottom line is, if you want to turbo assist a jet system, not a problem. I've done it on mine. They're fun, except for when it's really cold outside. Then they cool the tub down faster. But other than that, it can be done. But if you're doing injector systems, definitely do it. The other reason injector systems can be helpful is if you've got a really, really big tub. Now, I live in Florida. Average tub size down there is about 6 to 7 feet round. They throw 6 jets in it. They're happy. It looks frothy. Everybody's happy. You start getting tubs bigger than that. I was on a job years ago up in Chicago. It was Scottie Pippen's old house. They sold the house. New homeowners came in, had a builder come in, rip the old one out, put a brand new pool in, and this pool was 50 by 50 square with a 10 by 10 tanning ledge in the back corner and a 10 by 10 tub in the opposite corner. So they kind of mirrored each other. Except for whatever reason that day, they stuck in 12 of our power jets. It was a gorgeous tub. I mean, the jets worked. But their plumber, for whatever reason, decided that the injectors didn't need to be on the floor. Now, they had a really big body of water. If you got a 10-foot square tub, how big is your foot well? 7 foot, right? Big as an average sized tub. Now, air always seeks path of least resistance, which means it's going to go straight up, correct? Now, if you take those injectors and decide, gee, let's put them over here on the sidewall, and I'm being called out there because they're asking me how do they fix this problem, because they had this gorgeous 10-foot tub with 12 jets all the way around, And normally they're getting about a 2-foot plume from the jets, covering the benches all the way around, and then they kick on the blower. And those injectors created a perfect picture frame all the way around the inside of that footwell, straight up. So that whole tub had roughly a 2-foot square foam picture frame all around the footwell. That's not the proper way to use injectors, guys. If you're going to sit there and have a tub that's large like that, you want the injectors in the bottom. It's for aesthetics. That's all it is. It's creating froth where you're going to have dead spots. So if you don't want to sit there and shove jets down in through the face of the footwell underneath the bench, we can use injectors, put a blower on it, okay? But those are certain applications where those can work quite well. All right, moving on. So here we got our blower, we got our Hartford loops. In fact, we got a double here, and then we've got our injectors in the floor. What's the key with a Hartford loop? It's supposed to be 12 inches above the water table, right? But there are times, especially if we're shoving it into the shell, where we're not going to be above the water table, are we? Water table is going to be roughly maybe 4 to 6 inches below the top of the beam. So if we've got our Hartford loop inside the beam, are we 12 inches above the beam, or above the water table? No. That's why at that point you need to do a double. Now, you're not going to sit there and put a check valve on it because it's embedded in concrete. So we have to use a passive system. So in that instance, to make sure you get a good airlock in that thing, strongly consider doing a double if you're going to be putting it inside the beam. And that's usually the most logical place to stick it. Unless you can hide it somewhere near in the landscaping somewhere, okay? Well, why do we do this? Because we just said air blowers do not push water very well. So we need to do everything we can to keep the water in this tub, in the tub, and not in that 150-foot line going back to the blower. Okay? Because I can guarantee you, if you don't put a Hartford loop in it, like another job in Chicago, homeowner was going through air blowers at, usually about every 2 to 3 or 4 weeks. Thank goodness they were Polaris Ansons and not mine. Okay? But the stupid equipment was 150 feet away, and the blower couldn't push the water back to the tub. So what was it doing? It was burning itself up. And that was on an injector system. Okay? So key thing here is if you're going to do a blower system, or if you're going to do a passive air system, so you got 3 ways to inject your jets, right? You could do, if we were doing jets, you got an air control that you could have tub side. You could have a passive line going back somewhere in the landscaping or the equipment, or you could do a blower if you're doing blower assist. But if you're going to do any of those 2 last ones, you need the Hartford loops. All right? So moving forward, we're going to go through and we're going to calculate up what the water depth is. In this instance, the tub's 32 inches deep. We're going to also figure for every 90 or T, a 1/2 inch of water. For every U-bend or 90 long sweep, like our sweep 90s, we can do a 1/4. For every 45, we can do an 1/8. For every length of 2-inch pipe, because with air blowers, we can only use 2-inch, we can't use smaller. It's going to be 1 inch of water. And then for any air check valve, you're at 4 inches. So we take all those, throw this in this example, and we've got 8 of our long sweep 90s, that's 2 inches. We got 3 U-bends for our Hartford loop, that's 3/4. We got 60 feet of pipe, that's 6 inches, plus a check valve. Add that all up. We're at 44 3/4 of total water depth. That is your back pressure. Think of that like feet of head, is what we just went through on the jet system. Okay? So that's your back pressure. Now what do we do with that? We go through, we're going to figure up our hole sizes, and then from there we're going to go into our blower curve. So in this instance, all holes are going to be at 10 SCFM, say that real fast. And if we're doing injectors, there's 29 holes in those, in each one. They look like a salt pepper shaker. They just glue inside 1.5-inch pipe. You got 1/8-inch holes. You got a total of 116 holes. Divide that by 24, so 1/8 hole is 24. 116 divided by 24 gives us 4.83. At 10 CFMs, it gives us 48.3. Everybody see where that's coming from? Okay, cool. And like a pump chart, we take our blower chart, and we're going to sit there and take our total water depth, which is right here, and then we've got our SCFMs on the bottom. And so we're going to take those, we're going to throw them into our pump curve. So we're at 44.75 of TWD, and we're at 48.3 of SCFMs, and that's telling us that a 1.5 horse is too small, but a 2 horse would do it. Okay? Everybody good with that? All right, cool. Now, what's the most important thing that homeowners want in their spa? It ain't magic to make bubbles. We just proved that. We just spent an hour and a half going through the math. Okay? So, in summary, it's as easy as A, B, C, D. We're going to sit there and figure up our jet flow demand. We're going to blueprint our pipe size, calculate our total head loss, and that allows us to then determine what size pump we have to use. All right, guys, that's all I got. The rest is just all promotional marketing and bluster. So obviously, those are all the different things that we make in the USA out there in Southern California. So appreciate your time, appreciate your listening to how to make bubbles. Everybody passed. Love it. Yes.
You're running at full speed.
The best, the one and only takeaway that I want you guys to remember is when we're using variable speed, and come July 19th next year, I cannot make and sell anything but 4 large self-priming pool pumps in the US. None of us manufacturers will be able to. What does that mean? That means every doggone pool pump, after you guys run out of all your inventory and the distributors ran out of all their inventory, at some point in time in the near future, we're going to be shoving variable speed pumps on a device that doesn't need variable speed pumps. Because jets weren't designed to be variable. They're like floor systems.
Yeah, but Jason, we usually, for our 8 jets and our hot tubs, we're used to using 1/4 horse per jet.
True.
We're putting a 2 horsepower pump out there.
Yes.
And we're going to be replacing them with 3 horsepower pumps.
Which you can't.
So we don't necessarily have to run it at 3450.
Yes, you do. That's the whole point of this exercise.
I can say definitively in practice that you can set these things up at lower flow rates than 3 horse, and they work. They work. Run it at 2 horse, run it at 2.5 horse. Talk to your Pentair reps. They tell you to run these things at low, medium, and high. Variable speeds give you multiple.
Let me ask you a question. Does Pentair still have their hot water division? No, they sold it off 2.5 decades ago. Okay? They don't know the first damn thing about a jet. Period. I know what you're trying to say. The bottom line is this, and this is the whole problem. We've been dealing with this since '05 in California. Okay? That's where it started. It's gotten worse. The problem has gotten worse because I'm the guy, because we make so many of the jets in this industry, we're the guys that get the phone call saying that our $24 jet won't make bubbles. The problem is it's not the jet. The problem is either the plumbing hasn't been done right, so the plumbing's either inadequate, or we've got too small or too big of a pump on it. Those are the only three things that can screw up making a jet create a venturi. Either we're not getting enough water flow too because we throttled it down with too small plumbing, or we put too small a pump on it, so now we're not getting the flow rate, or, what's that? Well, there's the second part. The second part, and this is what's been happening, is with variable speed pump, is now we sit there and have a fancy 3-horse whisper with, or a 3-horse whisper flow pump with a fancy motor. And if we ramp it up to get full RPMs, the next step's going to be is I start blowing out internals, because this thing's not sized for 120 GPM unless we put in 12 jets. So that's where I'm going with this, is that if you're going to use a 3-horse whisper flow with a fancy motor on it, then you have to sit there and size your jet system to match that, which means we're at 120 gallons a minute at 50 feet ahead with that pump. I was an old Purex guy, WFE 12s. That means you need, if you're going to do a 10 gallon per minute jet, you need 12. If you're going to do a 15 gallon per minute jet, you need 8. So as long as you do that,
Can't you pick the speed of the pump?
all right, let's back up, because that was the whole reason of this hour-and-a-half exercise.
I understand, but I guess my point is that I get a spec and it's got 10 jets on it. You're telling me that I need to...
You either have to get a pump that's sized properly at that 3450, or you have to put enough holes in the tub to accommodate whatever the flow rate is.
Right, but I don't have to run it at 3450.
Yes, you do.
I can run it at any speed over a certain speed, and then once you dial, like if you're setting a pool up for the first time, you turn the variable speed pump on, you go up to a speed, okay, there are my bubbles, and there's my low speed, and you go up to a higher speed, you give the customer 2 speeds, a low and a high. I do it on all our pools. We don't use blowers, they all aerate, and it's great. And we use waterway jets.
And how many jets are you putting on?
Typically 8 jets.
Polys or powers?
Polys, not the spinners.
It doesn't matter what the eyeball is.
Right.
Okay? This is a poly, but this is only 10 GPM. The problem is this. It goes back. Let's go back to what we were talking about before. Okay? If you have a 2-speed pump, when we decrease flow, we are cutting pressure by 4 times. Okay? So the same thing's going to happen with a variable speed pump. The difference is we got more smaller speeds.
Right.
Okay? So
Or higher speeds, depending on how you look
no,
at it.
there's only one 3450 on every pump.
Right, but if I'm replacing a 2-horse with a 3-horse,
Yes.
that's what we're talking about here. Is typically, I'm using the 2-horsepower jet pump, and I've never had problems with our jets. But
Yes.
now we're using the 3-horsepower pump. So you're saying there's only lower speeds, and I'm saying there are lower speeds, but there's also now higher speeds over and above. You know, if I'm running at 2-horse, and now I replace that pump with a 3-horse.
Aren't you then the net excess pressure and excess?
Yes. Yes.
So his point is in the field, practically, he's finding the happy medium just by dialing it in.
Right.
You're saying that's not possible, or that's not?
It doesn't work that way. I've had some guys that have told me anecdotally. I have never seen one in the field because, trust me, every time I'm getting called, no bubbles. And I've seen it on 6. I've seen it on 8 jet systems. And I'm not saying that you can't be on the border, because that's the thing. At 60 to 80 gallons a minute, you can be somewhat on the border, but it also depends on the pump. The problem we were running into, okay, let's go backwards. So let's go back. Title 20 goes into effect back in 05. Every tub in California always has had 6 jets. They still do it that way. They don't change unless they're doing high-end neat stuff. The problem is you take something like an IntelliFlow, which is a 3-horse whisper. That's a WFE 12 wet end with a fancy motor. That's all it is, pure and simple, okay? Same as my Champion 300. That Champion wet end is almost identical to the whisper, except for we got a larger trap. It's about the size of a Super 2. Same flow rates, but also same problems. And the problem is this. If you got 60 gallons per minute of jet need, and you sit there and try and dial that pump down, That, in essence, which was exactly what I was using in my analogy, would be the same as if I took a 120 gallon per minute 2-speed pump and sat there and turned it down on low. Because what happens with a low or 2-speed pump? If I'm at 120 on high and I kick it down on low, what flow rate I'm at? 60. But the problem is pressure also drops off exponentially. So if I'm getting 15 psi on high speed, then on low speed I'm down in around 3 to 4, period.
So essentially, to have the pressure high enough, the flow is going to be excessive, which is going to wear out the internals.
No, not if everything's been sized properly.
Well, I'm saying if we leave the internals
Oh,
to a 3-horse,
well, again, everything has to be sized properly. So
because you have exponential pressure loss, if you go down to 60, you got to stay higher than 60 GPM, but now you're wearing out internals because too much flow.
if we're a 6-jet system, yes. Okay, and that was the second part. So the second part that happened out in California is the guys go, oh, once they realize what the problem was, I'll dial it up because that's the bill of goods we've been sold as an industry. These are variable. We should be able to dial them up. Doesn't work that way because then what happens is these things, these seals, one of two things are going to happen on this jet. Water's either going to bypass that seal and flood out the air chamber, at which point you'll see water coming up the airline or maybe going back to a blower or whatever else, okay? Or, worst case, it's going to blow one out, at which point could damage it. Now, it's only $24 retail.
Put a bypass on there. If you're using a jet pump, you can bypass it to the return line also. There's no point doing it. I guess my point in saying it is that most of us in this room are using a 1.5 or a 2 horsepower jet pump.
Right.
And we're replacing those with a bigger pump. So we're not running into the situation where it's too little flow. Because I can always go, of course, more to the jet than I did before. Where I'm concerned about it is the drains in the bottom of the spa can't support the flow rate of the pump that is now on the system.
Well, that's a whole nother subject.
That's a whole
That's a whole nother subject.
for another day. But what I'm saying is if you're replacing jet pumps with 3-horse IntelliFlows, you're not going to have this problem ever.
Yes.
You have like 20 jets.
No.
You're going to have more flow than you need. You're not going to have too little.
What they're talking about is the pressure the pump makes at lower speed is not enough to create deterioration in the jet.
Right.
But I agree with you. I've had pumps that I can dial down and get air to pull. But I've also had ones that don't work either.
So what's the play for the renovation world?
That's the fun part. Did you notice that? Let's do this.
You may not know what the suction line is.
Can I get it back to? All right.
You know, you may have an 1.5 inch suction line under some of the pools in Florida, you know, and what are you gonna do? You can only pull so much water, but you're putting a pump on there that can pull more than the system is designed.
I can't get her to go back. Am I going forward? No.
See, and I kind of with you too, Mike, because you're wanting to use a single pump because it's cold. So you want that pump to run low speed versus have a dedicated jet pump.
When it comes to the jets, or with the waterway jets, you need the jets to be set at the right depth in the spa or they don't work. It's gotta be on the W. You wanna cut the nozzle on the W of the waterway.
I've gone too far back.
That should be in the presentation. Cut the nozzle on the W and they work.
Come on. Can you, Zach? Yeah, I want the picture with the pumps and the rule of thumb. That's the one. All right. Here's the bottom line. If you're going to do 80 gallons a minute on jets, that's why. Got to turn it on. If you're going to do 80 gallons per minute on jets, you've got to make sure, and this is why all of us manufacturers have come out with different size variable speeds. Used to be 165 and a 3-horse. That was the norm. And honestly, I thought that's where the industry would go with this. And then one of our friends decided to come out with 1s, 2s, 3s, on up, okay? And guess what? We've all followed suit. So the bottom line is the advantage that gives us is I can now size a variable speed pump to every flow rate application. Where before, when I was doing this exercise 5 years ago, I had 90 GPM and 120 GPM. Now, of course, I have a pump that'll do 160, but nobody was buying it to any degree because we were still the baby of the bunch, even though we've been around for 47 years, okay? Now, since some of the other manufacturers have come out with some larger pumps, there's some others out there that'll do 160, but most of the applications are going to be built around that 120 because what's been the predominant pump in the industry for the last 10 years in variable? An IntelliFlow, period, which is, like you said, it's a 3-horse, a WFE 12 with a fancy motor. That's all it is. It's a full rate whisper flow. I'm an old Purex guy, so, okay? So that's 120 GPM, plain and simple. So there's one of two ways we had to solve this problem in the past. Go grab a smaller impeller and change out that wet end. Hey, we've had whisper flows for years. Guess what? There's all different size impellers. I have 1s, I have 1.5s, there's 2s. We can go steal them. I ain't shoved it inside there. Guess what? The flow rate I have now created on that pump is whatever the maximum of that impeller is, okay? Or you can sit there and add more jets. Those are the two ways we can solve the problem.
Change the jet nozzle.
Well, we used to.
Change the pressure at the jet nozzle.
Well, how are you going to change pressure? These have to have 15 PSI.
Change the orifice.
Can't. These are fixed. That's my whole point. Look, here's the whole problem. We have taken this industry to its highest level. We have now got this stupid thing where there's 3 to 4 lousy parts in it, period. It's not like my old polys where we have 16 parts in them. That's why they're being discontinued this year. Because with everything going on with COVID, we don't need to make more parts. So the problem is this thing's been refined to the point where there is no field adjustment. If I take a 3/8 drill bit and run it down here, I can tell you what's going to happen because I tried it once. Okay, because our old clip-ins were large enough where we could sit there and do, we had different size nozzle inserts, okay? That was a whole nother presentation at one point. Now I don't have to do it anymore. But the bottom line is if I run a 3/8 through here, we will literally rip this whole jet apart because that thing is that small. So there's no field adjustment. Now on the powers, we still have interchangeable nozzles. We can field adjust those. They come standard with 15 from the factory. You can sit there and add any one of the other 3 to go smaller or larger from 10 on up to 20 GPM, okay? So that you can play some games there. But here's the whole point of this exercise. If we go through and you guys do what we just talked about in the last hour and a half, and you make sure that your project is set up that way, we want that thing to be down that sweet spot of that jet chart that I showed at the very beginning. That gives you some plus or minus. Not much. We're only looking at a couple gallons a minute either way, okay? And only 5 PSI either way. But the thing is, if you go too low to one side or too high to the other side, you run the risk of that system not working. It may not. There's a little bit of tolerance, but not much. So if you stay at the sweet spot, I can guarantee you it will work each and every time. So that's the bottom line with it, okay? So switching over to a system where now you're going to go to a variable speed pump, you have one of two choices. You can go ahead and add more jets to match that high-end flow rate, or you'd have to go to one of their smaller variable speed pumps that if it matches whatever your flow rate is designed on your tub. Those are your choices. Because there's going to get to a point in time, it may not be this year or in the next 7 years, but unless Pentair starts adding more selection to their whisper flow bodies, sooner or later those single speed impellers are going to go bye-bye. So changing out impellers is not going to be an option after a period of time. As a manufacturer, legally I have to make parts for 7 years. After that, I don't have to. I can discontinue it. Now, have they ever discontinued pumps that they bought over the years? Oh my gosh, Duraglass, forgot about that one. So yes, it can happen. But what I'm trying to get across is if you size your system accordingly, then you won't have to run into that problem. Okay?
I think, I mean, in a Florida market, Mike, you bring up a good point. Like if the stent, you know, capability of this pump is 120 GPM, and I'm exceeding the flow rate of the drain cover, it's an illegal installation anyway.
Yeah, you can't.
Change the impeller. Inspector's not going to trust me that I changed the impeller. So from that standpoint, the big pumps are not enough.
What drains are you putting on your tubs right now?
I'm saying in a simple, even a simple resurface.
We're using channel drains typically now for the flow rates.
Okay, yeah.
We'll take 2 suction ports out for the jets and then 1 suction port out for the spa drain.
Okay.
There's typically 3 ports in the bottom of the channel drain.
Whose channel are you using? Is it ours?
Aqua.
Yeah, I'm not sure they're flow rate.
A lot of waterway drains that we use.
Where are you at?
Philadelphia.
Philadelphia? All right.
I mean, we buy a bunch of stuff from waterway. And we'll use your circular drain pots and we'll just do 2 of them, 4 of them. Big deal.
Okay. Yeah, I can tell you, like on our strip drains, depending on whether it's the Diamond or the Ultra, we're ranging around 320-ish to 350. So those things are sized enough to where they'll do most application what you're talking about. But now, the other advantage we've got there is we're at 2.5 inch on the plumbing. On the back, you go either 2 or 2.5. But even at 2.5 inch, you're at 80 GPM at 6 feet per second. Okay? So if you bring that together into a T,
We're running it back at 3 inch.
yeah. So then you can do the 120. You're not going to do the 160. I mean, I just went through this on my pool. You guys would.
I guess
Shit.
I'm just gonna ask.
I ain't
a
showing
stupid
pictures.
question then again. Why not just stock the 3 horsepower pump? Why? Because then you've got everything covered. You know, why would you stock a horse and a half?
Well, if we're talking jets, no, a 3-horse is not going to sit there and do everything. What a 3-horse is going to do, if it's an IntelliFlow, a 3-horse is going to do this. If it's my SVL and a 3-horse, it's going to do that. But a 3-horse is not going to give me that, because as soon as I dial it down, I lose pressure.
For your 6-jet example in California, you could still put a 3-horse IntelliFlow out there and dial it down.
No, they didn't work. Trust me, they've never worked. That's the problem they're having.
It's the pressure, not the flow.
Yes. Look, the best thing that I can have you walk away from out of this whole exercise is that this stupid thing, like an in-floor cleaning system, requires a fixed flow rate and a fixed pressure rate. And that pressure rate happens to be 15 PSI. If you have a caretaker floor system and you don't run enough pressure, what happens to the heads? They don't pop up. They don't function. Now, you may have flow. It may be kind of oozing out, but you're not going to.
So I have a question, just maybe this will
Shoot.
help with. Do you know what's your PSI at 2,800 RPM on that PDVSC 300?
No.
Changes on the system.
Well, that's what I'm saying. I mean,
But think about it, when you look at.
and I guess that's what you're getting at, is like, you know, like if you're at, can you set up, I guess you have to set up plumbing to address that, to where you're dialing it down to where you have 15 PSI at 2,800 RPM. And I guess that's what
In theory, it could be done, because if you look at some pump curves, If they're high enough, you can see where it possibly could cross. The problem is keep in mind, if we went back to that jet, let me.
Well, we like to keep everything simple, so.
Oh,
If
hey.
it's at 3,500 RPM and we know that's gonna work, that's
Well, and that's the bottom line is that, look, to keep life simple, guys, in the years that I've been doing this, I found out that basically, if you keep in mind that everything's got to run at 50 feet ahead, the math gets to be real simple. Because now you can group everything in groups of 4s and 8s, okay? Because you can work with 40 GPM and 80 GPMs. And if you start looking at most of the pumps that are out there, mine included, the way those things are sized, we can now start creating, and that's why when I work with guys that are doing these multiple jet projects, when I'm looking at what they want to do, I am always trying to keep them in 4s and groups of 8 if at all possible. So 4, 8, 12, 16, 20, 24, 32, on down the line. Why? Because if I can keep those in groups of 12 or 16, guess what? It'll do most of my pumps. It'll also do a number of the competitors' pumps.
Would you advocate that a variable speed pump or a single speed pump should still be, I mean, I know everything's happened, we just had a session with Pantera on,
Oh, yeah.
you know, this is all going down in 2020.
We don't want it.
It wasn't on that list of, you know, people that were involved.
Oh, yes, we were. Yeah, we're not even going to get into the mandate, okay? That's water over the bridge.
But essentially you're saying that every variable speed pump for a spa application is a single speed pump.
Has
Yep.
a fixed curve point on its curve.
So,
It's only
all right.
that 150.
So when the committee was created, yes, we advocated very strongly that this was a total waste of time because from a spa-related application, it's
The
mute.
only argument is that the pump's a little bit more efficient because of the way the motor's constructed.
You got a TEFC motor, yeah, that's great.
If you're running a variable speed pump at 2 horse and it's a 3 horse.
Right, but remember, Mike,
But you're not.
But if you got 15 PSI, kick it down to 2,000 RPMs and it goes to 5 PSI, that's what he's saying about the jets. And, you know, it might be running at 2 horse equivalent, but.
I get it, but what I'm saying is there's no energy savings.
Oh, right.
If you gotta operate those jets at that fixed
Well,
point.
the only energy savings
Whether your
is that.
pump's a variable speed or a single speed, you're operating at 1 point.
That was our whole argument when the committee was created back in 15, okay? It was a total waste of time. And you notice, if they went through the full gambit of DOE, what was it? What was the part on spa pumps? Did they have to be variable speed? No, they're exempt. Why? Because it doesn't work. The things run for 20 to 30 minutes and they're shut off. The timer makes sure of it. Okay? Same should be true for a pool application. The problem is we're using pool pumps to also do spa jets. So guess what?
But there's no exclusion for what's
No.
dedicated to spa.
It's not based on application. It's not based on application. And hence, that's where we're at. That's why I'm running around the country doing the seminar for the last year and a half because our phones are ringing off the hook. Because guys are now, who never have done variable speed before, going, hey, I'm putting these on, and your $24 jet ain't giving me bubbles. Your jet doesn't work. It's not a jet problem. We've already proven that. Okay? So it's not fun. We got to live with it. It's the mandate. But the good news is, if we plan accordingly, like what we've talked about, we can set up our tubs to operate properly. Is it going to be more expensive than what we were doing this year? Heck yeah. It's only a whisper flow with a fancy motor, guys. No different than mine. It's a more expensive motor. Yeah, it's got TEFC, permanent magnets. But
using the new pumps that are getting 240 gallons per minute, then you're saying that.
I'm sorry, I didn't hear the question.
What if you're using the new pumps that get 240 gallons per minute?
Enter new variable speeds.
You mean their XF? Then the 5?
Yeah, the XF.
Yeah, same thing, because their XF3 has got the same flow curve as my SVL. Same problem. You've got to sit there and size that thing based on.
So you're saying then, based on those jets, we would need 24 jets.
Yep. 12 times 2 is 24. Exactly. Now, you know the good thing about this is being one of the only jet manufacturers left in the industry, especially in the US. If you guys are sizing your equipment right, or your tubs right, I get to sell more jets. Now, on the other hand, you guys can also make cooler projects for your homeowners. My pool at home, I got a new pool being put in right now. I got 16 jets in it. Why? Because it allows me to size it to that PD VSA 300 right there. Okay? The tub I had up north on the house I just sold, that is 16 jets. It was running that in a single speed 67 feet away, and in a triac shell that I plumbed myself, because back in the day, triac only had 6 jets pre-VGB and looked like crap. But 16 jets in that little tub, that 7-foot fiberglass octagon, that thing foamed. You know, it rocked and rolled. But I've had homeowners that have sat there, you know, had a builder a number of years ago out in Nebraska, 32 jet system, 9-foot tub. Hey, looks cool. Homeowners love it. So the fun thing is that the second part of this that we haven't even spent time on, that's a whole nother gambit. The technology is there in concrete, in vinyl, in fiberglass, that if we want to sit there and step these up a notch and start doing some cool things like they're only seeing in the plastic retail tubs, it can be done. I've got builders that do it all the time. Okay? That's taking it to the next level. That's where it's important to do the things we were just talking about. But that can be fun. Okay? Now, next part of this is, so, let's see. Nah, we'll leave that example alone. All right, any other questions? That's all I got, guys. Appreciate your time. No problem.
All right, let's take a quick break, and then we'll
4 o'clock, not too bad.
Oh, very good, actually. That dialogue at the end, priceless. Yeah. Stupid questions, but priceless.
Well,
they're the best ones. Because you don't want them walking out of here thinking that. Yeah,
you won't know how many times that I've done the seminar, and a week later I get a phone call because they thought it was a dumb question, and I'll get the same question.
Yeah, yeah.
But
And you're like, okay.
well, hey, it comes up, and I get it. Well, the problem is as an industry, we've been told one thing, and that's not what happens in reality. And I've also had guys that have told me, I've never seen one, but I've had guys that have told me that with an 8-jet system, they've been able to make it work, but yet I've still not seen one today. Okay? So.
All right, so let me ask you a question. Because we've used the IntelliPro VSF for
Not sure if anybody's got anything from today or any other topics they want to talk about, challenges. We can do best of, worst of, kind of stuff, even though that takes a little time to do. I mean, who else? Anybody got anything?
I got a question.
Yes, ma'am.
On vanishing edges, anybody that's in the freeze-thaw area, what type of products are y'all using on the vanishing edge portion?
On the top or on the face, on the outside face?
Like on the top that the water's running over.
When we're putting tile on it, definitely I would prefer to use personally I'd rather use like a 12 by 12 tile, bigger tile. Biggest problem I've had with the vanishing edges that we've built has been the grout joints and the grout we used and water getting underneath it. I mean, of course, up here, it's, the vanishing edge becomes your overflow. So any extra rain, snow, so it's always full during the winter. So it's still a lot of water, a lot of freezing, that kind of thing. We don't tile a lot of our walls, although the one we'll see tomorrow is one of the few that we did just because they don't really see it and they don't want to pay for stone on it. Mostly stone. I mean, you see my vanishing edge at my house tomorrow. It has stone on it. Now there is some leaching, and out of the stone grout, as much as can't see the shell, but that you have that kind of to deal with. But most tile on top, and I use a bullnose tile at the top of course a lot of these companies used to make a 3 by 12 bullnose. That's not as available as it once was. So now we're cutting down a lot of tile into 3 by 6 bullnose inside, and then letting that, be proud of the top of the wall, and then doing your flat tile off of it. So there's no joint for the water to get under the tile that's on flat.
We do it not at night then.
Huh?
Forward slipping towards the basin.
Yeah, towards the basin. Yeah, not knife edge, towards the basin. So, little varied.
If you guys notice, those of you guys who are using like Shotcrete or waterproofing, like in Florida, almost nobody waterproofs a shell before they plaster. And I've seen some shells that were in really bad shape. Did you notice a big improvement after you started waterproofing on those spa walls or vanishing edge walls, that you weren't losing tile as much, you weren't having as much material pass through or efflorescence pass through?
Yes. Well, I've done at least a half dozen renovations on raised walls, finishing edge walls, and spillover basins, and just with Acuron, what I've been using on the inside and outside of the shells. And these are pools that we didn't build, fortunately, that have had this notorious problem with tile. We have to go back every year and patch tile. In the past 5 years, I haven't repaired any of the jobs we've done with Acuron in our area.
Although, to be honest, traditionally, we haven't used a whole lot of waterproofing. I've started using Shotcrete this year probably for the first time on the few, not even vanishing edges, I've been doing a lot of the, I guess, exposed pool walls. I call them poor man vanishing edges. But I've been using them on some of those. And I think all the waterproofing personally is just an extra layer of insurance. It's hard to tell. I mean, I think it goes back to the Shotcrete work. Because we have had projects that don't have problems, and we have had some that do, and I don't know if it's a have to have, but it's a good insurance to have. I know Josh uses Shotcrete way more than I do.
Well, in your circumstance where you're doing a lot of renovations, the Shotcrete product is bond coat too. So if you're bond coating the pool, you might as well use the one that's a waterproofing agent too. It's the same price.
Have you guys had any issue with your plasters not liking it?
No.
The plaster applicator, our wet edge applicator, hates it. He's like, if we use this, you got a bond coat over.
What does a plaster applicator like?
What's that?
What does a plaster applicator
No,
like?
I'm saying he's used to bond coat.
No,
so-
it is. Well, you just got to tell them it's a bond coat and show them that.
But when they show up on a job, they literally walk away because of the different feel or whatever, the look. Like they know it's not bond coat, and so for me, I'm going, okay, now I have to find a different.
Well, it is a bond coat, and you can get.
No, I understand it technically, and I know Vito will support that.
Right.
But I just wondered if anybody else was having that issue. He's saying that it's been an issue where the material's not sticking to it the same.
Yeah.
And his guys aren't liking how it's working, and so I'm like, okay.
We had an issue with that initially because our guys weren't applying it thick enough and coarse enough, so they were applying it too smooth.
You got to use the right nap.
Right, so we had to make sure they were using a thicker nap, and they were making sure that the material was thick enough. Of course, they want to add more liquid to it to thin it out because it's easier to apply.
Yeah, like if you use a squeegee on it, it looks great,
Right.
but it's not effective.
Right.
So you actually want to make it look like spiky.
Right.
And then it's pretty effective. I mean, to answer your original question, from an efflorescence, we do a ton of raised walls and vanishing edges. And I mean, it's not cut efflorescence down to a zero, but it's come pretty close. I'm extremely pleased with it.
Did those guys actually train you with somebody who knew what they were doing, or did they send?
Yeah, I went down to Florida to do it. And
I mean, I'm 2 hours away. He sent Jim Bob from South Florida, and the guy who trained us wrong. We had to redo it twice, and it was a mess.
I don't see it to be that complicated. I mean, like I feel like if you can hold paint, you're pretty good at it. But we haven't had any so far.
I guess it's just a really bad initial first taste, coupled with the fact that
My plaster guy plastered over the bubblers and then he blamed it on the base green. I'm like, okay, great job here. Like, just free plaster the things. With the worst client ever.
All right, anything else? Who's got something? Yes, sir, Bob.
So we're all scheduled out for a year or plus. Any tips, any thoughts on how we stay on schedule, how everyone manages their schedule? I mean, so we have no idea what the weather's gonna be like. Your guys, how many guys are we gonna have in 3 months and 6 months, and what's gonna happen with materials and subs? And we're saying, oh yeah,
mind that
bigger
right
issue
now.
is making sure your sales guys don't get bored to the point where they go find
I,
something else to do.
No, I mean, our guys,
don't care.
our guys are like,
if I can free up my
their
schedule.
morale is higher than ever.
Really? Okay.
Because they've sold so much, and it's literally, it's like customers call.
Yeah.
They've abbreviated our presentation, it's hurt our average ticket a little bit. People are going, just when can I get on the list? What's the time frame? I want on the list, and it's easier for them right now than it ever has.
Could you pay them in a draw schedule, like the sales
Yeah, you
people?
could, you could do a draw against their commission later on.
Well, they're getting paid on a lot of jobs we're doing right now. So it's
Yeah,
like,
that's
the
why
book of business is.
Doesn't matter when you
That's
sell.
right. It's just, there's gonna be a point, and I mean, I guess we're all aware of it, maybe. I mean, you guys heard this morning, like, I'm only 12 years in this, and we've grown very, very quickly. We've only been building pools for 6 years. And so I haven't seen like a cycle, you know what I mean? But, I mean, I'm
None
not
of us
the
have
coolest
seen this
man.
cycle. I don't think ever. This is
I
a
mean, that's what I'm getting at. At some point,
this is a 100-year
it's going to
flood
stop.
here.
And it's going to, even if it doesn't stop, it'll fizzle out, you know? And
But I've done it for 43 years, I've never seen it.
yeah.
Never.
I mean, I think the only positive is, you know, especially in some markets, they've made multiple phone calls, and since we're all in the same boat, I think they are at least have some, you know, better understanding that they know they're not going to get something tomorrow, and if they do, then you don't really want to work with them. I mean, I've got people.
It's just economics at this point. Demand spikes and everybody, and then the resources are low.
That's been the only positive part about it. Is they don't.
Pricing on them, but
Yeah, we try to put some things in place and we feel better about where we're at on what we're gonna do.
Have you guys all sort of adjusted pricing based on demand?
We have ours.
I mean, and limited
I did
supply?
back, I figured that things.
If you're not raising prices right now,
Right, I mean,
Everybody
to me, that and the ability to draw talent into the industry that might not otherwise be interested because there's such demand in the industry and such a kind of a maturing, that's pretty exciting to me. I mean, if nothing else, we'll get some talent into our game that, you know, hopefully we can staff and catch up on the business side because the operations are just at max capacity.
yeah, but everybody wants more money. Like, we used to be able to hire people for $15 an hour. People work at Burger King for $15 an hour. Costco, yeah, or Target. So
pay them 25 and see what
we're having to pay our employees more.
might work out.
So, yeah, there's definitely going to be upward pressure on price, I think, for sure. But we were shut down for 2 months, you know, so how do you hold a construction schedule when your governor shuts you down?
You know?
You can't. So then when the customers call and they complain, I thought this was going to be done by Memorial Day. Do you live under a rock? I mean, really? We haven't been able to do anything for 2 months. No, we're not starting to do it. I mean, what do you want me to say? We couldn't come to work for March or we couldn't come to work for April and May this year. So our schedule, if you think you guys have the problems, just think of Pennsylvania and New Hampshire and some of these states up north. It's like we were shut down and we had no idea when we could go back. It's a nightmare. So, but customers seem to be, you know, if you tell people fall and you get them started in the summer, or you tell them next winter and you get them started next fall, like you under promise and over deliver.
I agree with that.
You know, that's all you can do.
Yeah, just vague timeframes.
Yeah, tell you I'll get you started next fall, and if you get it started early.
Just get better at dancing.
The hard thing for us is the permits. Managing when we're going to get permits has become difficult because a lot of the municipalities shut down too. There's no one there reviewing permits.
They don't do it online.
So we got like 20 permits sitting there under review when we all got shut down. No, they want hard copies, you know, they want hard copies, 4 copies of everything. I mean, it's so stupid. It's nuts. So I think customers are giving us a little bit more leash because they know what's going on.
If they're really smart consumers, which most people are, and you really boil it down to like 2 or 3, but they've gone out to shop for a boat, it's not there. They went to go get a bike and they're not available. And so it really boils down to the 2 or 3, but they were going to be jerks. So we don't have any great answers, but we just broaden it out. I mean,
You just under
or just be honest. Just say, look, I don't know. Yeah.
No, I lost a pool
That's the
last
best
week
answer
because
sometimes.
my competitor lied. I said, sure, we'll get you in this fall.
Yeah.
I know that they use the same gunite subcontractor as we do, and I called the sub. And they're like, I don't care if they move that job up, but we're giving them the same number of pools a week as we're giving you. But I lost the job because a competitor lied to the customer and said, we'll get you in this year. No friggin' way. I know that. I told the customer that. They chose to hear what they wanted to hear. They're not even gonna have a permit by this fall, so whatever, but be aware that.
You don't want those customers though.
No, you don't, but it's hard to lose, it's hard to lose a job at it.
Oh, yeah.
You know, when it's not about price, it's about start, when you're gonna get started. That's frustrating for me.
I mean, if they come back, it can be about the price for you.
Side note on there, yeah.
Yeah, I mean, it is what it is. The ball's in your court.
We've had multiple customers that sent it to 2 months ago, and they're like, we're ready to get started. And my sales guy was like, do I give him that price? I mean, it says on our estimate, and we do, very basic start. We won't even give you a real hard price until we do a full design on the project. And it says, big bold letter, just good for 30 days. And I said, no, go ahead, because we moved everything to 2021 pricing at this point, because we're selling pools and we're expecting increases on we do a lot of subcontracted work, and we're expecting increases and equipment increases and all that. And, because he's like, are you sure? He's like, I don't want to lose the sale. I said, just do it. I mean, I promise you, if there won't, no one can get to them. And, because it went up about 10%. We sent it to him, and he had a check and a signed contract back to us the next day. Like, they don't, I mean, we are in such a good spot right now. We should not be worried about charging more.
All right, so have any manufacturers been either good or just all terrible at products this year as far as inventory? Anybody been good? Anybody got a good? Who? Paramount. Any other vendors that?
Spectrum's been on top of their stuff.
Yeah.
Cameron told me I didn't
Huh?
hit, they said that we didn't beat our total purchase from last year, and I asked him how much I had pending, and then he said, never mind. There's so much, I don't know about you guys on your main manufacturers, but I don't think I'm alone, but we're waiting on,
Everything.
Oh, I mean, I've got probably $50,000 to $100,000 worth of stuff on order, and I just placed an early buy that I don't know even when we'll get it.
We're getting like 1 heater a day from Pentair.
Yeah.
It comes in on like a broken skid, and we get the skid quantity discount, but I mean, it's like,
Oh, they can't
if I
make them.
place an order for 100 products from Pentair, I might get 2 on Monday, 3 on Tuesday, 4 on Wednesday, none on Thursday, 1 on Friday. It's unbelievable. It's really
they told
bad.
us 90 days.
Huh?
Any orders through UAG, he said expect 90 days. Right.
Is that regular buys and early buys?
No, he said the early buy, we could get that sometime in March, maybe.
When the terms are due.
Yeah.
I didn't place one just for that reason.
Really?
I haven't placed an
I
early
just
buy.
didn't think I was gonna get it. I didn't think it was worth like stacking up this stuff that was like, I just piecemeal it as I need it.
Oh, we just had, we sold so many jobs, we just did the math and said, okay, well, we know we're gonna need all this shit. March, April, May, June, and we just got enough to cover that. In my office, my operations manager who puts those orders in, she asked me, she's like, so do you still want me to, and I called Ryan, and he's like, man, you need to be making an order, like, if you need product before then, you need to be making those orders now. 'Cause
Yeah, we've been placing orders. I mean,
We just got our
big orders.
last shipment from, it was like a late May, early June of heaters, just finally got those in.
I mean, anything made in California has been terrible.
Anybody have a?
New York was pretty tough for a while.
It's really funny it comes in, it's like 9 heat pumps and then like one pump.
Artisan, whatever you wanna call them.
There's onesie twosies.
Yeah.
Oh, they're spreading around.
I've been told.
Are they?
They're in trouble. Just don't order handhelds right now from SR Smith.
But we serious.
Oh, it's-
Is there anyone else that offers
You're not
that?
gonna get it. You won't
We're
get it.
starting to look at the, we have slides, that's what smells like, we sold to customers, we're looking at all different options, we're pretty much completely done.
You're not gonna get it.
What was that again?
S.R. Smith.
We've pretty much
Pulled
cut all,
everything?
pretty much cut all ties, and we got your slides and handrails, stuff like that. We're looking at all other options.
What was the issues?
We can't get them.
No product.
They can't even tell you when you're gonna get it.
Yeah, we have a slide on order that
Yeah,
they
we went,
said December.
yeah, it was the last thing on the job, and we're just like, we gotta get that slide. It looked identical, that's our.
You know what's so weird though? We had a warranty issue and they had it to us in a week.
So who else does rails? S.R. Smith?
We use Safetron.
Safetron.
Yeah,
Huh?
we use Safetron. They're down by me.
Safetron?
They're like 6 weeks.
I know Spectrum tends to be more of a commercial company, but they are also another.
Zodiac is a full line that just.
Yeah, Zodiac just.
Really?
Complete also. So I would take slides to Global, which is a newer manufacturer out of Detroit. They knocked off all the interfax slides and got the words out, and I would take rails and probably to either, probably Zodiac. This is Fluidra, it's the old straw line, but they made it fat tubes. Remember a straw was always a skinny tube?
The the 1.5s versus the 2. Which 1.5s you can use for ADA stuff, but yeah.
Has anyone had any mold defect issues with Life Lounger?
Oh, I got one. Oh, no, I haven't had that.
I haven't had a customer that likes their lounger.
Really? You don't use
No.
it? Are you using SR?
I have like 7 of them in my office. That
They
people
look
are like,
good.
they look good, but they're like,
You
I
have to
can't
get the
sit-
head pillows.
Huh?
You have to sell them the head pillows.
It's the shallow one. You guys got, you have the other one. It's like pliers.
I've got the deep one up there, but I think the upright ones are better.
If you don't have the sense, you must miserable.
Go about 4 to 6.
Yeah, you gotta have the head
I don't like a deep sun shelf. It's like wading through.
The common complaint is it's not comfortable.
Is it because the head pillow?
It's the head pillow.
Is it the head?
That's the consensus, Josh.
Alright.
Call your rep.
All right, now that Pentair's gone too, anybody use Pentair sand filters, TR series? Anybody had a problem with bulkheads? I've had 20 tanks with bulkheads that break.
We've only done 3, but 1 out of 3.
Oh, so
We've replaced every bulkhead, all the tanks you see over there right now, all but 4. We've replaced all the bulkheads in those.
High flows right now too, they're on the gas.
They said they had a guy that over torqued them. I was like, oh yeah, that's nice. It's got 900 pounds of sand in it. Hopefully it doesn't work there anymore, but it doesn't help.
We've been having a lot of problem with Pentair equipment across the board. Controls, had bad controls, flooded a basement this year because of an actuator, bad actuator. Wasn't supposed to rotate past 180 degrees. They said it couldn't rotate past 180 degrees. Well, it did, and it deadheaded the pump. Put 30,000 gallons in a basement this spring. Still working with them on that. Their spa site controls are terrible.
No.
Their shipping is the worst. I mean, I've been pretty happy with Hayward.
I thought you switched to Hayward. What were we talking about Pentair
I've been
for?
pretty happy with their shipping. And if I need something, I call Jason and it's there the next day. Like I call Jason the Bruin like 3 times a week. He's probably tired of hearing from me, but he gets it there.
I mean, any other, speaking of Hayward, I mean, I know there was a lot of change to Hayward. Anybody have a good story about that?
We switched this year and I've been absolutely pleased.
I mean, are they still working with the group really good?
We're doing a nice job.
They support, they offer a lot of really good support.
They have the
And
best
our reps
customer
are awesome, so.
It's not even close. And I loved my rep before.
who is our rep?
I'll tell you what, their lights are a lot. Their lights are. I prefer their lights to Pentair's lights. I think Hayward makes a much nicer light.
Are you using all inch-less or using?
Both. Both.
How do you feel about the plastic?
Are they still making the full-size plastic ones?
I like the colors. Their light does more colors. It's a better white, a truer white, and it's a brighter white.
But are they making the full-size plastic thin niche that doesn't need
Yeah.
foaming or thin light?
That-
I've installed several of those and they failed.
Those things fall out.
Yeah.
I don't really.
Yeah.
You gotta lock
drop them in. I
Couple of
put
them
them in
got
a
water
commercial
in
pool
them,
this
too.
year, but if you turn them far enough, I was like, well, that would have been helpful to
I
me.
was
You
told
gotta clip them.
But once I clicked them in, they were fine.
Yeah.
the Omni system is untouchable in comparison to everybody else. And it's so much easier to teach a client how to use it.
What were you, Josh? Were you Andy?
Yeah, and I wasn't unhappy.
Did you try the IntelliStar versus the Omnis?
No.
There's no comparison between the Telefone and
No,
Omni
yeah.
is still much better, I
I
think.
couldn't even call them if I wanted to.
In my market, there's no Hayward stores.
Never called them.
Zero.
You're a Jandy.
Yeah, I was really happy with Jandy, and they just, I mean, speaking really honestly, the deal they made me on a rebate was unbeatable. So
Hayward.
Hayward, yes, excuse me, Hayward. And so they gave me no option, and I was really concerned about it. And I've been really happy with and we haven't had any lag times with their shipping, just because there's a lot of stuff's made in the United States. And if I needed something, I have an advantage. Our rep lives literally like a mile from my house. So, I mean, I hang out with him, like, and I did before, and so he just takes care of it. But I've been really impressed with the product, and I was really worried about the quality of it, but it's been fine. Everybody's stuff breaks. It's about how they respond to it.
The equipment doesn't feel as substantial as Pentair's, but it's worked. We've made the switch. We've been really happy.
The heat pump looks like it's gonna fly away. But it works really well, and it's like significantly quieter, and ultimately, I was really concerned about how it looked and all these other things that I was concerned about, and my customers could care less.
They don't care.
It's like Pepsi and Coke. They're like, it tastes great, it's fine.
That was my whole point to Pentair that they never heard was we make the market. Their sales reps, no offense, we sell the equipment, not them.
Right.
My customers don't care what goes on the slab. My competitors that sell their pools based on equipment, like, that's a joke. It's a complete joke. 3-year warranty on the equipment. Big deal.
All right. Anybody got anything else? Another topic? Anybody want to bitch about something?
Anybody,
Throw me. What
did
are you doing
anybody
for
get
Romy?
the PPP loan, and has it been forgiven yet? If we've got it,
No, I don't think anybody knows how to do it.
process?
Nobody knows how to forgive it.
I started the process, it wasn't that bad.
You've already submitted?
Mm-hmm.
The count seems like it's.
We end up, I think,
It's still unclear what it's gonna be, whether they're gonna count it as income or not. 'Cause I'm
As of
actually-
right now, they
and-
are.
And it's even more unclear if you're trying to renew your contractor's license at the exact same time. Because it's like, they don't know how to, whether they count it as like equity or income.
Right.
And then you throw like 3 accountants in, and they're like, we don't know. And I'm like, this is equity.
It also depends on what you claim, whether you claim payroll, whether you rent, retirement benefits, like we only claim payroll.
Yeah, we did. That's all we did. We burned through it through payroll.
Right. And as long as you satisfied your 75% of last year's payroll, you'll be fine.
Right now, it looks like even if it's forgiven, at least it counted as taxable income
Right.
for the IRS, which is,
I mean, they're gonna change the goalposts. It's what the
Yeah, but for
government
people,
does.
for you folks
well,
that
it's
got
not
to
what the
stay
original
open,
intent
it's
of
like
the law was, but
found
that's what
money.
the IRS is interpreting.
Yeah, well, and that's the thing is,
We'll see what happens.
we had
Like we were
1 month.
shut down.
Yeah.
We needed it, but for the folks that stayed open, it's like for most of the people in this room, it's free.
I didn't take.
Well, yes. You can't complain about free money.
Right.
Well, I mean,
anything else? Who said something? John, would you mind come up here and just give us a rundown of UAG staff changes?
We don't have that one.
doesn't look a joy.
I mean, you can sit right
I prompted him last night.
Stay comfortable.
He understands that it's coming.
No, I gave him 24 hours to think about how he's going to do it. Huh?
What's changed again?
I talk loud.
That's fine. Well, I mean, I don't know again.
We have a stats thing up our website because most of it's up there, but, and, I don't want to forget anybody. So, because it's sweeping changes, depending on how far back you look, the changes just continue as you go further back. So I'm going to take the last, say, 12 months, because that's really since February, we all saw each other there. That's the big changes. So in February, you got to the new IT team, right? Nothing's changed in that IT team, and I'm here, and Zach is more than proud to announce they've accomplished every goal they set out to do. So this delayed year on year of we're going to get it, we didn't get it, they actually did it. It's fully functioning. There's a number of members using it. Millions of dollars are being transacted through the new website, and you're going to see it probably in a week and a half. It'll be live to you from what Zach is telling me. So the IT team is made up of Zach, who's the guy in the big red shirt in the back, and then you have you have a few other people. You have a guy named Travis, who does our help desk. You have Joe, which falls in the IT team, but he's more of an operations person. He was brought on by Kevin, our CEO, to more or less guide all these departments and bring them together, make them kind of talking together. We were very siloed, meaning member care did what they did, accounting did what they did, sales did what they did, and no one really communicated. Joe is the facilitator to bring it back together. So yeah, that's Joe. Smart kid, just got his master's degree. Married, has a lot going on. Carla was hired. You know, if you remember in the past, we always had Watermark, and a girl named Natalie did that. She was rather expensive. She was let go. Carla was brought in. Carla has taken over the marketing. And, you know, UAG's like any company, there's a while it takes to get acclimated and get familiar with what you're looking for and how it works. I will say Carla has acclimated well, and the product she's kicking out right now is very good. From our presentations to our social media presence to just about everything she's doing is very solid. Scott is a newer hire. He was brought in as sales in the West. So you might remember someone named Aaron. Aaron was let go well over a year ago, before conference last year. The position remained open for a while. I was covering the West Coast, and we hired Scott. So Scott has a long history in the pool industry. Ironically, our whole sales team, myself, Scott, Kyle, and then Craig, our vice president, we all came from the same place. We all came from Zodiac. And Scott and I have worked together for years, as I have with Craig and Kyle. I never really worked with, but we all have a big history together. Kyle covers the Southeast. He lives in Florida now, and he moved recently. Renee in member care, she's the manager there. You might remember Jane. This is about a year and a half ago. Jane was let go. We moved Renee up. Renee, personally, from the inside out, is doing a phenomenal job. You may not experience a phenomenal member experience, but it's simply because she is coming from a very broken position, fixing it and moving forward. From where I sit, she's very accountable. She holds her people accountable, and the progress is amazing. We will get there, and I think she will take it there. It's a very strong guy. Zach, we'll go to Craig. Craig's the vice president. He's been around for a couple years.
Not my favorite.
George, you all know, he's your money man. Rosalind, she was hired as a CFO. She comes from the medical industry. She has been there 5 months, maybe 6 months, and she has the largest department in her company. Of the 31 employees, 11 of them are represented in accounting. And we'll talk about the elephant in the room. Accounting's a freaking mess, all right? You're probably getting invoices all screwed up. I mean, my phone rings off. I probably had 7 calls today on accounting. It's a mess. Now, part of that's related to what her department's going through. Part of it's related to our software. I had a call today from the vice president of Zodiac. He said, hey, I got this member of yours who placed an order with you, and we never got it. What happened? It's our software. We get lost. Between one software and another, it gets lost. That all goes away November 1st. But those things are happening. It many times falls back on accounting, or it falls back on member care. Their phones are blowing up. They're doing everything they can to get on top of it. I believe she will take it there. I believe she can get us where we need to be. But yeah, it's a mess right now. There's no question about it. So she's diligent. I talked to Rosalind a couple times today. Her follow-up is good, where she's like, I'm after this, I'm after that. We're getting this done. We're working with this member. We're solving these problems. But the problems are immense. You just have to understand there is a pile of problems right now in accounting. And it's all kinds of different things going on. So she's after it. Kevin, our CEO,
He's been there about a year and 2 weeks, a year and 3 weeks, something like that. Kevin, if you did get to meet him at conference last year, came from the the electrical distribution industry. And Kevin brings a lot of success into UAG. He's not a pool guy, so he spent a year learning the pool industry and trying to understand, how we work, because we're unique. We all know we're unique. That's why we're here. And he's doing a lot of comparison between where he came from and where we are at. He has a pretty good vision on where he wants things to go. It doesn't always align up with the board of directors or with sales guys who are very opinionated, but he's got his thing and he's driving it out. And he's got a pretty good command of the office. So if I measure where we're at today versus a year ago, and recognize I've worked for a number of companies, some of them dysfunctional, some of them very functional, I would say we are way ahead of where we were a year ago. And I'm a very honest person. I would tell you if it wasn't, but I think we are making great progress. You will see it. I mean, it has to be fixed before you see it. You will see it in the next 6 months. You'll go, okay, it's coming. They're getting their act together. But it's a challenge, no question about it. We're getting there. That's the changes. So this talks about the people who are there. It doesn't necessarily talk about the people who aren't there. If they're not on that board, they're not there. So it kind of goes that way. In accounting, there's a lot of changes there. We go from temps to full-time. Same thing in member care. We've had a lot of movement in member care where people are kind of coming and going. You might remember Pierce. Pierce left and went to work for a member of UAG. That didn't work out. He's very recently unemployed. I talk with Pierce often. Whether he'll come back to UAG or not, I don't know. Either you loved Pierce or you hated Pierce. I tend to be on the love side. I think he was a very good member care person. It's a matter of getting the right people and holding the right people. We lost some people in accounting that were very good recently. It's just a loss. It happens. And so we're diligently trying to put the systems in place that people love their job and stick around. Oh, we have a new HR director. Is Diana up there? Zach? Is Diana up there? I didn't see her. Okay, so there's a new director of HR, Diana, and I don't know her last name. Thank you. So you'd say, why does UAG need an HR department? Well, because we keep hiring and firing people, I guess. But anyway, I'm being sarcastic. No, it's a matter of trying to put in place systems. We've been doing HR, and Sandy had been doing it, but Sandy had a number of other jobs. And when you're doing HR, there's a lot of legality issues. There's a lot of systems that we put in place. Like, sounds crazy, but 37 employees ought to have evaluations. They ought to celebrate their birthday. They ought to, just do these things that are important to employees, about being acknowledged and things like that. We weren't good at that. So, as having an HR director, she puts those things in place and gets things moving along to where we don't lose that layer of employee who just didn't even feel like they were acknowledged. They didn't feel like they mattered. So
We get it, John. We're dealing with the same stuff.
Okay, all right.
Scaling our business.
Because when we were hired, Diana, I was the first one to say, okay, we need people in member care. We need people in account. We don't need an HR director. We don't need it. What are we doing? And so someone sat me down and said, well, this is why. I'm like, okay, all right, makes sense. So, I will say at UAG, as a salesperson, we're allowed to have a voice. They don't always listen, but we bark pretty loud. We have opinions, and we've been around the industry a while, so we tend to voice it. And Kevin's been patient with us. I've had many meetings in his office where he sits me down and he's like, let me tell you a bigger picture. All right, yep. I live on a little island in Michigan, and I don't know the big picture always, so it just goes that way. And that's probably my message to you. There's a lot of good stuff going on. There really is. And people working crazy long hours, I'll tell you that. COVID, a lot of times you think when COVID happens, we all were working remote, we get to work less. It did not happen at UAG. We're all given secondary assignments, and I mean, I just not exaggerating, a lot of 60, 70-hour weeks, week on week on week on week. It was just, everybody's jamming through. And we're still doing it because if you talk internally, we feel short-staffed. We're not. From a numbers perspective, a profitability perspective, we probably need to trim people. But from a servicing you and giving you a great experience, we're short-staffed. We're not getting it done yet. So I don't know if throwing people at it is the answer. Definitely improving systems is the answer, so we're about it. So a lot of us are putting in crazy hours, but that's what it takes for now until we get to the goal. UAG questions?
Sure.
I mean, is there anyone
And
that
I didn't mean to put you on the spot. It's just, that's one thing that,
Anybody just need to vent? I mean, if you do, now's a good time. You got a beer in you. It's a good time. We can do that. It's all right. Okay. Good.
All right, thank you, John.
You're back.
All right, so that's all I've got for today. If anybody wants to go back to the hotel right now, I can get a shuttle together and you can go.